Hello students, welcome to Vedantu Neet English. I am Miss Gopika, your biology master teacher. I hope all of you are ready for human physiology. So we are going to do a quick revision of human physiology, especially 3 chapters: locomotion and movement, excretory product and elimination, and your body fluids. This is the most asked chapter, so I took a poll from students and finally they have agreed. So can you all see me, hear me, see the presentation, everything possible? Yes or no? Yes, ma'am is here. Finally, ma'am has arrived. Okay, I just finished a live, so you people should give me like 2-3 minutes break, yeah. Too much you people are becoming nowadays. Come on, fire in the chat box. Don't tell fire, fire, fire. Put fire emoji in the chat box. Everyone is like fire, fire, fire. Okay, ready? Full energy? Yes, okay, great. Chalo, let's start. Okay, so students, let's also see the weightage of these chapters. All these chapters, we can expect at least 4 questions from this chapter. So 16 threes are, please do maths. Okay, you will do the maths. Okay, so you'll get 4 questions from this chapter. 48 marks, students, you will get. Okay, 48 marks you will get from this session. So I'll be using my previous notes. So we will try to understand. We'll try to break down NCERT. So keep your NCERT in front. And if you have attended previous sessions with me, keep your notes also. Quickly share the link. Okay, quickly share the link with all your friends. And we will start. Are we ready? We have Diksha ma'am and Baswa sir in the class. They are going to forcefully listen to the class the whole time. Okay. So yes, it's Ugadi special episode. Come, Diksha ma'am, let's ask her what is locomotion.
Oh yeah, that. Hi everyone, this is Diksha Kaushal, your chemistry master teacher. And what is locomotion? That is movement of
Shoulder,
tendons and bones and all that.
Did she say tendon?
Thank you.
Yes.
What is tendons? Like the
bone to
the joint.
Bone will be attached. Muscle will be attached to the bone. No, that connection is called tendon.
Movement?
That is tendon.
That is rigid.
See, this is locomotion.
You dance, ma'am.
Yeah, you dance. That is locomotion. Okay, this is movement. That means you stay in one place and just move, body posture changes.
Do you know how to dance?
Yeah.
Okay, so you're doing locomotion. When you're dancing, you move around, right? That is locomotion.
Just learn new
Yeah, new steps.
That is my dance. Every good dance now. Every dance.
And she's learning yoga and all that.
Yeah. So don't reveal. Okay,
That
so
is locomotion.
yes, thank you so much. She gave the introduction for the chapter and Baswa sir also gave the introduction.
Bye, guys.
Bye.
Okay, let's start the class. Ready? Steady. 1, 2, 3, go. Yeah, I know you people cannot confuse me this time. I have written that and come. Okay, all locomotion and movement and everything. Let me see if you have all marked the attendance. I cannot see the attendance. All of you. Wow, such a nice number. 111. Let's manifest that we crack NEET 2024. Okay, so students, locomotion and movement. Just what Sir and Diksha ma'am showed was locomotion. That means if I move, right, if I do displacement, basically if I do displacement, that is called as locomotion. That means displacement has happened, right? Physics term, displacement has happened. Now, what is movement, ma'am? Movement means what? This is movement, right? This is movement, okay? So, that means no displacement has happened, okay? No displacement has happened. That's all is locomotion and movement, right? Thank you so much. Okay, so many are telling 3 legends. So nice. Okay, so students, quickly share the link with your friends. I need more numbers and I need all of you to like the session, share with your friends, because you know how difficult it is to break down human physiology. So we are going to try. Okay, yes, come on, fill the chat box. Okay, chalo, let's start. So last time this was the statement that confused me and everyone the most, and it was very like a prank. So I have written it. All locomotions are movement, but all movements are not locomotion. Make sense? All locomotions are movement, because when I'm moving, I'm changing the posture, right? When I'm moving, even though I'm doing something with my hands or legs. So all locomotions are movements, but all movements. Can I say this is locomotion? No, not at all. I'm just standing in my place. I'm moving my arm. So it's not. So, but all movements are not locomotion. Is this clear? Good to go? Fine. Now students, let's start the main topic. So even though we study in animal kingdom that locomotion is happening, cilia is doing something, flagella is there for some organism, amoeba is there, all this is there. But do you know that these things happen in our body also? That means we have some types of movement. So which are the types of movement? Very simple. We have 4 types of movement. In NCERT only 3 is mentioned, but I have told you one more, that is flagellated movement. Okay? Yes. So I want all of you to answer in the chat box. Please avoid any kind of messages with your friends because we have very limited time for Neet. So let's focus. How much of our time you're sitting in this class? Let's focus. Okay? Okay, fine. Look here. There are 3 kinds of movements. What are these 3 kinds of movement? Where is it seen? Very simple. First is amoeboid movement. Have you all seen amoeba? Have you all seen amoeba? So it is, right, the pseudopodia is there, irregular in shape. That is shown by our WBC and macrophages. Students, examples are very, very important. Okay, macrophages. These 2 people show amoeboid movement. Yes or no? These 2 people show amoeboid movement, and especially WBC shows something called as diapedicis. What is diapedicis? That means if there is a wound, this WBC will squeeze out. Right, this WBC will squeeze out, go and cure that, right? So that squeezing movement is called diapedicis. Good to go? Very good. Then we have ciliary movement. That means hair-like structures are present. Some things have to be moved, some things have to be retrieved. That kind of movement is shown where, students? All of you tell me in the chat. It is firstly shown in your tracheal lining. Tracheal lining, right? We studied this in breathing. Then also in the lining of your fallopian tube. Okay, lining of fallopian tube. Okay, lining of your fallopian tube. These are the 2 types of movement. Then we have flagellated movement. Flagellated movement means what? Moving like this, right? Zigzag, zigzag, zigzag. It's continuously going. That is only shown by one person, that is our sperms. Right, that is sperms. Sperms are the only one that show flagellated movement. Good job. Awesome. Very good. Okay. Yes. Very good. Now, muscular. Everything that we do is muscular. Muscular movement. Everything. My muscles are contracting, relaxing. Contracting, relaxing. All of this is muscular movement. How many muscles are there in our body? All of you in the chats. All of you in the chats. How many muscles are there in our body? How many muscles are there in our body? Okay, so this is what we understood in the starting part. Yes, very good, awesome. 339 muscles are there in our body, and that's why boys go to gym and nowadays girls also go to gym. That is to build their muscles, to show off in front of their crush, because muscles they need. Fat is not required. Our body 40 to 50% is covered by muscle. Okay, so to build that muscle, to modify that muscle, people go to gym, people do yoga, people do multiple things. Yes or no? Right? Very good. 369. Now, students, what are the properties of muscles? Why do I say that muscle is so important? Muscle is so important. What is the property? The property of muscle is basically 3EC. That means, what did I say? E or E cube C. Okay, this is the property of muscle. Very simple property of muscle. All of you, again, in the chat box. Okay, let me see if you all like the session. No. Okay, you people haven't. Yes, people eat protein, right? Whey proteins and supplements and all of this is because they want to build a muscle. Okay, yes. Did I write wrong? 339 I've written correct, no? 339. Don't confuse. Yes. Students, what is the property of muscle? First thing is the ability for them, extensibility. What is it? Extensibility. Second thing is elasticity. Third thing is contractibility. Contractibility. And the last thing is what? See, extensibility is there, elasticity is there, that means the ability to stretch. Then what is there? Contractibility is there. I want all of you to tell me in the chat, what is the last one? Excitability. Right? Excitability. Correct? Okay. So, EEC is the property. Let's just go through the property. Extensibility, that means the ability to extend or stretch, right? The ability to stretch is called extensibility. Then elasticity, that means for them, the ability for them to be a little flexible. Little flexible is the, see, look here, passive recoil, that means elasticity is there. Then the third thing is contractibility. Main thing for muscle, why do we talk about sarcomere? Why do we talk about myosin and actin? Because that is what does contraction, right? And then we have excitability. That means if any impulse is coming, right? Any impulse is coming from the axon, the muscle should be able to react depending on that. Okay, Gopika is telling she need to run. So that excitability has to come. Okay, right? Got it. Fine. Now, types of muscles. How did this category actually come? Very simple. Types of muscle was actually done based on their location. Based on what? Based on their location. So based on location, muscles were divided into three. What is the three categories of muscle? Very simple. We have cardiac muscle, skeletal muscle, smooth muscles. I'll tell you why I put this image, because with this image we can write all the properties of muscle. So with this image we will be able to write all the properties of muscle. I want all of you to keep your notes in front of me. If you're new to this session, try to learn it with me. If you've already watched my locomotion and movement before, just keep your notes and go through your notes. Okay? Yes, very good, very good. Three types of muscle. Again, we can remember it as SSC. Okay, we remembered EEC, SSC. Okay, awesome. My students are the best. Okay, so students, look here. We have cardiac muscle, skeletal muscle, smooth muscle. Who is the hero of this class? Skeletal muscle is the hero of the class, right? Because skeletal muscle is the one who is going to do all the locomotion and movement. All the locomotion and movement. Okay. Is this voluntary or involuntary? Obviously, if they have to do locomotion and movement, my muscles should be, they should listen to me or they shouldn't listen to me. It has to be voluntary or it should be involuntary. All of you in the chat box, it has to be voluntary or it should be involuntary. All of you. They're telling Sri Chaitanya school and all. Wow. Come on, fast. Skeletal muscle. Very good. It should be voluntary, right? It should be voluntary. That means it has to listen to me to do locomotion and movement. Now, just look at this muscle. What do you see in this muscle? Do you see any striation in this muscle? Do you see any striation in this muscle? I do see striation in this muscle. So that means these are stripped or striated muscles. Stripped or striated muscles. Okay? Striated muscles. Simple. So we studied the characteristic just by looking at this muscle. Its main function is locomotion and movement, okay, and it is voluntary. It is stripped or striated muscle. And where is it present? It will be attached from the bone, right? It will be attached from the bone. Yes, that's all. Now let's try to understand cardiac muscle. Okay, let's try to understand cardiac muscle. Yes. Now, cardiac muscle, what do you see in this muscle? Obviously, you know, this is mainly in the heart. Anything to do with cardiac is heart, right? And if I look at this muscle, I can see striation. But before that, what did I write there? Is it voluntary or involuntary? What is the function? It will definitely do diastole. That means relaxation and contraction in the heart, right? Relaxation and contraction. Contraction, relaxation and contraction of who? Of the heart, right? When you see your crush, your heart will be like duck, 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 right? That is because your cardiac muscle is doing some job, okay? So relaxation and contraction. Students, I'm only telling this, okay? Yes, it is striated and involuntary. Awesome. Very good. It is striated. Okay, it is striated and it is involuntary. Very good. Very good. Awesome. Okay. Did we miss anything? Now, most important thing that I can see in cardiac muscle, that it is branched. I can see branching. So this muscle show branching. What does this muscle show? Branching. Got it? So we have learned two types of muscles. Students, it's important for you to know about the muscles. Even though your textbook has mentioned only here and there, you should know the muscles. Okay, you should know the muscles. Okay. Don't talk. What is this? People talking in the class. Okay. Yes. Can you see that? What is happening? This you just have to know the basics, okay? You don't have to know the depth of cardiac muscle. You only have to know this much. If it is, what is its function? Is it striated? Is it branching? Is it involuntary? Voluntary? That's all. That's all, okay? And it is branching. Now, the next hero of our class, who is that? Who is the hero of our class? That is smooth muscle, okay? As always, ma'am does not have place, okay? So, shall I write like this? Yes, okay, it has taken full one over. Smooth muscle, okay? Tell me about smooth muscle. I know that smooth muscle is also called as visceral muscle. What? Why is it called visceral muscle? Is because smooth muscle line your visceral organs, internal organs. Can you see here? It is lining the visceral organs. So, smooth muscle lines the visceral organ. One more thing that I am noticing, it does not have striations. So, it is not striated, right? It is not striated. Next thing, what could be its function? Its function is to transport food or gametes, right? Last time also we wrote this. Transportation it is doing. It is helping for transportation. Then students, do you see branching? I don't see any branching. So, no branching. No branching. Then, very, very important thing that I see about smooth muscle is that it is fusiform in shape. What is fusiform? Okay, look at the shape, students. See, look at the shape of it. It looks like momos, I can't tell. Do we get momos like this? No. This looks like that sweet we get for today's Ugadi. I think Ugadi also people make this sweet where they stuff in some sweet and they give, no, like this one shape. I don't know what you call that, yeah. I've eaten it. Okay, I've eaten it. So that it looks like that sweet, right? It looks like that sweet. Can you tell the sweet name? Yeah, it looks like sickle shaped. Your sickle cell anemia, your RBCs will become this. Kaju? No, people are doing Kaju Barfi. Kaju Barfi is not that shape. Kaju Barfi is, what is that? That shape. Okay, Kaju Barfi is this shape, no? Something like this, students. Kaju cut. These people are something around this people are telling students fusiform. Let's focus on fusiform. You should never trust my students. Okay, they'll let something and all. Okay, fusiform shape. And these two are cylindrical shape. These two are cylindrical shape. So let's do a quick revision. We studied types of muscle based on their location. Okay, what is that? What is that muscle? Visceral organs means internal organs, dear, internal organs, that's all. See, what are the types of muscles we studied? We studied based on location. There are three types of muscle: cardiac muscle, skeletal muscle, smooth muscle, SSC. Okay, in that, this chapter is completely focused on skeletal muscle. Okay, so we started with skeletal muscle. We know that it is present or it is attached to the bone and it does locomotion and movement, voluntary inaction, striated muscle, and it is cylindrical in shape. Okay, and no branching. Then we studied about cardiac muscle, which is present in the heart. It will do diastole and systole or do relaxation and contraction, and it is striated, involuntary, branching is there, cylindrical in shape. Most important thing is it is branching. Okay, now smooth muscle, it's a visceral muscle, not striated, helps in transportation of food and gametes, no branching. And the only muscle which is voluntary, all of you in the chat, the only muscle which is voluntary, go for it, only muscle which is voluntary that we studied. Yes, all of you. Nucleus is not required here. How much is required only we are discussing. Okay, there's a lot about these muscles. If you go and learn in the depth, there's a lot about these muscles, but that much is not required for your syllabus. Why are you wasting your time studying unnecessary things? Let's focus on, very good, skeletal muscle is the, okay, skeletal muscle is the voluntary muscle. Okay, thank you, Shri. Okay, see students, I have just written my notes. I've just given the notes. So you can see that skeletal muscle, bone, stripped, we did this movement, voluntary, branching, cylindrical. Heart, stripped, diastole, systole, involuntary, this is branching. Okay, the tick mark is for branching. Branching is the cylindrical. Okay, visceral organ, not striated, transportation of food and gametes, involuntary, no branching, fusiform and shaped. Okay, good to go. Now, next most thing, skeletal muscle structure. Okay, let's draw the skeletal muscle structure. Very, very important topic. Okay. Last time also I drew, but still we will draw it once again. This is your bone, Tom and Jerry bone. Okay, Tom and Jerry bone. Now we'll draw the muscle. Okay, all of you, if you have already drawn it, just look at the diagram. See students, I have drawn a bone and a muscle. The bone and the muscle, what is that attachment called? The muscle is attached to the bone. What is that attachment called? It is called a tendon, right? It is called a tendon. I'll label it here. Tendon. Okay. Now, this is a muscle. Okay, muscle has striations. That also we know because of the myosin and actin. Light, dark bands are there. Right? Light, dark bands are there. Now, in the muscle, students, all of you need to know that there are muscle bundles. What is that? Muscle bundles are there. So, let me draw some bundles. 1, 2, 3 bundles are there. Okay, and I'm attaching that bundles. Okay, bundles are there. Now, what is this bundles called as? These are called as muscle bundles, or in other words, can anyone tell me in the chats? Muscle bundles, or called as fasciculi. What is it called? Fasciculi. Did you all type it in the chats? Yes, bone to bone is ligament. Here, what are we talking about? Tendons. Right, students? Tendons. Okay. Muscle bundles are called fasciculi. Got it? Now, inside this bundles, okay, inside this bundles, there are something called as muscle fibers, or normally muscles, it is called fibers because it is long and slender. Okay, it is long and slender. So, I'm going to draw here. See, I'm going to put just dots. Those are muscle fibers. Okay, why is it called fiber? Because, see, they'll be long and slender. Only one I'm drawing bigger. Can you see? It is long and slender. Like if I remove one, it will look like the chopstick. Okay, it will look like a chopstick, or it will look like a long French fries. Okay, so if you think, see, if you think this is a muscle bundle, can you all see this is a muscle bundle? This will be how muscle fiber will be. This is how muscle fiber will be. Okay, okay. How many marks will come? 16 marks. Can you see? This will be muscle fiber. It will be long and slender. Okay, long and slender. Don't get it confused. Fascia and fascicula is that. Do not get this confused. This is fasciculi. Okay, fasciculi. Is this clear? Yes. French fries. Yes, French fries. Okay. Okay, got it? So, we have muscle fibers, muscle bundles we learned. This is called as muscle fibers. I am labeling it with the same color, so it will be easy for you. Okay, it is called muscle fibers because they are slender and long. I am writing here because they are slender and long. I'll show you the image, don't worry. I'll show you the image, don't worry. Now, students, we saw this. Now, I want to hold all these muscle bundles together, or your fasciculi together. What will I do? Because the term is fasciculi, the muscle bundles will be attached with the help of fascia. How will it be attached? Fascia. See, these muscle bundles will be attached to each other with the help of, students, you can tell fascia, fascia. If you are a British, you please put it up like that. Fascia. Can you see the spelling? Fascia. Okay. So, that means very simple. Let's go once again. There is a bone, there is a muscle. To the bone, muscle is attached like this. This point is called tendon. Okay. Now, there is muscle bundle. There is like muscle bundle like this. This muscle bundle is called fasciculi. Okay, this muscle bundle is called fasciculi. In that, can you see this pen? Can you see this pen? Okay, I think I should take another color pen, no? Yeah. See, this pen is there. This is the muscle fiber. Okay, like this it's extending. This is the muscle fiber. Okay, so this is my fasciculi, muscle bundle. In the muscle bundle, what will be there? Muscles will be there. In that muscle, I can call it as muscle, or I can call it as muscle fibers because it is long and slender. Now, there are many bundles like this. I need to keep all these bundles together. For that, I am using fascia. That's all. Okay, this much is clear. Fine. Now, we have to learn the covering. What we have to learn? Covering. There are some people to protect these people, right? Now, to protect this entire muscle, there is a covering. What is that covering called? All of you know. It is called as epimysium. What is this entire covering called? Epimysium. Students, if you understand this, no, everything in this chapter will be easy. If you understand this, everything in this chapter will be easy. Okay. Haha. Okay, got it. Awesome, awesome. Now, so what did I tell? This entire muscle is covered by a covering called as epimysium. Okay. Now, the catch is here. Let me use some other color. Now, can you see these muscle bundles are there? I need to protect the muscle bundles also. So, I'm going to cover this muscle bundles also. I'm going to cover this muscle bundles also. And that covering the muscle bundles, what will be it called? Perimysium. Perimysium. That means perimysium will be covering the muscle bundles or your fasciculi. Okay, got it? Epimysium covers the whole muscle. Perimysium covers only the muscle bundle. Then we have to protect this muscle fibers also. We cannot be like, oh, you are muscle fiber, so I will not protect you. No, we have to cover the muscle fiber also. To cover the muscle fiber also, we have a covering. Okay, see, I'm drawing it here. You cannot see that much, but yeah, you can see the blue. It is called as endomysium because it's completely inside. It's called endomysium. Okay, got it all of you? Clear? Yes, very good. Endomysium is the one that covers the myofibril or your myofilament, or just simple words, muscle fiber. Okay, simple words, muscle fibers. So students, look here. See, best diagram. What do you want more than this? Just learn this diagram. That's all. You want a revision? I'll only tell you about the covering. The entire muscle is covered by epimysium. Muscle bundles are covered by perimysium. Okay, and muscle fibers are covered by endomysium. Got it? Easy? Okay, fine. Look here. Can you see this diagram? So this is what we are going to understand. See students, this is what I spoke about. This is how your entire muscles will be arranged. Okay, they're all cylindrical, so they'll be arranged like we are keeping so many stacks of pen together. Okay, so many stacks of pen together. If I arrange like this, how will it be? I don't think you can see, but yeah, so many stacks of pen like this will be arranged. This is how. So in that one will come like this. This will be a muscle fiber. Okay, so that is how this is arranged, and in that only you can see there is sarcolemma. What is sarcolemma? That means sarcolemma. What do you get from the term sarcolemma? Can I tell it is the plasma membrane of the muscle? Yes, ma'am, you can tell it, right? Because whatever you tell, we will listen. Okay, it is the plasma membrane of the muscle. Sarcolemma, right? Then we have nucleus, you have mitochondria, you have myofibril. Myofibril means this contracting factor. This entire muscle has many myofibrils or myofilaments, and this myofibrils will be made up of two things. What are they? Proteins, myosin and actin. Okay, got it all of you? Then you can see this is one covering. Can you see this one covering? Entire muscle bundle is covered, right, with the perimysium. Okay, yes, very good. Then we have sarcoplasmic reticulum or endoplasmic reticulum. In endoplasmic reticulum, who will be there? Calcium storage is done by this people. Okay, so endoplasmic reticulum will do the calcium storage. So is this much clear, students? Yes? Yes or no? Yes, very good. Myosin and actin. Okay, myosin and actin. Students, thoda pani chahiye. 1 second. One second. Yes, okay. Fine, got it? So here, this is done. Now, look here students, an amazing image is there. Now, you will label with me. You will label with me this image. What is this? What is this whole thing? All of you, fast, you have to answer. What do I call this? Okay, this is your question number 1. Okay, what do you call this? Okay, let's not put that. Yes, what do you call this? Okay, then what will you call this? What will you call this? That is 3, no? 4, 5. Can you try labeling with me? Let's try labeling. I've studied too much Hindi, no? Wait, I have to show them action. Baswa. They're not listening to me, students. So I will go outside and ask. Yes, very good. By then, answer quickly.
Bring it back. Bring it.
Yes.
Did you all answer? Thank you.
So guys, we have got water. We water for Gopika Ma'am.
We have got water for Gopika Ma'am.
Exactly, ma'am. Gopika Ma'am, please drink some water, ma'am.
Bahubali. Yaar even.
Ma'am, drink some water.
Ma'am, now if you don't finish this, we won't go.
You have to finish this now.
Yeah.
Finish the water, ma'am. You're asking for water, right?
Wow, Shreyas.
Yeah, please, water. Like, okay, take this.
So you're showing the muscle strength here.
Oh my God.
Structure the muscle strength.
Students, what do you do when you have a team like this? I asked water. They're doing revenge. Oh my God. My stomach is hurt.
You didn't expected this.
Guys, there should be a meme on this. Yeah. Come on, please.
Students, muscles. Students, use of muscles.
Okay,
Yeah.
Diksha ma'am, can you lift this?
I can.
Okay, let's see.
Let's see how the muscle contraction. Let's see.
No,
Pakka, no,
but breaks and this will be all water. Oh my God.
Look at the strength.
She's collapsing like, oh my God.
Okay.
Can you lift?
Yeah, shouldn't I lift?
Epic fail.
Okay.
Okay,
Yeah.
Gopika ma'am, come on.
Gopika Ma'am, come on. Use the muscle contraction, ma'am.
Yeah.
Oh my God. Oh, on the gym front. On the gym front.
Oh my
I
God.
have to try it again.
Oh my God.
Okay.
Oh.
Yes. Bahubali.
Bahubali. Bahubali.
Oh my God. Students, never ask water in the class. They've got.
Next time if she asks for food, we'll get a farm.
We'll get a formula. We'll take one.
Like Hanumanji.
Hanumanji, pahad utar.
We'll take the whole mountain and come.
Okay, now then you continue. Okay.
Yeah, thank you. I don't know.
Let us know, ma'am. Let us know. We will get you more water.
Hold.
Now I should...
Oh God, I can't. Students, best team award goes to us. So, did you see the use of muscles? Okay, use of muscles. Did you see? Okay. Oh my God, I can't. I've literally laughed so much. Okay, students, let's try to answer this. What is this? This is the muscle that worked for Shreyas sir right now, right? We all worked, okay? Yeah, exactly. Not gym class, not biology class, gym class. Okay, gymnastic is done. Chalo, what is this? This is your entire muscle, right? This is your entire muscle. Fine. Inside this, if they have removed just one muscle, right? So, what is the one that covers the muscle bundle? All of you in the chats, the one that covers the entire muscle bundle. What is this? What is this purple color thing that they have mentioned? All of you, they are still laughing. I think they'll still keep laughing. Very good. See students, this is epimysium. This is covering. Forget about the covering. But yeah, I will write it here. Epimysium. Okay, epimysium, it will be actually a very transparent layer, like a plastic cover, no? It will be a transparent layer. So, this is your entire muscle. Okay, don't tell me they're coming again with water bottle. Yes, very good. This is the muscle bundle, right? What is this covering? Perimysium. Perimysium. This is the muscle bundle. Can you see the entire bundle? I can tell it as fasciculi. or I can tell muscle bundle. Yeah, why is this not writing? Fasciculi. Okay, I can tell it muscle bundle. Okay, muscle bundle. Fine. Then students, here what do we have? They have pulled out one fibrous, that is one muscle fiber they have taken. So this will be your muscle fiber. Right? This will be a muscle fiber. Any doubts so far? Any doubts so far? This chapter is rotation, thermodynamics. Locomotion, hello. Exam is coming in 26 days. You're asking which chapter? Thermodynamics. Okay, students, try to answer this. What is this? 4 and 5. 4 and 5. This is, see, this is your myosin, actin. Okay, myosin and actin. Any doubts? Right? Okay, great. So this is the labeling. With this labeling, you have studied the entire muscle. So you should understand when the diagrammatic representation is given, a muscle is there, one muscle bundle will be removed. From the muscle bundle, one muscle fiber will be removed, and from that one myofibril will be removed. What is this? This is actually your myofibril. Okay, myofibril or your myofilament. In the myofibril, what will be there? Many actin and myosin will be there. Okay, many actin and myosin will be there. Very good, awesome. My students are pro max. Okay, look here. So this is a myofibril. Okay, this is a myofibril. If I see the myofibril, it will have sarcomeres. These sarcomeres are basically made up of what? Very simple thing. Sarcomeres are basically the structural and functional unit of your entire myofibril, or the entire contraction unit is the sarcomere, right? The entire contraction unit is your sarcomere, correct? Now, in the sarcomere, what will be there, students? Mainly two people will be there, myosin and actin. Myosin and actin will be there, correct? Is this clear? Yes, very good, very good. This is the sarcomere. And how can I say it is a sarcomere? Sarcomere always starts from one Z line to another Z line. One Z line to another Z line. Okay, I'll teach you Z line, all that. Don't worry, just understand. We studied myofibril. Myofibril is mainly constituting actin and myosin, right? That is what this arrangement is. Now, this is what you're going to study, how your muscle contracts. When I lifted the can, my muscle contracted. I tried to push, like I tried to hold the weight. That means what happened? My muscle has contracted. Who helped in that? Actin and myosin helped in that. Okay, fine. Now, sarcomere. Let's try to draw a sarcomere. Okay. Now, I'll teach you what is Z line, M line, all of that. So, first students, we will draw a myosin. Okay, we'll draw a myosin. This is the myosin is the thick filament. Okay, so we will write here also simultaneously. What is this? Sarcomere. Entire contraction happens because of your myosin and actin. Okay, and your myosin is the thick filament. Okay, thick filament, and this myosin is the one that is constituting for the dark band, for that striation. No, dark band is seen because of this myosin. Then what about actin? Actin is the thin filament. I told you that day also, tin, you remember? Thin filament. Okay, and this thin filament is giving rise to what? Light band. Simple, right? The light band is seen because of this thin filament. Tin, actin, tin. Okay. Biotechnology and principles will be done in your next block 2. I've already told that block 2 we'll do that. Okay, chalo. Now I have drawn a myosin, students. Now let's draw some actin also. Okay, let's draw. Very important sarcomere diagram. Very important. Draw it. If you have already drawn, just look at your diagram. Okay, this is a myosin. Okay, let's draw some actin also. This is an actin, this is an actin, this is an actin, this is an actin. Okay, fine. Now, To keep this actin in place, to keep whom in place? Actin in place, we have a Z line. Okay, many actins will be there. I'm just drawing two because it's easier to understand. Can you see? Two Z lines are there. Okay, then to keep this myosin in place, I will have a M line. I will have a M line. Let's also label simultaneously. Look here. So this is my actin filament. Okay, actin. What is this? Myosin. This is M line. This is Z line. This is Z line. Now what did I tell you? A sarcomere, I can say this is a sarcomere. That means when it starts from one Z line and ends in another Z line. That means between two consecutive Z lines there will be, that is called as your sarcomere. All of you got this? Okay. So from one Z line to another Z line. Yes or no? Yes, very good. Okay. Now students, we have to learn some bands. Okay, we have to learn some bands. Okay. See. Now, this actin and myosin, can you see how it is? This is your myosin, this is your actin. Okay, this is how it is. Okay, this is the myosin, this is the actin. Okay, that means what? They are not like, it's not only a region with myosin, there is actin and myosin, right? So, that region is called what? See, if I am labeling this entire region, what is this entire region called as? A band. What is it called as? A band. Okay, A band. That means an isotropic band. So, this myosin with actin will form an isotropic band. An isotropic band. That means what? Anisotropic means what? That means not only myosin is present, myosin and actin is present, or two different things are present. That is when we tell anisotropic, no? Now, this is your A band. Now, all of you carefully look. Here only actin is there. Here only actin is there. So, that means this region becomes what? This region will become I band. So, here one I band is there. Here one I band is there. I band. Okay. So, two I bands, one A band. I band is where? Caused by your actin. Okay. I band or your isotropic band. Isotropic band. Got it? Is this clear so far? So far clear? Yes, very good. Anisotropic means different, isotropic means same. That means only I bands are there. Okay, this much is clear. Now, very, very important students, the region where only the myosin is present, the region where only the myosin is present is called as H zone. What is it called as? H zone. Okay, this region where you can see only myosin, that region is called H zone or the Hensen zone. Hensen's zone. Is it visible to all of you? Visible to all of you? Can you see the H zone in the between where only myosin is present? Okay, myosin is present. Okay, H zone. Fine. Now, there is a region where actin and myosin is overlapping. Actin and myosin is overlapping means what? This is actin, this is myosin. They are overlapping. So, that region is called as the O region. Okay, this region O. See here you can see actin and myosin is overlapping. Here also an O region. Okay. So, O region is the overlapping region. Can you see myosin and actin is overlapping? This is the actin, this is the myosin. They are overlapping. That region is called the O zone or the overlapping zone, not the O zone. Okay. O zone or the overlapping zone. Okay, overlapping zone. So far clear? Very good, very good. O region or your O zone or overlapping zone. So, what are the things this we discussed? This is your entire sarcomere. Okay, this is your entire sarcomere. I'll try to put it in a box. Students, am I still audible? Yeah, this is your entire sarcomere. Okay, this is your entire sarcomere. One second. One second, you want me to say? O region is this region. O region is this region where the myosin and actin is coming overlapping. Overlapping. That is your O region. Is this clear? Okay, audible, no? Because I just pulled the mic. Okay, I just nicely pulled the mic. Yes. Okay, listen, students. Okay, yeah, fine. Let's go once again. Very simple. This is a sarcomere. That means from one Z line to another Z line. Why do we need sarcomere? Very simple, for contraction. Okay. Now, this pink line which I have drawn is an actin. Okay, this orange color big thick thing that I have drawn is myosin. We all know that myofibril is made up of many actin and myosin. Now, this myosin and actin are proteins which are going to help for contraction. Okay. Now, this region, this is myosin, this is actin. To keep your actin in place, we have a Z line or your zigzag line. Okay. And then to keep your myosin in place, we have an M line. This much is clear. Now, the region where both myosin and actin is present is called as the A band, an isotropic band. Okay, that is here, an isotropic band. Then, the region where only actin is present is called the I band. This much also clear? Fine. Then, the region where only myosin is present, where you can see proper thick filament, that is called as the H zone or Hensen zone. Okay, or Hensen's zone. Now, the region where myosin and actin is overlapping is called the O zone. Okay, O zone or overlapping zone. This much we understood. Now, when muscle contraction has to happen, like ma'am, I want to contract my muscle. What is going to happen? A band will be like, I will not move. Whatever you want to do, you do. I will not move. Okay. Have you seen in when we go for some places, when we go like for passport office or when we go for some Aadhaar card verification, there will be one lady or one man standing telling that I will not move. Even if the queue is moving, he will not move. Like that, this A band will be like, I will not move. You want to contract, you contract. How is that my headache? So, Papa, who will do all the job? Z line will do all the job. Z line will move forward. So, the muscle will contract. Yes, sarcomeres will reduce in size. This is one Z line, this is one Z line. So, muscle has to contract. A band is not ready to do. So, the Z lines will come forward. Now, the sarcomere size will reduce. Contraction will happen. Is this clear? Okay, is this clear? Fine. So, Z lines will move forward, contraction will happen, A band will remain as such, M line will remain as such. So, basically who is moving? This actin is moving forward, and that is where we learn sliding filament theory, right? Actin is coming and attaching to the myosin, then moving, again sliding, sliding, sliding. So, who is doing the sliding job? Actin is doing, because actin is moving forward, going backward, moving forward, going backward. Yes? I'm literally doing dance. I'm not teaching. I'm dancing and teaching. Yes, exactly. Okay. Actin and myosin love story is what we are going to learn. Now, students, I think sarcomere is done. Okay, sarcomere is done. Now, did you all like the session? Tell me in the chats if you all like the session. Now, here. Now, look here, all of you. This is the notes. Okay, very important. I told you A band, anisotropic band, I band, isotropic band, H zone, Hensen zone, O zone, overlapping zone. All the definitions is clear. Now, most important thing, if we just denote actin and myosin with the help of a dotted structure, how will they look? Very simple. Look here. This is myosin. Myosin is a three structure, right? Three combinations they are coming. 3 points are joining, 3 combinations. Actin is a 6 comma structure. Now look here, one myosin will be covered by 6 actin, or in other words, one thick filament will be covered by 6 thin filaments, right? So look here, one thick filament is covered by 6 thin filament. PYQ can be asked for this. So please write it down right now in your textbook or wherever you have a paper, write it down. Okay, one thick filament is covered by 6 thin filament, or in other words, I can say that one thin filament is covered by 3 thick filaments. Simple, right? Right? So, one thin filament is covered by 3 thick filament. Now, Next question for PYQ can come is, one sarcomere has how many A band and how many H band or I band? This question can come. So simple thing. One sarcomere has one A band and half I bands. All of you look here. One sarcomere, that means from one Z line to another Z line, it has one A band, one half I band, half I band. We cannot tell it full, right? We cannot tell it full because only one Z line is there. Half I band, half I band. So if I say one A band, one sarcomere has one A band plus two half I band, or in simplest words, one sarcomere is one A band plus one I band. That means one anisotropic band and one isotropic band. That means what? You can see the light and the dark striations on a sarcomere. Is this clear? Very good, very good. So students, if I draw a sarcomere, how will it look like? This is my muscle. Okay, this is my muscle. Okay, this is my muscle fiber. In that, there are going to be some myofibrils, right? Some myofibrils will be there. This myofibril, okay, one of them, if I take, right, this myofibril, if I extend, this myofibril, if I extend, what will it have? It will have an actin and a myosin, right? Okay, one myosin will be there, one actin will be there. Yes or no? One myosin will be there, one actin will be there. So now if you see this, you will understand how it is. Can you see? Myofibrils are there, many, right? In this, if you notice this sarcomere also, Z lines will be there. So here also students, please understand, there will be one light region, one dark region, one light region, one dark region, one light region, one dark region. This is how you will be able to see a striation. Okay? Got it. Let's go. Now, shall we start with myosin? Yes. Ad came. Achocho. Ad came off. I'm not stuck, no? Yes, 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 yes. Let me see. Let me see if all of you smash the like button. Okay, ready? Chalo, let's start. Okay? Sarcolemma means the plasma membrane. Sarcoplasmic reticulum means the endoplasmic reticulum of the muscle. That's all. That's all. Nothing to worry about. Okay? Nothing to worry about. Okay? So, sarcolemma, plasma membrane, sarcosome, mitochondria. You want me to write that? I will write that. Wait. Here I'll write. Don't worry. This notes also you'll get. Okay? See. Sarcolemma is who? Plasma membrane of the muscle. Okay? Next, sarcosome. Who is sarcosome? The mitochondria, powerhouse. Okay? Then we have who? One more, sarcoplasmic reticulum. Okay? Sarcoplasmic reticulum. Sarcoplasmic reticulum is called endoplasmic reticulum, which is a calcium storehouse. This is important for us to understand myosin and actin love story. We need this calcium, right? If calcium comes early, we can distract them. Okay, student, this is my notes itself. Okay, this is my own notes. So we can study with this. Now, structure of myosin. We know myosin is a protein. And it is also the thick filament. Okay, thick filament. Now, it is made up of monomer. And what is that monomer name? Meromyosin. The monomer that forms it is called meromyosin. Now, it is a polypeptide chain. I already told you it is a protein. So, it is made up of multiple proteins. So, it's polypeptide chain, right? Now, polypeptide chain means there is 2 long chain, 4 short chains. Where do you see it? Can you see? 2 long chains like your DNA helix, no? 2 long chains are there. Can you see this orange color which I have drawn? They are the 4 short chains. Okay. So, myosin has a globular head. Can you see? Globular head like a cobra, no? Like a cobra, it will be like this. Cobra head, globular head it will have. Now, let's try to understand this. This structure which you see is called the tail of the myosin. Okay. Tail of the myosin. Then, head is there. I told you cobra head. Now, 2 There was a name, no students? The snake with two heads, like this. You had morning some snake theory, you know, by Diksha ma'am. She invented a snake theory. Okay, so the snake like this. Okay, so like this, two heads will be there, and on both the heads, villain is coming. Okay, this is now love story, hero's entry has happened. Now villain will come, then heroine will come. Okay, actin is the heroine, myosin is the hero. Okay, if you don't like it, you would put it ulta also, no problem. Now you just have to study. I do not care what you think, like even if it's a story, I want you to study. That's all. Okay, so look here, these two long chains are called the tail. Okay, and then we have two globular heads. On the globular head, this orange color which you see is the short chain. Now you will be like, ma'am, like two eyes, what have you drawn two dots? Very simple. The two dots are, the purple dot is called the actin binding site. That means myosin likes actin, and there is a place for actin also in his head, not in his heart. Okay, we do not have place like that. This is not humanly structure. In his head, he has one place for actin. But one more problem is there. Who is sitting? His mother or his brother or anyone. Okay, father. Boys are scared of father. So father is sitting on his head also. And who is the father? ATPase is the father. Until ATP moves, actin cannot come and bite. This is the saddest love story. Okay, saddest love story. Ha ha ha. Actin. Okay. Yes. Got it? Which language are you people talking? Yeah. Yes. So now, let's understand once again, meromyosin is the monomer. It is made up of 6 polypeptide chain, out of which 2 long chain is there. That is the tail, and then there is 4 short chain which is present on the globular head structure. Okay, it has a globular head. Now, on the head, he has place for 2 people. One is his actin. Okay, the future. Okay, a future of him, actin is there in the head, and with actin, who is there? His father also is there. Now, until father move or until ATPase move and become ADP and PI, actin cannot come and bite. This is the story. Now, I have written something called as LMM. What is LMM? That means light. See here, you can look here. Light meromyosin chain. Okay, light meromyosin. That means where the density is completely low. Where the density is completely low. Don't tell nonsense about myosin in the chat box. Okay, I will remove you people from the class. How can you tell bad things about myosin? Okay, myosin is not like you people. Whatever you people are telling about myosin, this is father only on his head. Okay, I understand what you people are thinking. No, don't think about myosin like you people. Okay, yes. Okay. Suddenly they're deleting messages. One, all are deleting messages. So smart, you people are so smart. Myosin is not like you people, okay? Is that clear? I'm very strict about myosin, part of zoology. I will not let you people insult, okay? This is Andakala love story, students. 1996 love story, not like 2024 love story, okay? So please, little respect, say you people talk to myosin, okay? And look here, then we have HMM, that is high meromyosin. That means where density is more high. Density is more high where? On the globular head, okay? Yes, fine, fine, let's go. These people are not respecting you, myosin. Okay, now structure of actin. Heroine entry is happening. That is, it is made up of thin filament. We already know, told that actin is made up of thin filament. Yes or no? Right? Now, it has actually first actin was globular structure. Okay, actin was globular structure, but that does not actually help in this entire contraction. So for that, this globular proteins got converted into F-actin, fibrous actin, with the help of magnesium. Okay, with the help of magnesium ion, and it is called as polymerization. Okay, it is called as polymerization. So what happened? Globular proteins were there that got combined to form fibrous protein. Students, actually actin look like this. Like your hair, girls braid their hair, no, to school. Like this it will look. Okay, but I have taken only one and drawn. Okay, yes or no? Fine. Look here. So globular protein with the help of magnesium, with the help of polymerization, it became fibrous protein, and now it looks like your infinity sign. Okay, now look here, you can see many globular structures. Okay, no problem, ma'am. That globular proteins got arranged into a infinity structure, no problem. You'll be like, who is this? Like kebab mein haddi, one person is standing in the middle. Who is this person? This white color person is none other than your tropomyosin, who is the first brother of the heroine, the actual villain. Villain number 2 on stage. Okay, villain 2 on stage. Then, other than this habab mein kaddi, other than this white color fibrous person, there is 3 people sitting in the middle, like panchayat people, no? For no reason they'll come and tell, oh no, you won't crack NEET 2024. What do you know about NEET? They wouldn't have even seen what is NEET. But they'll come to your home and tell your mother, father, no, hey, let him drop, yeah. Why you wasting money on him? He or she won't study. Our so-called neighbors, like that, we have 3 people sitting like panchayat, coming and sitting every day 5 o'clock in the evening, judging people. This fellow will not do NEET, yeah. This girl will not do NEET, as if they know what is NEET. Okay, so this is those people. And who are those people? That is none other than troponin. So 2 villains we got. Now third villain, this is villain 3 on the stage. Okay, villain 1 was ATPase, villain 2 is tropomyosin, villain 3 is troponin. But this troponin, I told you, they are like those society CCTV cameras. They are not coming alone. They are 3 people. So if I draw this enlarged image, can you see here? We have TPI, okay, TPI, TPT, TPC. Who is C? TPC is the person who is going to save all of this. I'll tell you how. That is calcium. TPC is what? Calcium, okay. That is troponin C, troponin I, troponin T, okay. Troponin C, troponin I, troponin T. Troponin C is the calcium one, which will bind with calcium and help this actin and myosin to bind. Then this is actin inhibiting site. Okay, understood? Who is inhibiting? Actin inhibitor site. Then we have TPT, that is your troponin by itself. Okay, is this clear? Any doubts? Any doubts so far? Doubt is there? Doubt is not there? Quickly tell me in the chats. TPC is the savior. Doubt clear? No, any doubt so far? I'll explain it again for you people. You can ask me how many ever times you have doubts, students. Don't hesitate. Sarcomere. Sarcomere is actually the basic structural unit of muscle and the contractional unit. Sarcomere only is the one who is going to help. In that, sarcomere is the one who is going to do contraction, relaxation, all of this, no? So, myofibril, from myofibril you will learn sarcomere. So, you can write myofibril is the structural unit, structural and functional unit of muscle, and in that sarcomere is the one who is going to help in contraction. No doubt so far, right? Okay, great. Awesome. Now, understood, no? Villain 3 is come now. Students, look here. Tropomyosin and troponin are regulatory proteins. That means they will control when the muscle has to contract and when the muscle has to relax. Okay, when the muscle has to contract, when the muscle has to relax. That means they will decide when actin has to meet myosin and when myosin has to meet actin. That job is done by who? Troponin and tropomyosin. So, we will call them regulatory proteins. Okay. Now is the story. Now students, now is the actual story. We are going to make them meet because we need muscle contraction to happen. For that, you all have to draw with me something. See, this is the sarcotubular system. Students, because of the system, actin's head, I told you, no, this troponin is actually covering the myosin binding site. Who is covering? Troponin. Troponin, behind troponin is your myosin binding site, but that is covered by these villains, right? So, we have to move this troponin from there. We have to move this tropomyosin and troponin from there for the myosin binding site to be visible. For that, we are going to do something called as sarcotubular system. That means, with the help of a stimulus, we will be able to influx sodium, and because of that influx of sodium, calcium will come from the endoplasmic reticulum and myosin binding site will be visible. Story is going on. Okay, wait, don't. We are going, okay. We are the brokers, like I told you last time. We are going to help them. Now, look here. This is T tubules. Okay. So, this is your sarcoplasmic. Oh, this looks like a septic tank. Wait, students, 1 second. Let me increase my drawing skills. I roast myself, no? No one needs to roast me. I will only roast myself. Okay, let's start. See, look here. Now, let one who come, one. Okay, I'm drawing like this one right now. This is a nerve. This is a nerve. Nerve is bringing one stimulus, one impulse it's coming, okay? Right? It is going to bring, and here on the sarcoplasmic reticulum, sarcotubular system, there will be receptors like this. Who will be there? Receptors will be there. This structure which I have drawn is a T-tubule. I'll tell you the use of T-tubule. Right now, just understand this cup-like structures which you're seeing is the receptors, okay? This cup-like structure which you're seeing is a receptor. They're waiting for what? They're waiting for your neurotransmitter to come. So, now the impulse is bringing neurotransmitter. Okay, it is going to bring some neurotransmitter, that is acetylcholine. Okay, ACH it is going to bring. This ACH will be accepted by your receptors. Receptors will start accepting your ACH. Okay, receptors got neurotransmitter. Immediately as soon as they get the neurotransmitter, they will start influx of sodium. Okay, influx of sodium to the T-tubules. So, T-tubules will help in the sodium to reach. Okay, so here what is happening, students? First step is sodium influx is happening. Sodium influx is happening. Anyone has any doubt? Simple. One stimulus was bought. This is the neuron ending. That is your axonal ending. This axon ending bought some chemical synapse. In that neurotransmitter is there. Acetylcholine is a neurotransmitter. It bought some neurotransmitter and there were receptors on the sarcotubular system. This is for what? This is for muscle contraction to happen. Okay. And these receptors got these neurotransmitters got accepted by the receptors. As soon as they accepted the receptor, what happened? Influx of sodium happened. You have to think about your action potential, no? How we think like that. Influx of sodium happened. This is the first step. As soon as influx of sodium happened in the sarcoplasmic sarcotubular system, there is your wait, I'll draw it with another color. There is your ER, that is your, who is this? This is your sarcoplasmic reticulum. Okay, this blue color circle which I have drawn is who? Sarcoplasmic reticulum. Got it? Sarcoplasmic reticulum. Inside the sarcoplasmic reticulum, who is there? Calcium is there. Calcium is there. Calcium is there inside the sarcoplasmic reticulum. As the influx of sodium happens, okay, as the influx of sodium happens, slowly the calcium will get released from the sarcoplasmic reticulum. What will get released? Calcium will get released. As soon as calcium gets released, one person is waiting to bind with calcium. Who is that? Who is waiting to bind with calcium? None other than your actin. On the actin, 3 people are there, no? Who is the 3 people? 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? Your TPC is waiting. Right? So, TPC will go and bind with calcium and immediately what will happen? Distraction will happen. So, here what is going to happen? Is this clear? So, here your TPC will get attached to the calcium ion and because of it one conformation will happen. Conformational change will happen between tropomyosin and troponin. Is this clear? Is this clear? Now distraction has happened. Now imagine you're going to a party. You and your friends are fighting. What will happen? Security guard, the DJ, people who are dancing, everyone's concentration will come to you. Correct? Everyone's concentration will come to you. So, there will be a person who is 17, not 18 plus, that fellow will enter the pub. Why he'll enter the pub? Because everyone got distracted. Same way, here, as soon as calcium gets released, your TPC will get distracted and suddenly your tropomyosin and troponin will move or they will get distracted. One conformation will happen leading to myosin binding site being visible. myosin binding site will be visible. Is this clear? Is this clear? Okay. Yes or no? Yes or no? Is this clear, students? Very simple. Very simple. One stimulus came, it bought some receptors. That receptors were accepted by your acetyl, by your receptors which are present will take the acetylcholine, right? That acetylcholine will, because of that, what will happen? Influx of sodium will happen. Because influx of sodium happens, automatically the calcium storage, that means the calcium in the endoplasmic reticulum or your sarcoplasmic reticulum will come out. And who is waiting to bind with calcium? Your actin villains, the villains on the actin. So on the actin, the TPC will come and bind with the calcium and do a conformational change between the tropomyosin and troponin. Okay, full one fight will be happening. Okay, what will happen? Everyone's concentration will be there. Immediately that time, the myosin binding site on the actin will be visible. Yes or no? Yes or no? Clear? Yes. Got it? I want everyone to put red hearts in the chat box if you understood it. Fast. All of you put red box. What is red box? It seems. Red heart in the chat box if you understood. All of you. Rani, were you distracted? Listen to the class. Okay, all of you want to see? You can see. I'll move to one side. Yes. Got it? Yeah, more energy. Yeah. What is this? We have to run a long marathon. If you people are like this after 1 hour, how will I feel? I'll feel more disappointed. All of you, come on. That much you can do for a teacher. Yes, very good. Now it is nice. Awesome. Awesome. Yes. So students, first story understood. We went for their party and we basically fought in the party. Everyone got distracted. In that time, myosin binding site got visible. Now, myosin will want to come and bind with the actin. But from the myosin head, whom we should remove? We should remove the ATPase. Yes, we should remove it through. Why is remove is coming? Remove the ATPase. Okay. Chalo, let's start. Sliding filament theory. I told you. Z line is the only one who is ready to move. So actin will move, slide over the myosin, or the myosin will slide over the actin. So it's going sliding filament theory, right? Sliding filament theory. Okay. So let's try to understand. What are all you people are telling? Teacher, no, director it seems. Okay. Chalo, let's start. Is this visible? Yes, it's visible. Okay. So students, first job successful. We went as brokers. We did the first job very nicely. That the job was to make sure that the actin, on the actin, the myosin binding site is visible. Next job is to remove the ATPase or remove the father from myosin's head so that they both can bind, so muscle contraction can happen. Now, how is it starting? Look here. First thing is it has ATP on the head. That ATP has to get converted to ADP and PI. That is the first task. So we will do hydrolysis. We will do hydrolysis of ATP. First step, okay. So myosin head splits ATP and become reoriented and energized. That means ATP will be removed in the form of ADP and PI. As soon as ADP and PI, it becomes what happens, students? Actin will be ready to come in. Myosin will go and try to bind with the actin. Yes or no? Now, when they are trying to bind, they will form a cross bridge. What will they form? So here you can see myosin head binds to the actin, forming a cross bridge. Okay, it's like two countries. Okay, think that they were one is from Punjab, one is from Bangalore. Okay. Haha. Wait, we didn't even make them come together. Okay. Thank you, Shreyas Kapoor. I've actually got that compliment many times. So yes, thank you. Okay, thank you. My tongue is twisting. I don't know what I'm saying. Okay, students, look here. They are like two countries. Marriage is happening. Okay, so it will form a cross bridge. It will form a cross bridge. What cross bridge? When actin and myosin bind, cross bridge will be formed. Now ADP and PI is still in the head of the myosin. So myosin will feel that heaviness. So myosin will be like, I will do a power stroke. Power stroke means what? Removing that ADP and PI from the head. This Buddhu fellow, when he does power stroke, what will happen? He will move from the actin. Okay, so I will enact it with the story. Now this is I don't know if you can see. Let me go to a black screen. See students, this is, okay, this is your myosin. Okay, this is myosin. This is no, let's keep this as actin, let's keep this as myosin. This black remote is not seen. Okay, now what is going to happen? This actin is there, myosin binding side, myosin will come and bind. Okay, now as in this myosin bind, there will be ADP and PI on the head. So this myosin will be like, let me do one thing, let me remove this ADP and PI, and he will move like this, he will move like this, he'll do a power stroke. Because of this power stroke, this movement will cause a space between them. Can you see a space between them? Right? Can you see a space between them? When the space happens, who will come and join again? ATPase will come and join again. Another ATP will be waiting, no? That ATP will come and join again. And this cross bridge will break. So, very simple sliding filament theory. Actin is there, myosin is there. ATP got hydrolyzed to ADP and PI. They both bound together. See, they both they bound together. Okay. After that, this fellow will be feeling heavy. ADP and PI is on my head. So what he'll do? He'll move like this. He'll do power stroke. Because of the power stroke, this movement will happen. This will cause a space. In that space, another ATP will come and bind, and the cross bridge will break. So the terms that you need to remember is power stroke and cross bridge. Okay. Now you will understand better. So cross bridge means when they both meet. Okay. And myosin head rotates towards the center of the sarcomere, causing a power stroke. That means to remove the ADP and PI, he will do a power stroke. When the power stroke happens, as the myosin head binds to the ATP, the cross bridge will discharge. That means another ATP will immediately come and bind, and this cross bridge will break. Isn't this fellow dumb? So much difficulty we did cross bridge formation, and this fellow is like, ADP and PI is heavy, so I'll move. But then students, this is nature, right? This is how muscle contraction happen. That is how very fast you are able to contract and relax. Because if myosin is continuously attached to actin, then continuous contraction only will happen, right? So this sudden movement should happen. So this is how sliding filament theory is happening. Are you all good to go? Okay. See, look here. Let's try to understand. So look here students, first here, this is the first step. That means hydrolysis of ATP will happen here. Okay, hydrolysis of ATP. Okay, not tired, no? Not tired, no? Interesting, all of you? Not tired, right? Yeah, Sharath is such a what is this villain in the story. From that time he's telling, ma'am, let's break myosin and actin, let's break myosin and actin. Okay. Okay. Yes or no? Got it? So look here. Students, hydrolysis of ATP, first ever step of sliding filament theory. After hydrolysis of ATP happens, this ATP will get hydrolyzed into ADP and PI. During this, what will happen? Cross bridge formation will happen. So I'm writing here, cross bridge formation will happen. That means actin and myosin will come and bind. Tongue is twisting. Actin and myosin will bind. Okay. That time cross bridge formation will happen. As soon as cross bridge formation happen, this myosin's head will be like, pull, make a power stroke. That means remove the ADP and PI, causing a power stroke. Okay, should I write it here? Okay, causing a power stroke. So when a power stroke happens, what will happen? After that, the cross bridge will break. New ATP will come and bind. Okay, so I'm writing it here, cross bridge will break. Okay, and new ATP will come and bind. Okay, new ATP will come and bind. Is this clear, students? Any doubt? Okay, again this will continue. Okay, this is our muscle contraction will happen. Okay, fine. Sliding filament theory. So first step, second step, third step, fourth step. Okay, during this power stroke, ADP and PI will be removed. Okay, removed. During this time, what will happen? The myosin head will move. Myosin head will move. Okay. What are they talking, yaar? They're talking about giving gift to someone and all. They are in their own world. Some 29 days are there. They're sitting and talking about, well, should I give you gift? On May 5th, I'll give you people gift if you don't write the paper and come properly. Okay, done. Cross sliding filament theory. Yes, okay, awesome. Yes. So students, here, look here. Contraction is happening. So now I understood how myosin and actin is binding. You studied what is the sarcomere. On the sarcomere, myosin and actin was there. How they bound, how they are moving, that we understood. Now we have to understand what will happen during the contraction. This is from your textbook itself. Okay. So can you see Z line, Z line, Z line? This will be one sarcomere. No? This will be one sarcomere from one Z line to another Z line. This is one sarcomere. Okay, one sarcomere. So like this, another sarcomere is there. So can you see, as we are moving, as contraction is happening, first thing that you're noticing is sarcomere size is decreasing. Right? Sarcomere size is decreasing. Okay. Second thing that you're noticing is the Z line is moving. Right? The Z line is moving. Z line is not constant. Z line is moving forward. Right? So Z line is moving forward. Okay, and I already told you one thing. Whatever happens, who is that auntie or uncle who never moves in a queue? Who is the auntie or uncle who never moves in a queue? Yes, all of you tell me quickly. Who is the one who will move, who is not ready to move? No matter whatever you do, I will remain like this only. Who is that one who is telling? I band also will reduce in size. Okay. Then who else will be there? Very good. Awesome. A band will be the one who will be constant. A band is like whatever you want, you do, I will not move. Even the M line will be constant. Okay. M line also will be constant. Okay. I band will reduce, O band will reduce, head zone also will reduce, but these people A band and M band will be constant. Is this clear to all of you? Chat is slow? Okay. Chat is slow. Okay. Understood. Chat is slow? Understood. Is this clear, students? Sliding filament theory, everything is done? Oh, I forgot to tell. Sliding filament theory is by Haeckel and Haeckel. Okay. You can tell their names. Not very nice names for me to tell. Okay. British names. Okay. These two people were the people who found sliding filament theory. Okay. Yes. Haeckel and Haeckel. Okay. Done. Muscle contraction done. Let's go to, this is types of, okay. 1 second. Yes. Here it's there. Can you see this? Oh my god. It's too bright, no? Too bright, no? Okay. Students, I'll write it here only because that image is too bright. But don't worry, in PPT it will be normal. Only in this board it's like this. Okay. Okay. Students, ready? Skeletal system. We'll finish this chapter fast and furious. Maybe we'll finish it in half an hour more. That's all. We'll be done 2 hours. Locomotion and movement will be done. Then we'll do excretion. Then we'll do body fluids. Okay. Yes. I'll do fast. I've put my notes. I'll explain you with the notes like this solely properly. Are you all enjoying the session? All of you tell me in the chat box. Are you all enjoying? Okay. Are you liking it? Right? Too bright. Yeah. That's why I moved it. I will not keep it because what if my students' eyesight go? They'll blame it on me. They'll be like, ma'am, my eyesight is gone because of you. Okay. Come on. Tell me. Are you enjoying the session? Do you like this way? Yes, that is correct, dear. Huxell and Huxell were the people who found sliding filament theory. Okay. Yes, enjoying? Okay, fine. Yes. Okay, great. Fine. Students, types of skeletal fibers I'm not doing. I'm doing types of skeletal system. Okay, that diagram is too bright. Types of skeletal system. What are the 2 types of skeletal system? Axial skeletal system and appendicular skeletal system. Okay. Axial skeletal system. Okay. And appendicular. You'll be doing questions after this. Okay. So listen carefully. Skeletal system. Now, can you all tell me the number? Axial skeletal system means what? How many do they have? They have 80 bones, right? And appendicular has 126 bones. So, we have two systems, right? Axial skeletal system, this part is your axial skeletal system, appendicular skeletal system, hand. Wow, I look like that radiating. Have you seen in that word, in Word, when you do Word, no, when you type that word, there's something called as word art. In that there's one thing, no, glowing. See, don't I look like I'm glowing? Like imagine me as a font, A, letter A. Don't you think like I'm glowing? See, look on the board. I'm that glow filter on the word. Okay, so yes, word art, glow. I don't know how many of you understood. If you have used Word, all of you would have used Word, no? You would have seen that glow. Yes, very good. 126, 80. Right? So students, axial skeletal system means this part. Right? Your face, cranium, facial bone, and your vertebral column, sternum, ribs, all that. Right? Hyoid, your ossicles. Fine. Then appendicular means this. Right? Appendicular means all this. Fine? Got understood? Yes. Fine. Understood. Clear. Now, let's do appendicular. Appendicular. This is too bright? No, this is not. The skeleton looks very scary, yeah? Okay. Let's start with axial skeletal system. Now they are telling Isala cup namde. Students, Isala rang namde. Cup you forget. Yes, for infants it is 300 bones. For us it is 206 bones. Again, for infants the sacrum and coccygeal will be separate. Right? That will be separate. So, there is a difference in the bone number. Okay? Got it? Fine. Let's students, axial skeletal system, what and all are there, we will write. Okay? My God. Neet students are in this channel and I did a trick for ear ossicles. Ma'am, it's deleted. Ma'am, it's deleted. Ma'am, it's deleted. Why will I waste my time teaching deleted syllabus, students? I was telling about this ear ossicles. Questions have come. Ear ossicles, shape of the ear ossicle. Ear is deleted. But axial skeletal system is there, no? I was like, night full I was sitting and replying. Students, it's not deleted. It's not deleted. I felt to sit and cry via this telling ma'am is deleted. I am the first person who does not want to do deleted syllabus first of all. Such a waste of time. Okay, axial skeletal system. Let's start from the brain. Right, so we have cranium or the brain box. Okay, cranium. You will tell me numbers, okay? Facial bones. Okay, facial bones. Then you come here, tongue, that is your hyoid, U-shaped bone. As you come downwards, now this side, ear ossicles. Okay, then you will come single bone, sternum, then vertebral column, then students, last one is rib cage, right? Rib. Okay, fine. Did we write everything? Rib cage. Okay, these are all the axial bone. Yes? Yes or no? Organism, environment, forget. I got cyber attack only. Organism and environment. Ma'am, it's deleted. How dare you take the class on a Christmas? Okay. Yes. Shall we start? Okay, let's start. Cranium, students, how many bones are there? 8 bones are there. Okay, in that PT is paired. PT is what? Parietal and temporal. Parietal and temporal is paired. PT. Okay. Facial bones, how many are there? 14 bones are there. 14 bones are there. Fine. Our hyoid, 1 bone. Ear ossicle, 2 ears are there, so 6 bones. Some people calculate 3 also. Some people calculate 6 bones also. Okay, fine. Then sternum, 1 sternum we have. 1. Then vertebral column, how many is there? We start with thorax, start with cervix. Cervix 7, thorax 12, lumbar 5, sacral and coccygeal 1, tailbone. All of you calculate and tell me fast. Very slow, very slow. Let me see in this chat. Is it shown here? See, you'll tell chats are slow, ma'am. I'm seeing in this also. No chats. Chats are not moving at all. Did I write ear ossicle? Yes. Yes, very good. Yes, 26 bones. For kids, how many will be there? 33 will be there. Okay. 26 for us. For kids, for infants, it will be 33. 33. That's because sacrum and coccygeal is not attached. Then rib cage, students. 1 to 7 is true ribs. Then you have false rib. 8, 9 and 10. 11, 12. So how many are there? 12. Okay, 12. Now calculate. Do maths. Total how many do we have? Yes, I'll give you a trick to remember. This you have to remember, students. For this there is no trick. Simple trick is there. Cranium is there. After cranium you come to your face. Then you come to your tongue, hyoid bone. Then come to your ears. Then you touch your sternum. Then you touch vertebral column, rib cage. No trick. How many are there, students? All of you calculate total. Yeah, kids 33, 12 pairs. I'm waiting for your answers. Then only I'll move forward. Yes, very good. 80 should be there, right? 80 should be there. Is 80 there? Yes, very good. So total axial bones are 80. This is what you have to remember in axial bones. So here also you can see, you start with skull. That is skull. You can include the facial bones also. So that is there. Ear, ossicle, hyoid, everything. In the sense, basically till here, you can include it as skull. Okay, you can include it as skull. Okay, and then the rest separately. Okay, let's start. So look here. Now we have to know the cranium bones. How are we going to remember the cranium bones? All of you tell me in the chats, how are we going to remember the cranium bones? We are going to remember the cranium bones as step off. Step off. Okay, what is step off? S, sphenoid. So here you can see S is sphenoid, T is temporal, E is ethmoid, P is parietal, O is occipital, F is frontal. Out of that PT teacher, like that, no? PT teacher. P and T are paired. That means parietal and temporal is paired. All others are single. Very good. Step off. Everyone has learned it. Awesome. Yes, very good. Very good. Step off. Okay. So you can remember which is the one that is paired. PT is paired. Yes. Good, good, good. Yes. Okay. Let's try labeling the students. Look here. All of you see, they have given frontal. Where is frontal? Here is frontal. Forehead, no? Where you always have headache. This is your frontal. Okay. As you go frontal, here you will come, right? You have your occipital, then parietal, temporal, sphenoid we can't show. But sphenoid is there, and sphenoid is the one that is connected to all, articulates with all the bone. Very important to remember. Sphenoid is the bone that articulates with all the bone. It is called butterfly shaped bone, bat shaped bone. Okay. It articulates with all bones. Okay. With all the bones. Like the social butterfly, you know. So you'll remember its shape also as butterfly. Okay, can you see? It's more like bat shaped, more than butterfly shaped for me. It's more bat shaped. See, exactly like a bat it looks. No, see? Yes, see? Can you see? Bat shaped. Okay? Yes, very good. Then, students, on the sphenoid bone, there is a small, like a depression, called the sella turcica. You would have studied, remember, we studied this? Sella. We studied this where in chemical coordination. Sella turcica, which will have the pituitary gland. So it's a small depression like a cup like this. In that your pituitary gland will be there. All of you remember? Pituitary gland will be inside this. Pituitary gland. Yes. Look here, students. Can you see blue? Frontal you have. Okay. Then pink. Ethmoid you have. Ethmoid is this portion. Like I cannot show 3D, but yeah. This portion will be ethmoid. Inside, if you see, this portion will be ethmoid. Then we have your sphenoid, which articulates with all the bone. Question can come on this. Then see here temporal. Here you have temporal, two temporals. Then we have occipital. Okay, backside occipital, and here parietal. So parietal and temporal is paired. Other things are all single people. Okay, single people. It looks like bat, no? Bat emoji you people have said, no? It looks exactly like a bat. See? Sweetie and Sharath has said exactly like a bat it looks. So this is the one which articulates with all the bone. Okay, done. Cranium bones are done. Okay, sphenoid. So shall we learn frontal? Start with frontal, front. Okay, then you have ethmoid, sella we can't show, sphenoid, Okay, then we have temporal, occipital backside. Below the occipital, students, what will be there? Condyle, dicondyle. Our skull is dicondyle in nature. That means what? Below the occipital, there is a dicondyle structure. Okay, dicondyle structure. It will look something like this. Okay, something like this. Like how you have our Bluetooth, no? Bluetooth AirPods, same way it will look like this. Okay, like a two condyle structure will be there, which will help them to articulate with our vertebral column. I'll show you that, do not worry. Now, is this clear? Can we proceed to facial bones? Cranium, good? Yes, skull, in the skull only. In the skull only, ear ossicles. Question, what question will come about sphenoid? Which is the bone that articulates with all the bone, or which is the bone which is bat shaped or butterfly shaped, or which is the bone that holds the pituitary gland? Multiple questions can come. Okay, multiple questions can come. Got it? Cranium done. Cranium, let's revise quickly. It's made up of 8 bones. Out of that, how to remember? Step off. Okay, step off. S stands for sphenoid, T stands for temporal, E stands for ethmoid, P stands for parietal, O stands for occipital, F stands for frontal. Okay, now in that, who is the ones that are paired? We have 8 cranium bones. That means 2 of them are paired. Who is that? PT, parietal bone and temporal bone. Okay, parietal bone and temporal bone. Clear? Fine. Now we'll do facial bones. Okay, facial bone, students, here only you can see the structure is here. So we will start with the nasal bone. You start with your nose. Okay, nasal bone. Nasal bone. Then after nose, where do you come? Inside there is infranasal. What is that? Infranasal. Okay, infranasal. I think I can show it here on the diagram also. See, nasal bone is here. See, can you see here? This one, here, where you keep your specs, no? I don't have a specs. Where you keep your specs, here. This is where your nasal bone is there. You can touch and feel it. All of you feel it? Touch and feel it? Yes, inferior nasal. Okay. Yeah, numbers also I'll give the numbers, don't worry. Nasal bone is obviously 2. Okay, 2 nasal bones. Infranasal, look here. Infranasal, that is also 2. That is coming here. Infranasal, that is also 2 in number. 14 bones we need. Facial bones are how many? 14 of them. Okay. Next, the place where girls put blush. Like this, they smile and they put blush here, no? That is called as the zygomatic bone. Zygomatic bone. That also will be 2. Zygomatic bone, where the blush is put. Blush here. Here we put blush. Okay, that is called a zygomatic bone. That is here. I think here it's given in blue. Yeah, this one. Zygomatic bone. This one. Okay, fine. After zygomatic bone, which one? Eyes may, where you cry, no? When you cry here. Lacrimal. Okay, lacrimal. Yes. Hyoid we'll do. Hyoid we haven't done now. Just do infranasal now. Hyoid I'll tell you. Yes, very good. Palatine. Yes, very good. It's also called, zygomatic bone is also called cheekbone. Then we have your tear gland, no? Tear gland or your lacrimal gland. Tear gland or your lacrimal gland. That also is 2. Fine. Then students, when we come to the middle structure, we have something called as the vomer. Wait, I'll show you. Here we have vomer. Here, this portion we have vomer. Vomer is a single bone. Only one is there. Okay, vomer is 1. Lacrimal you told? Yes, very good. Lacrimal gland or your lacrimal. Tear gland. Okay, just you can write lacrimal bone itself, because we are talking about bone. Don't get confused with gland. Okay, tear gland. Vomer is 1. Okay, vomer is 1. Fine. Next one. Okay, after vomer, students, can you see here? Palatine bone is there. Okay, palatine bone is there. Again, I don't know if you can see it. It's here, labeled here. Eyes, inner region of the eyes, palatine bone is there. All of you know that? I don't think you know, or you know. You know, you don't know. So, vomer and palatine, we'll write it together because they are present in, okay, palatine also we have, that is 2. Okay, then we come to the mouth region. After done nasal bone, then zygomatic, lacrimal, palatine, then we'll come to maxilla and mandible. maxilla and mandible. That's all. Maxilla and mandible. Okay, done. Maxilla and mandible. Obviously, who will be upper jaw? Upper jaw. Maxilla will be 2, mandible will be 1. Did we reach 14 students? 2, 4, 6, 8, 10, 12, 13, 14. 14. Done. 14 bones are done. Let's do once again. So, you start with the nasal bone, infranasal bone, okay, lacrimal bone or your tear gland, zygomatic bone where you put blush, then you have vomer, which I can also, vomer, palatine, and then you have maxilla and mandible. Okay, maxilla and mandible. You touch your basically all the parts of your face and you'll understand all the facial bones. How many are there? 14 are there. Okay, no trick for this. You have to remember by yourself. Fine. Now let's understand ear ossicles and hyoid. So students, first of all, let me discuss hyoid. Hyoid is actually a bone which is like alone. Okay, it's like lonely person. It is a U-shaped bone. Okay, below the tongue, a U-shaped bone. U-shaped bone. And obviously it is 1 in number, only single bone. Okay, it's a single bone. Single lonely bone it is. Okay, hyoid, a single bone, a U-shaped bone which is below the tongue. Okay, it does not actually articulate with anything as such, but it just exists there. Then ear ossicles is very, very important. What is the trick I told you for ear ossicle? All of you tell me in the chat. Ear ossicle, what is the trick? Ear ossicle has like one ear has 3 bones. Yes, what is the trick? Fast, fast. Trick, 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 trick. Yes, hyoid is also called the tongue bone, right? Yes, very good. Myth has, right? How do you remember myth? Okay, has. That is, M stands for malleus. A stands for, oh, no, miss. Incus. S stands for stapes, which is the smallest bone again in our body. Okay. Now, not only knowing the bones is important, we also should know the shape of the bone, that is has. Head stands for hammer shaped. Okay. Head stands for hammer shaped. Incus, A, anvil. Okay. Stapes, stirrup. Okay. Stirrup. This was early days. It was depending on the tools that they used. This was the shape which was told. Okay. So this is the trick. Myth has. M stands for malleus, I stands for incus, S stands for stapes. The shapes are hammer shaped, anvil shape and stirrup shape. Okay, I'll show you the shape now. See, this is the shape. Okay, so, hammer shaped, anvil shape, stirrup shape. Can you see the shapes? Okay, myth has. Got it? Chalo, let's go to the further. Now, look here students. Next thing is vertebral column. So, vertebral column basically have 4 curves. Now, if you're doing some kind of exercise, okay, if you're doing some exercise, can you feel a curve? Can you feel the different curves in your body? Can you feel here there is a hump, like not a hump but a small protrusion, that is your cervical curve. As you go down, you can see your thoracic curve, lumbar curve and your pelvic curve. So, here there are 4 curves. First one is your cervical curve. Then you have your thoracic curve, lumbar curve and pelvic curve. Okay, 4 curves. Got it? Now, look here. This is how we got 26. Those students who do not know how we got 26, look here. Cervical bones are 7 of them. C1 to C7. C1 to C7. Then I have written T12. That means T1 to T12. Okay, then L1 to L5, lumbar. Then sacrum and coaxial, I have put it in a bracket. Why have I put it in a bracket? Because these 9 bones are made into one bone called the tailbone. Tailbone. So that's how we have 26 vertebral bones. But the babies, the infants, what happened? These 9 bones are not fused together to form the tailbone. Later development will happen. So 33 of them. What are you asking? Okay, yes, organic formula, no? Now, look here students, very easy. Cervical vertebrae are 7 bones. That is specially the most important one we have to remember is axis and your atlas and axis. Okay, atlas and axis. C1 is your atlas, C2 is your axis, then C3 to C7, not important to know the name. But C1 and C2 very, very important. Okay, atlas and axis. Then cervical vertebrae, 3, so that you forget. Thoracic vertebrae, 12 bones, T1 to T12. So how are we labeling it? T1, T2, T3, T4, T5, T6, it goes like that. C1, C2, C3, C4, C5, C6 till C7. Okay, first bone is atlas, second bone is axis. Got it? Now, look here, lumbar vertebrae, L1, L2, L3, L4, L5. Okay, then sacrum and coccygeal together fused into tailbone. So you don't have to know anything much, you just need to know tailbone. Okay, tailbone. Yes, here you can see this is the tailbone. Now, look here students, atlas and axis. I want to just show you this. Can you see this axis has a odontoid process. So it is basically, see, this is my hand. Okay, this is my hand. So this hand is the atlas. Okay, this is the first bone. This is the axis. Can you see this blue color pen? This is the axis. This portion which you are seeing upwards, this one which you are seeing upwards is a odontoid process. Okay, this odontoid process is it is actually articulating with the atlas. Okay, that's why I have just put this image, and you know this atlas will go and bind with where? Your occipital, I told you it is dicondyle. It will go and bind there. Okay, it will articulate there. Okay. Yes, so atlas and axis, this is odontoid process. Oh, awesome. Now, let's learn the rib cage. Before rib cage, we have to learn the sternum. Are you ready? Ready? No bone. Who has no bone? Ready? Ready? Okay, chalo, let's start. Okay, let's start. Students, this sternum is also called, here, even though I wrote rib cage, let's start with sternum. Sternum is your breastbone, right? Breastbone. The sternum, it says it is dagger shaped, but I always feel it is like a tie shape. Proper tie, you know, when we used to go to school, we used to tie a tie. Right, exactly, sweetie, it's tie shaped. Okay, so this one, sternum, they say it is dagger shaped. I don't understand, yeah. Dagger shaped. Tie shaped it is. Okay, dagger shaped. Fine, we will listen to what our ancestors are telling. Now, students, can you label the part? Very easy. This first portion is called as prosternum. Prosternum. Okay, then this middle portion is there, and this last portion is there. This last portion is called sphenoid process. Now, this portion can be called as mediasternum or mesosternum. Okay, it can be called as mesosternum. Mesosternum. Got it? Yes or no? Yes. So, prosternum, mesosternum, the small process, like a small kutti tie-like structure which you are seeing, no, that is your sigmoid process. Okay. Now, this much only you have to know about your sternum, nothing big you have to know, but you just have to know that all your vertebral columns, right, one it is attaching to the thorax, again one the front it is coming and attaching to the sternum. That means to form the entire rib cage. For the entire rib cage formation, we have this vertebral columns, they will come and attach like this. Okay. So, okay, this is your sternum. Okay, these are the vertebral columns. So, they will come and attach like this to form a rib cage like this. Can you see? Like a rib cage like this. Okay, fine, got it. Mesosternum is clear, no? This rib cage formation, in this middle what you are seeing is the sternum. My clip is the sternum. Why this clip doesn't have color? Should I move this side? Okay. So, this was the, and this is the rib cage. Fine? Okay, chalo. Now, I have scratched with the pen. Yes, it is the ventral side of the thorax, right? So, in the front, it will be joined by sternum. In the back, it will be joined by your thoracic vertebrae. That's how your rib cage formation happens. So, in the front, it will be joined with the help of sternum. It will come and attach to the sternum. And the back side or the dorsal and frontal also you can say. Back side, it will be attached to the thoracic. Okay, thoracic vertebrae. Okay, let's try to understand this. Okay, this we already understood, students. Cervical vertebrae, here we have 7. Okay, here we have 12, here we have 5, and this will form the tailbone. Okay, now here rib cage, very very important. So students, look here, this is how your rib cage is. This is the sternum. This is your sternum. Okay, this is the prosternum, which I am drawing in blue is the prosternum. Students, you can see some places manubrium also, the words manubrium. Don't get confused, same other word is there. Okay, this is the, okay, this is the blue, the orange color one is what? Mesosternum. Okay, and the last, the tip is your sphygmoid process. Tip is your sphygmoid process. Got it? Sternum. Now let's try to focus. What is our rib cage? Rib cage has, is the visible, no? Rib cage has basically 3 set of ribs. First one is true ribs. Why am I calling it true ribs? Very simple reason. Because in the front, right, in the ventral side it's coming and attaching to the sternum. In the dorsal side it is attaching to the thorax. This is how a rib cage should actually function. That means all NEET aspirants should be solving mock papers, reading NCERT, attending Gopika Ma'am's live. This is a general category. Okay. Now people who are not doing this are not true NEET aspirants. Same way, true ribs means the one that is attaching to the sternum and it is going and attaching to the thorax. How many of them do we have? We have 1 to 7. That means 1, 2, 3, 4, 5, 6, 7 are the true ribs. Okay. 1 to 7 is the true ribs. Now, then do we have, ma'am, false rib? Yes, we do have false rib. False ribs means in the ventral side, they are not coming and attaching to the sternum. Instead, they are going and attaching to the 7th one. So, imagine this is the, this is my 7th rib cage. This is the 7th one. What is happening? The 8th, 9th and 10th one are coming and attaching to the cartilage of the 7th one. This is the sternum. It's not directly attaching to the sternum. It's coming and attaching to the cartilage of the 7th one. So, how can I call it true ribs? True ribs means they have to directly come and attach to the sternum. Yes? So, they are false ribs. So, which are they? 8, 9 and 10. 8, 9 and 10 are they come and attach to the cartilage of the 7th one and hence called the false ribs. Other word for that is vertebrocondyles. If you want to remember, you can remember. And this is, okay. Now, last one is floating ribs. That means they are not at all attached to anyone's cartilage, nothing. They are not at all attached to the sternum and they are floating. Those are the 11th and 12th one. Okay. 11th and 12th ribs are called the floating ribs. That's because only in the back side they are attached, in the front they are not attached. Got it? Yes, very good. 7th, 11th and 12th is the floating ribs. Okay, good job. Understood? So far good. So here you can see 8th, 9th and 10th false ribs, 1 to 7 is true ribs and the last 11th and 12th is false ribs. Floating ribs. Okay, can you see here how they are? They are not at all attached to the front. They are just floating like this. Fine? Yes. Now, students, next one. Very, very important. All of you tell me the tricks in the chat box. How to remember the bones of your forelimbs. How to remember the bones of your arms. In simple words, how to remember bones of your arms. All of you. All of you, all of you, all of you, all of you. Quickly tell me in the chat. How do you remember the bones of your arms? Yes, very good, Subhashni. Okay. 7th cartilage. False ribs are attaching to the 7th cartilage. Remember this number, 7th cartilage. Okay, don't forget. How are you, CM Pandu? How are you, CM Pandu? So, we made Pandu the CM. Okay, very easy trick to remember. H stands for humerus. Okay, R stands for, wait, I should have written this way. H stands for humerus. Okay, R stands for radius. U stands for ulna. C stands for carpals. M stands for metacarpals. And P stands for phalanges. Okay, so easy students. Humerus, okay, humerus, humerus, radius, ulna, carpal, metacarpal, phalanges. Okay, phalanges. Very good. Awesome, awesome. How are you? CM Pandu. Okay, yes. Bicephalic means, students, bicephalic means, I'll tell you, basically they are attached to two heads. Which are the two heads? One to the vertebral and one to the sternum, right? Bicephalic ribs means, see, I'll write it here, bicephalic ribs, okay, meaning two heads they are attached to, one to the sternum extremity and one to the vertebral extremity. That is why it is called bicephalic. Is this clear? Okay, one to the, see here, if it's attached to the, in the dorsal side, it will be attached to the vertebral extremity, sorry, why am I telling? Extremity. And here it will be attached to the sternum extremity. That means two head, right? Dicephalic ribs. Is this clear? Whoever asked me the doubt. Okay, dicephalic means vertebral extremity, sternum extremity. It's attached to two portions, no? So it is called as dicephalic. Chalo, here. Okay, so metacarpals. Can we write the numbers also, students? Can we write the numbers? Humerus, obviously one is there. Radius, one is there. Ulna, one is there. Now, carpals and metacarpals, how many will be there? Carpals, 8 of them are there. Metacarpals, 5 of them are there. Phalanges, easy to look. Look at this markings on your hand. Markings on your hand. Can you see these lines? No, on my hands. See, these lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So that's how you count the phalanges. Okay, carpals are 8. Metacarpals are 5. Phalanges will be, I'll start with the thumb. 2, 3, 3, 3. How many fingers do I have? 4. Okay. So this is how you'll remember. 14 of them. 14 of them. Okay. How will you remember? This just in case in exam you forget, just count. Don't make the teacher think that you have written handmade chit and come. Don't be like 1, 2, 3, 4. Just look like this and be like, okay, 14 are there. Don't be like 1, 2, 3. She'll think you have written code and come. You have written handful of chit and you have come. Okay. So how many are there, students? 1 plus 1 plus 1 plus 8 plus 5 plus 14. Okay, 30 are there. So 30 bones on your forelimbs. Very important. Numbers are very, very important. Okay. Ulna is a bone, da. Ulna is a bone. Humerus, radius, ulna, carpals, metacarpals, phalanges. Next one. Next is leg. Okay. So we are going to understand your lower limb, right? Lower limb. How will you remember? Very simple. Who is that person with 2 thumbs? Shri, you have 2 thumbs, huh? 2 you have written. 2 thumbs you have? 2 thumbs are not counted, yeah. Only 30 you should have. Okay. So students, how do you remember this? Fly, Tarzan, fly, mountains and planets. Whom am I asking to fly? Fly, Tarzan. Okay. Fly, Tarzan, fly, Tarzan, mountains and planets. Very easy to remember. F stands for femur. T stands for tibia. F stands for fibia. T stands for tarsals, metatarsals, phalanges. So only thing tarsals, carpals, tarsals, carpals, tarsals. That's all is changing. Okay. Okay, fine. Very good. Femur is the longest bone. Femur. I cannot lift my leg and so I'll fall down. Okay. Yes, next block I'll do. No, neural control and coordination, chemical coordination and breathing and exchange I'll do on the wave platform. I will not do it on YouTube. Okay, mostly I'll do it on wave. I will tell you people. Okay. So, fly, Tarzan, mountains and planets. So, you have femur, tibia, fibula, fibia, tarsals, metatarsals and phalanges. Number remains the same, students. Femur 1, 1, 1, tarsals 7 is there. There we saw carpals were 8, but here we have 7 tarsals. Then metatarsals are 5, phalanges are also 14. But this also has 30 bones. How do we have 30 bones? Very simple. We will count our knee bone. That is the patella. This one. Knee bone. Patella is counted. So that is how we have 30 bones. Okay. So 1, 2, 3, 7, 10, 15, then 29 plus 1 patella, 30 bones. Is this clear? Yes, kneecap. Very good. Alna, to hit someone. Those who ask such questions, no? To give one like this. So they'll fly and go. Okay, ready? Next one. Okay, since now we have to understand the girdles. Okay, girdles means anything that is circular. Like anything that is like attaching, like maybe something like this which is closed or something like that. And also girdles are mainly to articulate. Now I told you humerus is there, femur is there. Where will they articulate? Where will they go and bind? Who is going to help them in binding, right? For that we have shoulder bones. Same way we have your pectoral and pelvic girdle. That is what we are going to understand. Here you can see you have your clavicle. This is your clavicle. Okay, and this rectangular structure is your scapula. So you have your shoulder bone, okay, and your clavicle. So scapula, shoulder bone and scapula. Okay, and then this is your acromion, glenoid cavity. Again, all for articulation. Glenoid cavity and all you people don't have, but I'm just telling. Okay, glenoid cavity. Here also you can see, and then acromion process. Here, this one. This is acromion process. I think in this one it's more clear. This side, students, acromion process. Clear? Yes, beauty bone. It's called clavicle. It's called the beauty bone. For actress and all, earlier they had to have the clavicle very prominent, because there they used to put highlighter and they used to show that beauty bone. Oh, you have beauty bone. You do not have beauty bone, right? That one, all nonsense. So clavicle, scapula, glenoid cavity. Okay, let's try to understand from the textbook. Okay, see, pectoral and pelvic girdle bones help in articulation of the upper and the lower limb. Understood? Your hand and legs. Simple words. Okay, respectively with the axial skeletal system. Each girdle is formed of two halves. So students, the moment we started How Are You CM Pandu, Flight Tarzan, Mountains and Planets, we have come into our appendicular skeleton. Do not forget that. Okay, appendicular skeleton. That vertebral column rib cage was the end of your axial skeleton. Okay, this is all appendicular skeleton. Fine. Each half of the pectoral girdle consists of a clavicle and a scapula. Scapula is the triangular structure, clavicle is that long bone, okay, which is your beauty bone. Now, scapula is a large triangular flat bone situated in the dorsal part of the thorax between the 2nd and the 7th ribs. Very important. Where is it located? Scapula is a large triangular flat bone situated in the dorsal part of the thorax between the 2nd, that means T2 and T7. Okay, between the 2nd and the 7th ribs. Okay, no, here sorry students, just write 2nd and 7th ribs. 2nd and 7th ribs. Okay, ribs. Now the dorsal flat triangular body, here the dorsal flat triangular body of the scapula has a slightly elevated ridge called the spine. Spine, all of you know, no? We tell spine, right? Which projects as a flat expanded process called as the acromion. Okay, acromion. Okay, spine is there. Here, you can feel it, I guess. I don't know if all of you can feel it. Spine. Okay, acromion. The clavicle articulates with this. Below the acromion is a depression called as glenoid cavity. The depression I already showed you, which articulates with the head of the humerus. So humerus is like this. Glenoid cavity will go and bind like this. Okay, fine. Now, humerus and forms the shoulder point. Each clavicle is a long slender bone with two curvatures. This bone is commonly called as the collarbone or your beauty bone. Now, here, this is your pelvic girdle. Okay, this is your hip bone, and the way to remember that is I play in class. Ischium pubis, pubis, yes, wait, students, I don't want you people to be confused. First, one just basic I'll tell you, then I will label the parts, okay? I'll label the parts. Otherwise, you'll get confused, I have a feeling. Ischium, pubis and coxa, it will all fuse to coxa, that I will show you now. But before that, try to understand your hip bones. What is your hip bone, students? Why the chat's not moving, yeah? Something and all they're talking. Okay? Okay, wait. I'll write it once again. I play. I was seeing if this is the trick only I told in last class. Okay. So, ilium, pubis, ischium will fuse together to form coxa. Okay. Okay, this is the trick I told. So, students, this is the trick I play in class. So, what do I mean? I stands for ilium, P stands for pubis, I stands for ischium. All three fuse to form the coxa. Can you see this blue color? Right, they fuse and this is coxa. Right, coxa. This one. Okay. Can you see that? So, ilium, ischium, pubis forms fuse and form coxa. It is given here. Look here. Pelvic girdle consists of two coxal bones. Each coxal bone is formed by the fusion of three bones. I play in class ilium, ischium and pubis. At the point of fusion of the above bones is the cavity called as acetabulum. Okay, the cavity is called acetabulum, to which the thigh bone articulates. So, there we studied glenoid cavity is there, where the humerus will come and bind. Here they are talking about the femur bone will come and bind to the acetabulum. This much you can remember, right? To which the thigh bone articulates. The two halves of the pelvic girdle meet ventrally to form the pubic symphysis containing the fibrous cartilage. Okay, I play in class ilium, ischium, pubis. Ilium, pubis, ischium. Okay. Chalo. Now, students, last topic we have is fibrous joints. That means the joints which are movable, the joints which are not immovable, and the joints which are freely movable. Okay. Now, fibrous joints do not allow any movement. Example: sutures on your skull. Okay, this is how your skull looks, right? This is how your skull will look. On the skull, there will be sutures. Okay, like the sutures will be there, no? These sutures, do they move because you're moving your head? No, it does not move. So, fibrous joint do not allow the movement. Remember sutures, okay? Do not allow any movement. This type of joint is shown by a flat skull bone which fuse end to end with the help of a dense fibrous connective tissue in the form of sutures, okay, to form the cranium. So, sutures, fibrous joints which will not move how much ever you move, okay? Then, in cartilaginous joint, that means slightly movable. Which are the ones that are slightly movable? Your sternum, right? Sternum. So, those are slightly movable. Yes, after this break only. After this, I'll give you a good break. In cartilaginous joint, the bones involved are joined together with the help of cartilage. The joint between the adjacent vertebrae in the vertebral column is of this pattern and it permits limited movement. Okay, here students, think of cartilage joint. Example is your sternum, ribs are the example. That means slightly movable, not more moving, slightly movable. Now, synovial joints are the characterized by the presence of fluid-filled synovial cavity between articulating surfaces. That means like how I can move my hand, because here synovial fluid is there. That's why I'm able to move like this. Yes. Okay, surface of two bones. Such an arrangement allows considerable movement. These joints help in locomotion and many other movements like ball and socket joint, that means between the humerus and the pelvic girdle. Okay, then hinge joint, my knee joint, right? Knee joint, pivot joint between my atlas and axis, this atlas and axis. Okay, then gliding joint between my carpals. Okay, here this one between my carpals. This look like one Zumba class. Between my carpals. Then saddle joints between carpals and metacarpals. Okay, carpals and metacarpals here. Carpals and metacarpals. Okay, and Metacarpals of the thumb are some examples. So very important, synovial joint. How are you going to remember? Ball and socket. Ball and socket joint. Then we have pivot joint. Then we have carpals, hinge joint. Okay. Then we have atlas pivot joint done. Gliding joint. Last one is saddle joint. Okay. BSS, PHG. Okay. BSS, PHG. This is how you will remember. Basavasauruses, BSS, Basavasauruses. PHG, I don't know how you will remember. PHG. PHD, no, like that. Okay, PHD, no, instead of that, think PHG. Okay, PHD, no, like that, think PHG. So here it is ball and socket, saddle joint, pivot joint, hinge joint, gliding joint. Easy, no? PHG. Okay, we are done. We are done. Now disorders. Myasthenia gravis is an autoimmune disease. That means they're not able to recognize our own cells. They're killing our own cells. So it is an autoimmune disease where they kill the self cells, right? So autoimmune disorder, what happened? Basically, the person will get paralyzed completely, or their entire body will start weakening. Okay. Then muscular dystrophy is basically what happened? Degeneration of the skeletal muscle. Slowly the skeletal system will start degenerating. That is degeneration of the skeletal muscle, mostly a genetic disorder. Tetany, rapid spasm of calcium will cause, what happens? Continuous rapid spasm of calcium will keep making the actin and actin's myosin binding site to be visible, no? So same way, rapid spasm will lead to wild contraction, and then they will not be able to relax so easily. Okay. Then arthritis, inflammation of joints. Okay, this question has been asked, students. Now osteoporosis, that is age related, the bone mass reduces. Okay, the bone mass will keep reducing, so easily they will get, you know, fracture, damages very easily. That is mainly in old age people. Okay. Then gout. Here very important thing is decreased level of estrogen is a common cause. To maintain the bone mass, actually estrogen also helps. That is to maintain the calcium level also. That is why when the estrogen level decreases in old age people after menopause and all, estrogen level will decrease. That will lead to osteoporosis. Okay. Then gout, inflammation of joints due to the accumulation of uric acid crystals. Uric acid crystals. Okay. We'll take a break now. After that, you have to do some questions of locomotion and movement. Okay. After a break, you will take a question. Okay. Now it is 5:22. Where do I write? Yeah. So let's some empty slides. Okay, I'll write it here. Okay. Okay, resume back at 5:45. 20 minutes break you have. After that, you will do locomotion question and then we'll start excretion. Okay? Yes? Yes, locomotion completed. Take a break and come. Even my throat is cracking, so we'll take a break. 5:45, you all be back. Okay, 5:45, all of you be back. 5:45, 5:50. Okay, by 5:50, all should be back. Okay, then we'll do excretion. Okay, bye students.
Ah. Welcome back to Vedantu, Neet English students. How is everyone doing? You will see us coming here and there in and out of the class because Gopika Ma'am and all of us, Shreyas, Diksha Ma'am, everyone is in studio today. So you will keep seeing us coming into the studio, going out of the studio, and working in the background. We are actually planning a lot of things in the background. Today itself, we were planning for block 2. So students, tell me in the chat if everyone is excited for block 2. Tell me in the chat. Is everyone excited for block 2? So today is the end of block 1. See, in block 1 from botany side, we did your plant physiology. In the case of your zoology, we did your human physiology. Likely we did your modern physics as well as inorganic chemistry. So are you excited for your block 2? Tell me in the chat. Hello everyone. Are you excited for your block 2? So students, we were thinking, Gopika Ma'am and I were thinking, what is that one chapter which we are not done yet? That is, there's one chapter, right? There's one chapter which is all of you are asking for. One chapter where we can actually be like, okay, fine. This chapter was missing from your Super 6. So we'll be completing that in your block. Which is it? Can anyone guess in the chat? Which is that one lecture which is missing? That is gonna be, students. That is gonna be. Can anyone guess? In block 2. Which is gonna happen this week itself. It is gonna happen this week itself. Can anyone guess? Yes? Try guessing, students. Try guessing. Exactly, Subhashini. It's gonna be your biotech. It is gonna be your biotech. We'll be doing biotech this week itself. And students, trust me, for the next 3 days, we have a lot of surprises for you. Lot of surprises for the next 3 weeks. That is tomorrow. We will be doing an amazing class tomorrow. Amazing class where all the 4 teachers will be there. Again, day after tomorrow, we have one more special class for you. The day after that, that's going to be Friday. On Friday also, we have a dedicated session for you. Friday. The students, stay tuned because there's going to be so many classes every single day for your preparation. Until your NEET examination, every single day we'll have a special class and which will make you confident every single day. Right? Every single day. Biotech, Clear? Cool. So can we call Gopika Ma'am? Yes? We can call Gopika Ma'am. Yes, ma'am.
Did you tell them secret? Huh?
No, I was just telling them what we have planned for them for the next 3 days, ma'am. Right? For the next 3 days, it's going to be so much fun. It's like a festival. We are the next 3 days, we'll actually make you solve so many questions in so many different ways. One of the disclosing is we'll be doing something called as AR questions. No, not more than that. That's all I'm going to tell you. That's all. We'll have a dedicated session for AR.
Okay. So, thank you, sir. Yes. Students, are you all ready? Wait, I'll just drop a message in the Telegram. Yeah. I think all of them will be like, oh, break is still happening.
I'll do it.
Yeah. 1 second. Yes. Thank you. Okay, locomotion, thorough. All thorough locomotion questions will be ready to answer. Yes. Okay, got it. Yes, they're telling. Let's see if you'll be able to answer or not. Yeah? Fine. Okay, let's start. 1 second, students. I'm dropping so many things. One second, give me a minute. Yes, ready? Let everyone join. I think most of them, I don't know where they went. Yes, 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 yes. Tudun. Shall we start? Okay, fine. Let's start. Students, you have to answer fast so we can move forward fast. Okay, first question. First question. Okay, fine. First question. Which of the following is present between adjacent bones of the vertebral column? It is a 2022 question. Okay, 2022 question. All of you tell me in the chats what's the answer. Which of the following is present between adjacent bones of a vertebral column? They are asking about who? They are asking about the bones, right? Bones. Yes. Answer 2. Two is the answer. All of you. I don't think all of you are telling. Only few of you are telling. Yes, yes. Let's see what's the answer. 3 is the answer. Wait, let me see. Which of the following is present between the adjacent bones of the vertebral column? Cartilage? Cartilage or? Okay. Intercalated disc is correct. Yes, intercalated disc is correct. But majority of students had answered cartilage. Okay, but intercalated disc also is correct. So this question we'll have to, I don't know why majority answered this. Okay, I'll just check with that students. Maybe some error would have happened. Don't worry. Okay, now look here. Give the two statements. Osteoporosis is characterized by decreased bone mass and increased chance of fracture. Reason is common cause of osteoporosis is increased level of estrogen. Increased level of estrogen. Which is the answer? Very easy question. Very easy question. All of you can answer. Yes, intercalated, I'll check that, don't worry. Okay, intercalated disc is the correct. I don't know, maybe some error happened. 1 second, let me, I think it is cartilage only. I don't know what is wrong. Maybe let's see students, 1 second. Yes, cartilage is the correct answer. Cartilage is the correct answer. Okay. Intercalated disc here are cell-to-cell junctions found in the cardiac muscles. So this one is cartilage is the answer. All of you told wrong. Cartilage itself is the answer. Okay. Fine. Fibrous cartilage as intervertebral disc. Okay. Intervertebral disc. So I think you people got confused with intervertebral disc and intercalated disc. This is a cell-to-cell thing. Okay, that is present between the cartilage. So cartilage is the answer. Please don't make mistakes. Yes, 4. Very good. Very good. Okay, next one. Which of the following is the correct match for disease and its symptoms? Okay, muscular dystrophy, arthritis, tetany, myasthenia gravis. All the options are there. Students, yeah, cartilage. Got it? No? Those who made mistake, cartilage. Okay. Now, look here, match the following. Muscular dystrophy means what? A genetic disorder resulting in weakening and paralyzing of the skeletal, or is it an autoimmune disorder causing Students, do you understand? Something is ulta pulta. Something is ulta pulta. Can you tell which is ulta pulta? Okay, which is the correct match? Huh? Okay. Now I saw the question properly. High calcium level. Okay, got it. Which is the answer? Very good. 2 is the answer, right? 2 is the answer. That is arthritis. And that's why I was like, what is wrong? I thought it was match the following. Then I realized, here see, they have interchanged this 2. And high calcium level is tetany causing rapid spasm. Here high calcium level causing rapid spasm. Okay. Arthritis, inflamed joints. Correct. Okay. 2 is the answer. Yeah, fine. Now, excretion. Ready for excretion? Any doubts? Yes, very good. 2 is the answer. Yes, correct. No doubt in that. Let's do excretion. Ready? Excretion ke liye, are you ready? Ready? Yes. Yes, students, understood. 2 is correct. Okay, okay. Agreed. Totally agree to all of you. Okay. Okay, fine. Let's start. Okay, now what is excretion? So excretion is usually misunderstood with digestion, right? Excretion is usually misunderstood with digestion. Why is it misunderstood with digestion? Is mainly because when digestion happens, your fecal matter or your undigested food is given out. Undigested food is given out. Yes or no? As fecal matter. But people get confused. In this chapter, what are we focusing on? In this chapter, we are only focusing on excretion, means basically urine formation or expulsion of urine. Yes or no? Okay, this is what we are talking about in this chapter. Any doubts in this? No, right? Excretion means basically we are talking about urine formation and expulsion of this urine. Now, when I talk about waste, what are the things, like how do this waste material get created? Very simple thing. When we do any kind of metabolic activity, waste material gets released out. That means you can otherwise say nitrogenous waste, right? So nitrogenous waste is given out when we are doing a metabolic activity. Okay, nitrogenous waste is given out when we are doing any kind of metabolic activity. Students, I need you to give me a lot of energy because it's not easy to stand and teach continuously. So all of you should be active. Those who joined right now, quickly like the session. Okay, I'm going to check the attendance. All of you quickly like the session and wait 1 second. Let me check the like of the session. All of you should like the session and be like, yes ma'am, we are there with you, and you should give me the energy. Okay, you should give me the energy. Otherwise, I'll get tired, no? Talking alone to the camera and walls and everything. Yes. Fine. Okay, very good. So that much is clear. Very nice. Awesome, awesome. That is the energy of my students. Very good. Yes. Okay, so here nitrogenous waste is given out because of any kind of metabolic activity. Is there only one nitrogenous waste? No. In this chapter, you are going to study 3 nitrogenous waste, that is your ammonia, okay, ammonia, urea and uric acid. Ammonia, urea and uric acid. These are the people we are going to discuss in this class. Okay, ammonia, urea, uric acid. Now, what is this excretory system? What does this excretory system have? Right, that thing also we have to learn. So, let's draw a small system. We have 2 beautiful kidneys, bean-shaped reddish kidneys. From there, we have 2 ureter that is extending. Okay, 2 ureter that is extending. Okay, and then we have urinary bladder and we have urethra. This is our excretory system, right? This is our excretory system. Okay, this box may we will, like museum piece, we'll keep it. So, these 2 kidneys, from the kidney there is ureter which will go into the urinary bladder. This is the entire excretory system. But other than the excretory system, we also have one more function done by these people, which is called as osmoregulation. So, they do one more function called as osmoregulation. Osmoregulation means what, students? Salt and water balance, right? This is the entire chapter. Okay, this is what we are, this is the introduction basically. Anything that you want to understand. So, here, should we just label this? Shall we label this? Kidney. Okay, ureter, urinary bladder, urinary bladder, and down we have urethra. Down we have urethra. This is the excretion. So there is excretory waste, there is other job done is called osmoregulation, salt and water balance, and this is our excretory system. Okay, now that we have understood that, let's try to understand osmoregulation. Okay, 1 second students. Let's try to understand osmoregulation. Now, when I talk about osmoregulation, you should know it is basically salt and water balance. Like I told you, salt and water balance. Okay, salt and water balance. Okay, what is happening? What is happening? Are you all there? Okay, good job. Now, other than that, now what do we need to know? We need to know a very important graph which you have already studied with Basava sir, but I am going to teach you again. Okay, we have a very important graph to know, that is depending on the osmolarity, how many type of organisms are there? Are there different types of organisms? Yes, there are different types of organisms, right? So, osmolarity of the external conditions, okay, and osmolarity of the internal, okay, of internal. Okay, now students, depending on if they are able to regulate the temperature, like balance of salt and water is depending on what is happening outside, those are called as osmoconformers. There are osmoregulators like us. We will be like, no, whatever happens, I am going to use my energy and do the rest of my job, right? Now look here, all of you, this one. Now if we start like this is one graph. Okay, I'll first draw all the graph, then I'll explain you. Yes, line coming straight. Yes, okay. But it looks fine. Looks little slanting, no? 1 second, students. Let me try. Yes, okay. Now I've drawn 3 lines, okay. So let's start with the pink one, that is called as osmoconformers. That means I am going to regulate my osmoregulation depending on what is happening outside. Simple, job is easy, you know. Whatever is happening outside, oh, this is happening, so I will also go along with that. Now imagine Ugadi celebration is happening. I am a NEET aspirant, but still I will do osmoconformer. That means everyone is celebrating Ugadi. Why should I only be the one who is sacrificing? Those are called as osmoconformers. That means whatever happens outside, they are very interfered with that, and they will regulate depending on that. Osmoconformers. Okay. Now in osmoconformers, can anyone tell me the example? Definitely the example is going to be smaller organism like invertebrates, but I also told you an exception. Can anyone tell me the exception? It starts with M. M, exception. Can anyone tell me the exception in the chat, all of you, quickly? Then blue line, by the time you tell the example, I will write the next one. This is called as osmoregulators, like us. That means whatever happens outside, I will maintain my own character, I will maintain my own personality. There are people like that, no? Very good, Subhashni. Mycene, right? Mycene is the one that is an exception. Okay, and then osmoregulators, that means no matter whatever is happening outside, I am going to maintain what I have. I will not change according to what is happening outside. I want all my NEET aspirants to be like that. Yes or no? I want all my NEET aspirants to be like that. Are you doing that? Like whatever happens outside doesn't matter. I will just focus on classes. Okay, all vertebrates. Okay, all vertebrates. Now I've drawn one thing in green. What is that? They are partial osmoconformers. That means starting they would have had the energy to do osmoregulation. That means, okay, no matter what is happening outside, I am going to focus on my studies. First 2 months, they would have focused on their studies. After that, they'll be like, hey, I cannot do NEET. Yeah, this is not my cup of tea. I should just do something else. And they would have changed depending on what outside people are telling. They are called as partial osmoconformers. Okay, partial osmoconformers. Example is elasmobranchs, shark and race. Okay, shark and race are the example of partial osmoconformers. Got it? So you should not be partial osmoconformers. You should be Osmoregulator. Okay, you should be osmoregulator. Is this clear? Chalo, let's go to the next basic part. Okay, yes, shark and rays have written, or you can write elasmobranchs. Now, look here students, ammonia. Now, I told you there are 3 excretory waste materials: ammonia, urea, uric acid. Now, the question to all of you, which is the one that we give it out? Which is the one that we give it out? Urea, right? Now, look here, ammonia is the most toxic among all of them. Okay, most toxic, requires a lot of water for removal, readily removed. That means we cannot keep it even for some time in our body. Immediately ammonia has to be converted into urea with the help of urea cycle or ornithine cycle with the help of liver. Okay, now it has to be readily removed from the body surface by diffusion. Can we wait for kidney to come? See, there will be always a friend with you whom you will call now, who will pick the call after 2 hours. Then we'll be like, what happened, bro? By then you would have already been like, oh, I almost died. So yeah, I have reached heaven. So thanks for calling after 2 hours. Like, you'll all have a friend. I'm a friend like that. Okay, I always pick the call after 2 hours. So my friends will call. They'll be like, we have an emergency. They'll be calling for that. But I will be like, oh, what will this fellow tell? What will this girl tell? Every time they'll tell the same thing. So I'll give the correctly, that will be the emergency times. No. So like that this is. We cannot wait for the kidney. Kidney will be like, okay, I'll aram se come. I'll do excretion. Slowly I will do everything. Then I'll remove this ammonia outside. Who has the time? By then we will vanish. Okay, we'll be in heaven. We'll be like, okay, thank you kidney for coming and helping me. So for that we do not have time. So what we will do? We'll readily remove it from our body surface. Okay, are you a friend like this? Yeah, even me, I will look like this. Oh, that person is calling. No, nice. Why is this person calling? I'm like that. Okay, that friend is me. Okay, so no role of the kidney because no time for the kidney to come. And it is NH4 plus ions. Okay, NH4 plus ions. Clear? Yes, fine. Great. Next one. See, an organism which is giving out ammonia is called ammonotelic organism. An organism which is giving out ammonia is called ammonotelic organism, and the process is called ammonotelism. Okay, the process is called as ammonotelism. Examples, very, very important: sponges, cnidarians, bony fishes, and aquatic amphibians. Okay, sponges, cnidarians, bony fishes, and aquatic amphibians. Now, urea and uric acid. Now, we give out urea or uric acid. Okay, right? Yes. So many other like me in the class, so I don't feel offended. Now, students, urea. It is the least toxic. I mean, it is less toxic compared, not least, less toxic compared to ammonia. It requires less water, again compared to ammonia. We are comparing to ammonia, okay? Less water. It is, we give out urea, right? We give out urea. Is this clear? Okay, we didn't come there. Wait 1 second. Okay. Now what, students? It does not require a lot of amount of water. Now, important thing is, if at all ammonia is there in our body, by any chance ammonia is there in our body, then that has to be immediately removed with the help of urea cycle or ornithine cycle. Okay, with the help of liver, and convert it to urea. This way we will be able to save, right? We will be able to save ourselves, because ammonia is very, very toxic for our body and we cannot keep ammonia in our body. Got it? And it is less soluble in water, and the organism which give out urea is called as, what is it called as? Uricotelic organism. All of you know this? Uricotelic organism. Organism that gave out urea is called uricotelic organism, and the process is called ureotelism. 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 Okay, sometimes students, I might tell something wrong. Do not worry, it's because I'm continuously talking, but I would have written it correct. Okay, don't be like, oh ma'am, you told this wrong, that is wrong, this is wrong. Okay, don't just pounce on me. Be calm, be kind, be calm. Nothing is going to go wrong, right? Uricotelic and ureotelism. Okay, now what is the examples of this? First example we can remember is mammals. Okay, first example we remember is mammals. Then which, students? There we told bony fishes. So here can I write cartilaginous fishes? Yes ma'am, you can write cartilaginous fishes. Cartilaginous fishes. Okay, and some of the amphibians as well. Okay, amphibians. Got it? Clear? Mammals, cartilaginous fishes, and some of the amphibians as well. Okay, that is specially adult amphibians. Okay, specially adult amphibians. Fine. Next one, your uric acid. Uric acid is the birds. All of you will remember this. No one will ever forget this. I'm sure for sure. Okay. Okay, so here uric acid, least toxic, but we cannot afford it. Okay, it is the least toxic, but we cannot afford it. Least toxic, requires less, like least water. Okay, almost less water than urea. But there is a problem. The problem is that this is a very expensive process. What is expensive meaning? That means we need a lot of ATP while giving out this, right? So this can be only given out specially by our birds, aves, and most of the reptiles. Most of the reptiles. Okay, and the organism which gives out uric acid is called uricotelic organism, and the organism, the process is called as uricotelism. Simple, uricotelism. Okay, yes, all of you remember? Yes, very good. Lot of energy is required, right? Lot of energy is required, and that energy we do not have. We only hardly have energy. Now in our class, so many students are there, hardly they would have eaten food and they'll be sitting in class. Now for in that also we have to give more energy, we cannot know. So crow and animals, they are happy, the reptiles are happy in giving this, and this will be in a semi-solid form or the pellet form. Right, pellet form. I have already told you a lot of story about this. I am not repeating the story, but if at all a crow has ever given you a blessing, that will be in the uric acid form. Okay, chalo, next one. Now students, animal kingdom, we have to know some. You have to answer all this. Come on, all of you answer. All of you answer quickly. Ma'am will sit for some time. All of you answer. Platyhelminthes will give out what? Nephridia. Oh no, did I write nephridia? Yes, those who are new to this class, quickly smash the like button. Yes. Answer? Claim cells. Aha. Yes. Platyhelminthes, protonephridia. Awesome. Students, I don't know why I wrote this. I think I was sleepy. Protonephridia. Nephridia. Earthworm. Very good. Earthworm. Insect. Malpighian. Tubules. Then prawns. Green gland. Right? Nephridia, yeah, you can write Annelida or earthworm, okay? And prawns, green gland or antennal glands, okay? Green gland or antennal glands. Done? Yes, Malpighian, very good. Malpighian tubules, fine. Let's start here. Students, this human excretory system, first diagram I already drew. Now we'll try to understand that. Okay, we'll try to understand that. Look here, two kidneys are there. On two kidneys, two topes are there. What are those topes? Adrenal gland. Okay, so the topes are adrenal glands. Two kidneys are there. They are bean shaped, reddish brown color. Okay, they are bean shaped, reddish brown in color. And ureter, already you know. Urinary bladder, urethra. On the urethra, there are two sphincter muscle. Internal sphincter muscle, which is not in our control. External sphincter muscle, which is in our control. Okay. Now look here. Okay, this I'll tell you. First, let's try to understand what is this kidney. Where is this located? Okay, look here. This kidney is a retroperitoneal organ. That means in our body there are some spaces. Okay, in our body there are some spaces like intraperitoneal and retroperitoneal. So all the organs that come in the retroperitoneal space is called as retroperitoneal organ. You will study this completely in your MBBS as a full portion, where you will study about the space or the cavity, and you will also study which are the organs there, and you will also study how the peritoneum is covering them. Okay, right now just understand simple thing. Kidney is a retroperitoneal organ because see, this is your body. Okay, it is divided into two cavities, intraperitoneal and retroperitoneal. Okay, and there is a mid lining called as peritoneum. Now, this peritoneum will cover the kidney in a different way. That also I will show you. This much you remember, kidney is a retroperitoneal organ. That means kidney is falling in the retroperitoneal space. Fine. Done that. Now, I asked you this question also. Renal artery carries oxygenated blood. But does that mean it does not have any toxic content in the blood? Answer all of you, yes or no question. Kidney, okay, that means the renal artery is carrying oxygenated blood. Does that mean that oxygenated blood have no toxicity? Yes or no? No toxicity. If you are telling yes, you are telling ma'am, there is no toxicity. If you are telling no, that means toxicity is there. Did I confuse you people? Okay, did I confuse you people? No clip, no? No, very good, very good. That means even though the blood is oxygenated, it will have toxic content. That means some amount of urea will be there in this blood that will be removed by the help of kidney. Kidney's job is not to add oxygen. Kidney's job is to remove the nitrogenous waste. Okay, very good. Most of you have answered. Now, students, retroperitoneal space is clear, no? Now, look here. Kidney is surrounded by retroperitoneum. How? On the ventral side of the kidney. Now, look at this. This is the space. Okay, this is the space. This orange color which I have drawn, this one, is your retroperitoneum. So, look how it is covering. It is, this is the kidney. The pink color ones are the kidney. It is only covering on the ventral side. Okay, kidney is like this. This is the space. Kidney is like this. How it's covering? Only it's covering on the ventral side. Okay. Now, it is metanephric, retroperitoneal, situated from the thoracic 12 to the 3rd lumbar region. Very, very important question. Very, very important, where the kidney is located from the 12th lumbar, thoracic, that means the last thoracic to the 3rd lumbar region. Thickness is around 2 to 3 centimeters, width is around 5 to 7 centimeter, length is around 10 to 12 centimeter, and weight is around 120 to 170 grams. Okay, 170 grams. Is this clear? Okay, fine. Now, this retroperitoneal also is clear, I hope. Now, longitudinal section of kidney, like let's draw it. Okay, let's draw it. Ready, ready, ready. Okay, so students, look at this. We have to draw the kidney. Wow, what a marvelous kidney. Bombastic, elastic. Marvelous. The biggest task is drawing a kidney, students. Yes, better? Better, better? Better kidneys, yes. Okay, fine. Now, let's start with the outer layer. Okay, students, this is the kidney. Okay, that last time I had drawn a better kidney, but this time I don't know why it's looking like this. No problem, life will happen. So, let's try to draw the outside layer of the kidney. So, students, outside we have protection. Right, such a complex kidney doing lot of job. So, we have to make sure that this kidney is protected. So, there is the first layer. There's one layer of protection called as the renal capsule. Okay, first one layer is there called the renal capsule. It will be lining the entire kidney. I will draw only in the one portion. Okay, one portion we call as renal capsule. Okay, then on top of that, like one spring structure I will be drawing. That is your are you all there with me? Yes? Okay, all are there. See, like this one structure will be there, which is your adipose tissue. Adipose tissue. Okay, like this will be there, just like a cushion. And on top of that, there will be renal fascia. This renal fascia word, where did we study some time back? We studied it in our locomotion, right? Keeping all the bundle together, we have renal fascia. Okay, so this one is what? Renal capsule. Renal capsule. Okay, then orange color, no? This is adipose tissue. Adipose tissue. Okay, this is fascia. Okay, don't get it confused. Anything to do with renal is kidney. Other things you leave it off. So this is the envelope. So together, renal fascia, adipose tissue and renal capsule, together I will call it as the renal envelope. That means anything that is protecting the kidney. Okay, anything that is protecting the kidney will be called as renal envelope. Okay, envelope. Okay, envelope. Now, let's get into the internal part of the kidney. You all know that kidney is divided into two regions. What is it? Cortex and medulla. Okay, kidney is divided into cortex and medulla. Right? Look here. This is the cortex portion. The yellow color portion is the cortex portion. This is the medulla portion. Now, most important thing that we have to draw is medullary pyramids. Can you all see red color? Medullary pyramids. Okay, so this is your medullary pyramids, which are extending from the cortex to the medulla, more towards the cortex and less towards the medulla. Okay, medullary pyramids are there. On this medullary pyramid, students, your nephrons will be there. Who is nephrons? The basic structural and functional unit, right? Your nephrons will be aligned like this. Can you see? I think orange is not visible. Okay, blue color nephron, first time in India. Okay, blue color nephron. Yes, like this nephrons will be there on the medullary pyramids. Got it? Fine? Yes or no? Fine. Now, after this, you understood this is cortex, so I will just label this also. Cortex. Okay, then this portion is the medulla. This portion is the medullary pyramids. Okay, medullary pyramids. Now students, there are small other regions. Okay, 1 second. Yes, there are small, you know, like foldings. Okay, like I tell you know, gully like structures, which are, see, like this, like this, like this. The small like this openings. Okay, called. Okay, that region we have to know. Got it? Yes or no? What are those regions called? Renal papillae. Okay? Yeah, I will. People are telling me. 1 second. Yes, renal papillae or renal calculi. Yes? 1 second, students. This, I don't know that much. Yes. Huh. If it stays, it's good. If it does not stay, it will fall off. Yes. Huh. Okay. So students, look here. You have this yellow color structure which I have drawn is called as renal papillae. What is it called? Renal papillae. Now, after that, you have a wide opening. Can you see this wide opening? This wide opening is called as your renal pelvis. But before that also, there are small grooves. If you see here, you can see small grooves which are called as the minor calyx. Okay, I will label that. First, let me label renal pelvis. Okay, there are small grooves, students, which are called as renal minor, this one is called as minor calyx. This minor calyx will open into the major calyx. major calyx, and this major calyx will open into the renal pelvis. So understand like this, there are small grooves, minor calyx will open into the major calyx will open into the what is that, renal pelvis. Okay, this is how your urine will come out, or your blood flow also will happen. Is this clear, students? Kidney is clear? Kidney is clear? Tell me quickly in the chat box. Okay, so what did we learn now? Kidney has two regions, cortex and medulla. Okay, cortex and medulla. Okay, now I told you when urine formation happens, right? When urine formation happens, I told you how it will come from renal papillae. It will open to the minor calyx. Okay, from minor calyx to major calyx. Major calyx to renal pelvis. Got it? That's how it happens. Okay, this is the flow chart. Yes? Yes, clear? Okay, full clear? Okay, awesome. Okay, students, this is the labeling of your kidney. That means the longitudinal section of the kidney. If your kidney is a bean, right, a bean like this. I don't have a bean, students. What do I have here? Nothing I have here to show like a bean, okay? Dr. Vijay, I will motivate you. Very good. Good job. Keep going, okay? And crack Neet. Kerala Kuti. What is Kerala Kuti, guys? Yes. Okay, next one. Look here, we have to learn the muscles of the ureter. How is this ureter going to do peristalsis movement? Okay, peristaltic movement, that we have to understand. Okay, last time also I taught you this very simple thing. What is the structure? Okay, look here, this is how your ureter, I am just enlarging your ureter and drawing. So students, this ureter will have 3 layers. Okay, 3 layers. First one is called your, all of you can tell me, first layer is called your transitional epithelium. First layer is called your transitional epithelium. This green color layer which I am drawing, okay, is the transitional epithelium. This is important for you. Transitional epithelium. Transitional epithelium. Okay, transitional epithelium. After transitional epithelium, can you all think? Connective. Remember connective? We have learned between connective and what is there? Muscular. Muscular layer is there. Okay, one kutti muscular layer is there. And after that you have some connective tissue. Okay, some connective tissue. That's all. That's all you have to learn. Easy peasy lemon squeezy. Okay, connective layer. So you have a transitional epithelium in the first layer, then you have a muscular layer, then you have a connective layer. Now this will help in the peristaltic movement. That means for the urine to move down, right? For that peristaltic movement, this is going to help. Peristaltic movement. Okay. Now next one. Same thing with urinary bladder also we'll try to learn. So let's draw the urinary bladder, students. Same muscles are there, okay? Same muscles are there. But you need to learn a little more in this. I'll tell you what is it. Let's keep the colors same. So first we have a transitional layer, okay? First we have a transitional layer. Okay? Transitional epithelium is there. Very simple. Okay, transitional layer. Then after that we'll have a muscular layer. Bye. I'll give a break. You people go. Okay. Okay. But sir. If you guys are going now, get me something to eat. Yeah, take biscuit or something. Only a biscuit here. Yeah, biscuit if you want. Take it. Okay. Yes. Sorry, students. Okay, look here. Transitional epithelium, same color. Let's keep. After that, there is a muscular layer. Okay, there's a muscular layer. I'm drawing it separately, but obviously in our body it won't be like this separate. Muscular layer. Now, can all of you tell me which is the muscle that is there? It is? Let me ask you people. Come on, muscular layer. Which is the muscular layer? Detrusor muscle. All of you remember detrusor muscle. That is the muscle which will help in this contraction of the urinary bladder. Detrusor muscle. Okay? Detrusor muscle.
How was it going, ma'am?
Baswa sir is not calling, sir is asking.
I'm not calling anyone.
No, he's there telling me that ma'am sir is calling.
No. I was just telling ma'am. Ma'am, how's the session going?
I don't know, you should ask them. Ask them.
Students, how is the session going on? Let me know in the chat.
How's the session going, students? Is it boring, good, bad?
Boring.
No, I'm just asking. Students, tell.
Super.
Oh, sweetie.
It is like always on the super.
Others, all I did.
Super. See, everyone's saying super. So that's what we were planning for, what to do tomorrow and any shots we have to do. So that's what we're doing, ma'am, outside.
Okay, full planning, students. This week is going to be like dub. Have you seen that? Like fudge, one person gets hittings. NCRT, this, like that. Yeah. But like that, we'll get Vedantu Neet English full. Dug. Students, they're all planning without me, students. I'm teaching you here. I don't know anything what is going to happen tomorrow.
Don't worry, it's fine. We'll include you.
We'll include you. Such a favor they're doing for me.
So don't worry, we have a lot of things. I just came to give ma'am some
Energy
and give energy to all of you.
Food. Yes. Because I cannot do photosynthesis, no, students. Please tell someone's name.
Vijay, yes, Vijay, right?
Dr. Vijay.
Dr. Vijay, how is he doing? Vijay, if you want to contact us, you can always contact us on Telegram channel. You can always text me on Telegram channel and I will always reply. And all of you know my Telegram channel, right?
Yes.
That is... You don't know, no?
Basvasauruses. That would be such a name. Basvasauruses botany.
That would be so... It's like an oxymoron. Like botany and
zoology. Okay.
Nice, that would be different.
Yeah, unique, no? Basvasauruses botany. I'll promote your channel everywhere.
Okay,
done. Okay, thank you, sir. Yes, sir came to give me some biscuits so that I do not faint and fall. Yes. So students, this is the best thing about our team. We are all very helpful to each other and we all support each other however long the classes. So I want all of you also to be like that with your friends, with your family, with your future NEET classmates. I want all of you to help each other. Don't have jealousy, don't have selfishness. No, I have to become bigger. Because actually when you walk together holding hands, you walk faster, you walk better, whatever hurdles come in front, you fight for it. When you walk alone, no, at one point you want to give up, right? So always walk together, but always know if it's not worth it, don't walk together, okay? Yes, students, so here we have transitional, then we have muscular layer, then we have connective tissue, right? Then we have connective tissue. Now, I told you detrusor muscle is the one who is helping for urinary bladder contraction, right? For urinary bladder contraction, who is going to help? Detrusor muscle is going to help. Now, the most important thing that you need to know is, in the urinary bladder, there is something called as trigon of bladder. How many of you know this? I've told you in the last class. That means, students, basically, I'll draw it and show it to you. 2 ureter is opening. Okay, 2 ureter is opening. Okay, and 1 urethral opening is also there. Okay, wait 1 second. This color. I think Gopika Ma'am's biggest problem is choosing color. No, students, don't you feel? Okay, so it is called trigon of the bladder. That means 3 openings. Okay, what is it called? Trigon of bladder. So 2 ureter opening and 1 urethra opening. 2 ureter, 1 urethral opening. That makes a trigon of bladder. Okay, trigon of bladder, 2 ureter opening and yes or no? Got it? Is it clear? Trigon of bladder, that is 2 ureter opening plus 1 urethra opening. Urethra only I wrote a urethral opening. Yes, urethral opening. Okay. Now, most important thing about urinary bladder is the presence of sphincter muscles. Okay, here presence of sphincter muscles is there. That is, see, here muscle 1, that is internal sphincter muscle which is not in our control, and then the external sphincter muscle. Okay, internal sphincter muscle, external sphincter muscle. Internal sphincter muscle is when your urinary bladder, imagine you're in a class. Okay, the teacher is very strict. What you will do, when you fill your urinary bladder 500 ml, you will go and ask your teacher. She'll be like, no, go and sit back. Then you'll be like, okay fine, you'll go and sit. Then it'll become 550, 600, 700. You'll be like, oh no, I can't, right? That situation will come. That is because your external sphincter muscle is no more able to control and it will open. Okay, internal sphincter muscle is an involuntary muscle, it's not in our control. External sphincter muscle is a voluntary muscle which is in our control. That's when we realize, okay, I need to use the washroom. Got it? Now, so normal capacity of your urinary bladder is 700 to 800 ml. More than this, it cannot hold. Okay, 700 to 800 ml. More than this, it cannot hold. Is this clear, students? Easy? Easy? Sphincter muscles are easy? Yes. Now, for micturition to happen, that means for the urine to come out, what has to happen? Your sphincter muscle, if they contract, there is no space. If the sphincter muscle relax, only the urine will come out. So, the sphincter muscles have to relax. Okay. Sphincter muscles have to relax for micturition to happen, and your urinary bladder has to contract. Okay, urinary bladder has to contract. This is how micturition will happen. Micturition means expulsion of urine. Now, in some old age people, incontinence happen. That means the stretch receptor which is present on the urinary bladder will not be able to understand that the urinary bladder has got full, and it will not send a signal to the brain. So, what will happen? Incontinence happen. Okay, incontinence happen. Where's the AC remote? Students, 1 second. It's too cold here. Yes. Okay. So students, what did I say? Sphincter muscles understood. Micturition will happen. Incontinence will happen for older people. That is because the stretch receptors on the urinary bladder will not be able to send signal to the brain telling that the urinary bladder got full. So urine leak will happen. Okay, incontinence. Don't forget to remember that. Now, let's start. Nephron. What is nephron? Nephron is the basic structural and functional unit of your kidney. Yes or no? So, if you see here, there is a glomerulus and a Bowman's capsule. Look, Bowman's capsule is a cup and glomerulus is this. Okay, glomerulus is the blood capillaries which are running. So, there will be afferent arteriole, efferent arterioles, and then there will be tubules extending. Okay. Now look here. Glomerulus, you can see Bowman's capsule, you can see extending, you can see PCT, loop of Henle, DCT, and your collecting duct. Collecting duct is not a part of the nephron because multiple nephrons will open here. Can you see this is an opening? This is an opening. So multiple nephrons will open into the same collecting duct. So you cannot write collecting duct as a part of nephron. Is this clear? What is happening here? Okay, they're talking to themselves. Fine. So here there is an afferent arteriole, here there is an efferent arteriole. So this afferent arteriole is the one that brings the blood, and there is that efferent arteriole which carries the blood outside. Okay, so here you can see blood is coming in and it is going all the way, and there is something called as peritubular capillaries. All of you know, a type of capillaries which has also something called as vasa recta. So vasa recta is a type of a peritubular capillaries which is seen in your loop of Henle. Can you see this connection, how I have made those connections? See how it is extending like this from the loop of Henle and it is connecting to the loop of Henle. This is important for you to know when you learn countercurrent mechanism, because vasa recta against loop of Henle is how countercurrent mechanism happens. Okay, is this clear, students? Very basic, I have just made you explain. I told you this is a medullary pyramid and the nephron is present on the top of the medullary pyramid. That one we have drawn a larger image. Okay, that one we have drawn a larger image. Yes, fine. Okay, now look here. Nephron. Now there are different types of nephron. Can anyone tell me in the chats what is basically different types of nephron? Students, basically nephron is the structural and functional unit of the kidney. That means basically the person who is doing all the jobs in the kidney. Okay, this is what it is. Now nephron, if I have to divide, okay, nephron, if I have to divide, what will I divide nephron into? Students, don't worry, I'll send you this notes tomorrow itself. Today I don't think, tomorrow I'll send you morning. Okay, students, tomorrow we have only for girls session, so do not forget to join. It is for all the beautiful girls out there who are droppers, who are planning to write after 12th. It is specially exclusively for girls. It is an heart-to-heart conversation from our side to your side. Diksha ma'am and myself, we both will be there in the section. Why am I not able to say session? And all the girls, I want all of you to join. It will be something which will motivate you to go further, because we know what are the issues we faced while preparing for NEET, and we know how our families reacted during that time. So it's going to have everything that you're looking for. So send it to all the girls friends who is preparing for NEET, or maybe just like that also, even if they are going for their degrees also, it is a common content for all of you. It will be really, really motivational. Okay, fine. Vasa difference. Why are you asking me vasa difference now? Vasa recta. There is no definition dear. It is a type of a peritubular capillary which will be extending towards the loop of Henle. Okay. Link, yeah, it will be on YouTube itself. It will be on YouTube at 12 p.m. Okay, it will be on YouTube at 12 p.m. So don't worry. Renal tubules and your glomerulus with Bowman's capsule. With Bowman's capsule. Students, do you see my notes? I can teach you the entire chapter with only my notes. Okay, that's because I write every single thing, and I don't know why you people are not downloading the notes. Later you will find it very difficult. Before the exam, if you ask me, ma'am, where's the notes? I will not be in a position to send you the notes. Okay, so now itself download the class and keep. Okay, this duration or that duration, that will be a very short 15 minutes conversation with you people. That's all. Nothing big. 15 minutes. That's all. Okay, students, look here. Nephrons. But I want all the girls to join. Okay, all the girls to join. Nephrons, two types are there, students. Cortical nephron. Cortical nephron. Juxtamedullary nephron. Okay, juxtamedullary nephron. Now, cortical nephron is the one that is present in our body. Around 85% we have cortical nephron. That means cortical nephron is the one where the loop of Henle will be shorter. Okay, they will have shorter loop of Henle, and they will have no vasa recta. No vasa recta. That means since the loop of Henle is shorter, they will not have a vasa recta which is extending. Here, this is only 15%. Okay, this is only 15% of our body. That means a juxtamedullary nephron is only 15%, and this mainly works during the stress condition. That means now if I have not drank ample amount of water, juxtamedullary nephron will be the one working in my body. Okay, it has longer loop of Henle extending to the medulla, and they have vasa recta. Okay, vasa recta is present. Clear? Vasa recta is present. Now, all of you look here. How would the diagram will be? This will be a cortical nephron, shorter loop of Henle like this. Okay, and here the other one will be juxtamedullary, will be longer loop of Henle like this, and this will not have vasa recta on the loop of Henle. It will have only here the vasa recta will be there. Here the vasa recta will extend all the way to the loop of Henle. Got it? Clear? Got it? All of you wrote notes with me? Very good. Okay, awesome. Flow of blood. Can all of you tell me the flow of blood? You already understood the flow of urine. Now can you tell me the flow of blood? Very easy. We start with aorta, the main. 1 second, students. So sorry. Okay. In my hair, nothing will stand. No clips will stand. Okay. So, yes, aorta. From aorta, where will it go, students? Blood. We are talking about blood. We are not talking about urine. You only have to tell about blood. It will go to the renal artery, right? To the renal artery. From renal artery, where will it go? Can you all think and tell me? Renal artery to where it will go? Obviously, it has to go to the afferent arterioles. Yes? So, this is how you should understand how your urine formation will happen. Okay, afferent arterioles. From afferent arterioles, it will go to the glomerulus to your peritubular capillaries. Okay, afferent arterioles. Easy. From afferent arterioles, it will go to your peritubular capillaries. Okay, peritubular capillaries. Peritubular capillaries, then to your renal vein. I don't know if you people focused when I showed the diagram. I had drawn a blue color. See, look here, all of you. I have drawn a blue color thing. Can you see renal vein? So, from the peritubular capillaries, it will go to the renal vein. Otherwise, front of peritubular capillaries, you can also write vasa recta. But since vasa recta is not there in cortical nephron, there is no point of writing it here. Okay. So, aorta, renal artery, afferent arterioles, glomerulus, afferent peritubular capillaries, renal vein. Is this clear, students? Any doubts so far? Okay. And the most important thing here is renal artery will have oxygenated blood plus toxic blood. Okay. Renal vein will have deoxygenated blood plus non-toxic blood. Okay. Intoxic or non-toxic blood. This is the most important thing. That's why you need to know the flow of blood. Okay. Continue. Now, the most important thing, juxtamedullary apparatus. That means what? JGA apparatus. What is JGA apparatus? Okay, students, now for you to understand that, let's see this once. See, can you see how close is my DCT and glomerulus? Glomerulus and DCT is so close to each other. They have a mechanism. They have a mechanism, that is your juxtaglomerular apparatus. It is given as a paragraph in your textbook, but only with a diagram you will be able to understand. Okay? Yes, I keep forgetting. If you people don't comment no after this class, you see, I will not take any more marathons. I will not take block 2 classes. Okay? After so much hard work, if I ask you people, put one comment, you'll be like, no, I don't have the time. I don't have 10 seconds of my life to comment. Nice hittings I'll give you people. Okay? So yes, look here. Juxtaglomerular apparatus is a JGA apparatus. That means glomerulus is very close to DCT. Why is this apparatus there? Very simple thing, students. This apparatus is working because if there is any problem with the filtrate, that means if there is any problem with the filtrate, which filtrate? Your glomerular filtrate, this people will identify it. I'll tell you how they will identify. Now this is an inverted diagram. So you can see Bowman's capsule here. You can see DCT here. Okay, and this is your glomerulus. I told you there is afferent arterioles which enter the glomerulus and an efferent arterioles goes out. Yes, biotechnology unit will be next. Okay, biotechnology unit will be next. Big conjuice of this century you people are. Okay, century conjuice you people are. No one can beat you people in conjuicy. One comment. Nah, what comment? Why are you asking me comment? You stood for 7 hours, so what am I supposed to do? That is your attitude, no, always. Okay, chalo, KD people. Okay, now look here students, afferent arterioles are there. Some cells of the afferent arterioles, okay, look here, I have written here, smooth muscle cells of the afferent arterioles will get modified to something called as juxtaglomerular cells. Why is this modification happening? Simple thing, because filtrate has some gadbad, some problem is there. Okay, some khichdi has happened in the filtrate. That khichdi we have to sort it out. For that, what is going to happen? Some of the afferent arterioles, smooth muscles will get modified to JG cells. Okay, but before that, who understood that filtrate had a problem? I know that you people have a problem of commenting. How did I understand? By checking all my class comments. That is when I understood. Okay. Oh, these people have a problem of liking the session. These people have a problem of commenting the section. For that, I needed a sensor. My brain cells started working. Sensor, right? Same way here also. To sense that the filtrate has some problem, there was a special type of cells called macula densa. Okay, there was a special type of cells called macula densa in the DCT. This macula densa sensed that, oh, there is a problem with the filtrate. Maybe the water level is low, or maybe the BP, that means sodium electrolyte level is low. Some problem is there. Immediately, the sensor cells or the macula densa of the DCT will send a signal to the JG cells. And this JG cells will release renin. This JG cells will release renin, okay? This will release renin. And that renin will do a RAS mechanism to fix the filtrate. It could be anything, students. Glomerular filtrate is low, BP is low, blood volume is low, high, any problem. Basically, all the low problems will be taken care by your RAS mechanism, okay? So, it will release renin. That renin will do RAS mechanism. So, very simple, macula densa cells are present on the DCT, that is your distal convoluted tubule. That macula densa cells are called as sensor cells. They will sense, ayyo, filter has some problem, this filtrate has low GFR rate, low blood volume, some khichdi has happened, now what do? I have to fix this, I cannot send this, right? So, that khichdi will be sensed by macula densa and it will send a signal to JG cells. JG cells will be like, don't worry, Kattappa is here. Don't worry, all problems I will sort. It will release renin. Renin will go and do RAS mechanism and solve all the khichdi and make our urine formation more smooth. Is this clear? Is this clear? Is this clear? Is this not clear? Tell me quickly, is this clear? Not clear? Is this clear? Not clear? Clear? All of you? Thoda energy, solpa energy show madi students. What do you tell it in Tamil? Konjam, energy, chattle, podungo. After this talking Tamil, no, students will give me free class for Tamil. They'll be like, ma'am, every day morning 10 a.m. you will join and I'll teach you Tamil. Students, what do you tell it in Telugu? For little, what do you tell in Telugu? Cheppandi. That means you tell. No. I don't know what you tell it in Telugu. Tell it in Telugu, little energy. That means show little energy is what I'm trying to ask. Huh? Ichiri energy. Yeah, Ichiri. Malayalam I know, students. I'm not a fake Mallu like they told. I'm real Mallu. Little is koncham. Koncham. Oh, koncham in Telugu. And what is it in Tamil? Koncham is in Tamil, no? Yeah, this people are confusing me. Should never believe this, students. Telugu, Tamil. Oh, I mixed Telugu and Tamil. I'm so smart. Koncham energy, calminga, calmingale in Tamil. Okay, fine. Coming go. Energy, coming go, all of you. Konjam and kunjam. All of you coming very fast in the chat box. Okay. If you don't calming energy in the chat box, I will not come for classes anymore. Okay, very strict actions will be taken. Okay, so yes, fine. Yeah. So calming go, all of you. Fast. I'm waiting. I'm waiting for energy. Students, I know Cheppandi. That word. Easy word don't teach me. Difficult words you teach. Students, I know Kannada. Konjam, ma'am. Konjam I told, no? That is chinna, no? Chinna. That some ad comes. So, chinna, asay. Come on. Yes, very good. Okay, very good. Okay, students, let's start urine formation. Easy peasy. Okay, so urine formation basically happens in 3 steps. Okay, after this class, I will get all messages every day. Students telling, ma'am, you have Telugu class now, you have Tamil class now, you have Malayalam class now, you have all the language class, ma'am, because you mix all the languages. Meeru chala. I don't know what these people are testing my knowledge. Yeah, chinna. I know, students. Chinna means small. I know. Okay. So from tomorrow, you people will take for me block 1, block 2, block 3 strategy. Block 1, Telugu class. Block 2, Tamil class. Block 3, Malayalam class. Block 4, some other language class. Yes or no? Okay. So yeah, that is what is going to happen. So I will study, students. Don't worry. I will learn more languages. So yes. Actually, I understand, but I cannot tell it. Okay, I don't know, some part of my language brain is very weak, brain cells are not very active. I can understand completely. I can watch an entire Tamil movie. I understand everything about a Tamil movie. But when it comes to talking, I feel so difficulty. Like how we don't know ha and who in Hindi, no? Like he and she. That problem I have in Tamil. Okay, so people should forgive. Oh, okay. Thank you. Okay. Okay, fine. So they're basically Kannada I know, students. Kannada I know. Okay, come on. Glomerular filtration is the first ever step of your urine formation that will happen in the glomerulus. That means this glomerular filtrate will pass through your Bowman's capsule, no? So through the epithelial layer, endothelial layer, basement membrane, that is what is going to happen. Okay, that is what is going to happen. After that, tubular reabsorption will happen. That is, imagine in the glomerula, like in the glomerular filtrate that has gone to the tubules, what has happened? Lot of electrolytes are there, lot of wanted things have been gone. Okay, HCO3 is there, H plus is there, Na is there, so many things got lost. So that will be reabsorbed to the blood. Okay, third step is, imagine the blood has something that has to be secreted or it does not want it. That will be tubular secretion. Is this clear? Once again, I'll tell you, urine formation basically happens in 3 steps. First thing is glomerular filtration. That means from the glomerulus, GFR has to move through the Bowman's capsule, going through different layers like fenestra, epithelium, endothelium, basement membrane. Okay. Second thing is, in this filtrate, there will be lot of things that we need. All that would have gone. So that will be, you know that glomerular filtrate around 180 liters are formed. But how much urine is given out? Only 1 to 1.5 liters are given out. So can we waste all that 180 liters? Not possible, no? So that has to be reabsorbed to the blood. Okay. Then from the blood, whatever it's not required will be secreted. That is called as tubular secretion. So two steps. This two steps is happening in the tubules and this step is happening in the glomerulus and the Bowman's capsule. This AC is testing my patience. Reduce or increase? Okay, look here. Glomerular filtrate is 180 liters, okay, GF. Out of that, only 1 to 1.5 liter urine is given out. So, this tubular reabsorption will happen. Okay, got it? Is it too bright? No. Wow, I got a proper image. Students, look here. What and all is there? Can you see here? There is endothelium. Think of your textbook. What and all is given? Endothelium is given. Basement membrane is given. Filtration slit is given. And epithelial podocytes are given. Yes or no? This is how your normal things happen. Yes or no? See, look at this diagram. I'll move. Shall I move to that side? Look at this diagram, all of you. Look at this diagram clearly and try to understand. Students, many of you didn't like the session. I know. I know for a fact many of you didn't like the session. All of you quickly like the session. I'm telling section. I don't know why. Quickly, quickly. Yes, something and all they're telling. They're telling madam is singing Chinna Chinna Ase. I understand, okay? People think I don't understand, huh? You can't make me, can't prank on me. So students, look here. Endothelial cells, glomerular basement membrane, filtration slit is there, glomerular space is there. Can you understand how it's happening? This is what is mentioned in your textbook. That is what I'm talking about, okay? So otherwise we write fenestra, that means the space, fenestra to the basement membrane. From the basement membrane, where is it going, students? I think my eyesight will go, it's that bright. Okay, basement membrane, then to your podocyte cells, then to your filtration slit. Okay, filtration slit. Now, let's look here, NCERT. Now, the first step in urine formation is filtration of blood. We all know this, okay, which is carried out by the glomerulus and it is called glomerular filtration. Okay, ultrafiltration is also sometimes you can see in NCERT, PYQ, ultrafiltration is given, same thing, glomerular filtration. Okay, on an average, 1000 to 1200 ml of blood is filtered by the kidney per minute. Number is very important, 1100 to 1200. Okay, now filtered by the kidney per minute, which constitute roughly 1/5 of the blood. Okay, roughly 1/5 of the blood pumped out by each ventricle of the heart in a minute. The glomerular capillary blood pressure causes the filtration of the blood through 3 layers. I'll teach you about the pressure, but right now understand this pressure is allowing them to move through the 3 layers. Okay, now imagine students, when you're getting into metro, when you get into BMTC, when you get into like movie theaters, people will be pushing you, know, because of that pushing, what will happen? You will just go like that, no? You'll just go inside and you'll already sit in one seat also. Your seat will be in F, you would have already sat in A. Why? Because people pushed you so much, right? So, because of that pressure, it goes through 3 layers, okay? Okay, fine. Now look here students, the endothelium of the glomerular, first layer, epithelium of the Bowman's capsule and the basement membrane. So, which is it? Endothelium, epithelium, basement membrane. These are the 3 layers. Can you remember? It's easy. Yes, fenestra, basement membrane, epithelium, think like that, or you can write endothelium, epithelium and your basement membrane. Okay. The epithelial cells of the Bowman's capsule called podocytes. Podocytes are arranged in an intricate manner. So last time I drew this, all of you remember, like one Christmas tree I drew like this, remember, like this, it will be like this. Okay, it is done in an intricate manner. I am not 3D students, I cannot draw 3D, but intricate manner, so that, what is that? So that the process can be easier. So as to leave some minute spaces called filtration slits. Okay, look at this diagram now. Can you understand what did they say? Endothelium, endothelium, basement membrane. So students, understand this way, endothelium, epithelium. Between this, who is there? Basement membrane is there. So endothelium, epithelium, basement membrane is there. In that, podocytes are there, which are kept in an intricate manner. So there are spaces. Okay, simple. See, can you see how it's kept? These are the spaces. These spaces are called filtration slit. Better than this, there is no diagram. I searched so much yesterday to find a diagram to explain you, because last time also I drew it, but I was not satisfied, so I wanted to give you a diagram. Thank you, Karthik. Okay, students, clear or not? Tell fast. Very important. Endothelium, epithelium, between basement membrane, podocytes are arranged in an intricate manner to leave some spaces called as filtration slit. You cannot find a better diagram than this. Okay, challenge you. Okay, now the filtration slit is also called as slit pores. Okay, blood is filtered so finely through this membrane that almost all the constituent of the plasma except the protein pass into the lumen of the Bowman's capsule. Therefore, it is called as ultrafiltration. Okay, this is why I told you this word is used. Okay, now first layer, glomerular filtrate, is entered from the glomerulus to the Bowman's capsule. But they spoke about one pressure. That's pressure we are going to talk about. Look here, there is a positive pressure and a negative pressure. Okay, there is positive pressure and a negative pressure. Let's see here. Positive pressure means the person who is pushing you towards moving towards your NEET goal is a positive person. Now, Vedantu NEET English team is the positive people who is pushing you, telling that go, just do it, get it done this year, don't wait for next year, don't take a drop here, right? We are the positive pressure. What is the negative pressure? People who talk, telling that, oh no, you have already taken a second drop, how can you do, how can you achieve? Your friends who tell that, no bro, I am doing a degree, I'm going to earn so much money, you're just wasting your life. Those are the negative pressures which is pushing you down. Same way, the glomerular filtrate also has positive pressure and negative pressure. What you need? You need positive pressure. And also understand, you also need sometimes negative pressure. When you get negatives only, you understand that you're worthy. I always tell, no, when you're doing something good, there will be always people talking about you. There will be always people telling negative about you. But at the same time, there will also be people who tell positive about you. You need this negative in your life, because when your relative or when your cousin come and tell, I did it, you are not able to do, or when your friend tell, I did it, you could not do, you feel that fire inside you. You will be like, no, I will show them, I will prove them that I can do it. So negative is good. Negative is good. But you should know which kind of negative is good. Okay, which kind of negative is good, you should stop them then and there. Okay, right? So, positive pressure is glomerular hydrostatic pressure, or GHP. This is different, that is because of the difference in diameter of afferent and efferent arterioles. Okay, GHP can be, in some places you will see 60, in some places you will see 55. So, I have written both 60 and 55. Okay, now negative is BCOP. Okay, now BCOP means blood colloidal osmotic pressure. I told you colloids have the ability to hold this water or not let the water molecules to go. They block this, right? So that is your negative pressure. Okay, negative pressure, which is called the blood colloidal osmotic pressure, especially because of albumin. Again, in body fluids, you will be studying this. Albumin, which will stop the water. So what is happening? Glomerular filtrate has water, many things are there in that. Now, if they stop the water, how will they move? They cannot go, right? So that is the negative pressure. Capsular, so students, that is 30 mm Hg. Capsular hydrostatic pressure is already existing in the filtrate. That means the already existing filtrate will be like, I am already here, why you be coming? Now, if another teacher come here, I will be like, I am already using the studio, why do you want a studio, right? That means already existing people will not let the new people to come in. Right, new people to come in. Now, imagine one student likes me. They'll be like, I am Gopika Ma'am's fan. I like Gopika Ma'am more. If another student comes and tell, no ma'am, I really like you, they'll get jealous. They'll be like, no, she's my favorite teacher. So that you see, that is very cute. For teachers, it's very cute to see. when students fight, telling that where is Gopika ma'am, it's such a beautiful feeling. Like there's nothing like that. It's like I have taken one lottery, like I've got one 3 crores lottery. It's like that. Okay, when you people fight in the chat box, Gopika ma'am is my favorite, Gopika ma'am. Wow, sukoon students, sukoon. Okay, so yes, already existing filtrate, that is CHP. Okay, that is 20 mm Hg. 20 mm Hg. Now, effective filtration pressure, that means we have to calculate this. Okay, I told you positive also is needed in life, negative also is needed in life, but you should know how much is needed, right? How much is needed. Okay, fine. I don't know why you people are laughing. I told a good thing. Whatever I tell, they'll keep laughing. Nonsense people. Okay, effective filtration pressure, that means positive plus negative. Okay, positive minus negative. So GHP minus BCOP plus CHP. Okay, yes. What is GHP? Let's take 60 minus BCOP 30 plus 20 maths. This is open the bracket, board mass method. Okay, 10. How much is it? 10. Should fight like that. Yeah, how you people like this? Such KDs, you know, such KDs. There can't be people like this. Now only they are fighting. I have to take a screenshot of this chat. Wait 1 second. 1 second. Don't delete any messages. Wait. 1 second, students. Which one you want to okay, students, which one you want me to explain? You people are so cute. You people are the best. My students are the best. Best students ever. I will not give my students to anyone. Okay, 10 mm Hg. Okay, fine. Students, this is how much that glomerular filtrate needs to go forward. Okay, yes? Enough, students, enough. I am already flying. I will not concentrate on the class if you people do all this. Okay. Okay, yes. Now I want to see comments also. Okay, like this comments you should tell. Chumma you'll tell in live and you will go off. Then you will forget. Karthik, which one you want me to explain again? Tell me quickly. Okay, let's focus back. Let's focus back. Come on. Students, very simple. Look here. 2 types of positive pressure, negative pressure. That means the glomerular filtrate has to move from the glomerulus to the Bowman's capsule. From Bowman's capsule, it has to go further. For that, they need a positive pressure, which is called as glomerular hydrostatic pressure. That is because of difference in afferent and efferent arteriole. That means diameter difference. Okay. GHP is around 60 mm Hg to 55 mm Hg. Okay. Now, negative pressure is BCOP, that is blood colloidal osmotic pressure. That means this colloids in the blood. You all know plasma membrane also has some extra proteins, minerals, like that colloids are there, no? That colloids will stop the water molecule. That is the negative pressure against GFR. Okay? Negative pressure against GFR. Okay? Fine? Enough. Come on. Let's continue the class. Okay? Yes, thank you so much. Very sweet of you people. Okay, thank you so much. Okay, now BCOP is blood colloidal osmotic pressure. Albumin stops the H2O. Okay, stops the H2O. Now BCOP is around 30 mm Hg. Second negative pressure is capsular hydrostatic pressure. That means already existing glomerular filtrate will be there. No, that will be like, why are you bringing more filtrate? I will not allow. That is around 20 mm Hg. So now this is how much 10 mm Hg is how much pressure is actually required for the GFR to move through the 3 layers. Is this clear? This is the actual net pressure. Actual net pressure required for the GFR to move through the 3 layers. What are the 3 layers? Endothelium, epithelium and your basement membrane. Okay, endothelium, epithelium and the basement membrane. Exactly, maths we are learning. I don't know why I have to teach maths. Okay, students, next one. Tubular secretion. A comparison of volume of filtrate formed per day is 180 liters with that of the urine released, suggests that nearly 99% of the filtrate has to be reabsorbed. Then your question will be like, then why are they actually making this much? No, can't do anything, students. Body is like that, little slow motion it is. So, see, this process is called reabsorption. That means what? 180 liters is going out. In that, only 1 to 1.5 liters is required. That will go as urine. Okay? Okay, so the tubular epithelial cells in the different segments of the nephron perform this neither by active or passive mechanism. Okay, for example, substances like glucose, amino acids, sodium in the filtrate are reabsorbed actively. Students, one question has come from this. Let's make a note quickly. PYQ. What and all? Glucose, amino acids and sodium has been actively absorbed. That means with the help of energy, they have been absorbed. Okay, and passive, whereas nitrogenous waste are absorbed by passive transport. That means your ammonia, urea, uric acid, passive transport, even water molecules. Okay, water molecules. Fine. Yes. Now, reabsorption of water also occurs passively in the initial segments of the nephron. Very catchy statement. Why? Because you should know that conditional reabsorption happen in the DCT and the collecting duct. Okay, that is different story. Okay. Now, function of tubules. First one, proximal convoluted tubule is lined by simple cuboidal epithelium, brush border epithelium. So, understand, if anything has to go like this, no, we need a brush border epithelium. Okay. Now, which increases the surface area for reabsorption. Nearly all of the essential nutrients, about 70 to 80% of the electrolytes and water are reabsorbed in the PCT. Very important question again, students. This question also was asked, I think 2022. 70 to 80% of the electrolytes and water are reabsorbed by this segment. PCT also helps to maintain the pH and the ionic balance. Again, an important question. Okay, by selective secretion of hydrogen ions, ammonia and potassium ions. So, which and all? Hydrogen ions, potassium ions. From maths class, we have reached chemistry class. We'll call Diksha ma'am to teach this. Ammonium ions. Okay, ammonium 4, no? Ammonium ions into the filtrate and by absorption of HCO3. Now, Henle's loop. So, PCT, what and all happened? Maximum reabsorption of electrolytes and water happens in the PCT. It also helps in the maintaining of the pH and the ionic balance. Okay? Okay, fine. What is happening? Okay, fine. Look here, Henle's loop, reabsorption is minimum in its ascending loop. Very important, reabsorption is minimum. Where? In the ascending limb of loop of Henle. Okay. However, this region plays a significant role in maintenance of a high osmolarity of a medullary interstitial fluid. Remember, when I told you countercurrent mechanism, or when I am going to teach you countercurrent mechanism, you will understand that the intermedullary fluid, okay, the fluid which is present, intermedullary fluid, that job, that loop of Henle and vasa recta is doing. So, that is what they are talking about. Clear? Okay, clear? So, osmolarity of the intermedullary interstitial fluid, the descending loop of Henle, again very important question. Descending loop of Henle is permeable to water but almost impermeable to electrolytes. So, descending loop of Henle, permeable to water, okay, but almost impermeable to electrolyte. Okay. This concentrates the filtrate as it moves down the ascending limb. Now, ulta. The ascending limb is impermeable to water but allows transport of electrolytes. So, ulta it's playing descending loop permeable to water, ascending loop permeable to electrolyte. Okay, DWAE. Now, therefore, as the concentrated filtrates pass upward, it gets diluted due to the passage of electrolytes to the medullary fluid. Now, last one, distal convoluted tubule. Okay, ammonium. I have written ammonium, students, not ammonia. Ammonia is NH3, ammonium is NH4. Much I know. Distal convoluted tubule, conditional reabsorption of sodium and water. So, DCT is the one who will work only in active mode. That means whenever aldosterone is released or whenever there is some problem, only during that time conditional reabsorption will be done by DCT and collecting duct. Okay, so they will absorb sodium and water actively and place in the segment. DCT is also capable of reabsorption HCO3 and selective secretion of hydrogen and potassium. Important, selective secretion of hydrogen and potassium. Students, please take this. Okay, please take this. Students, I'll get some water. Please take this, write it down right now only. PCT what it is doing, DCT what it is doing, loop of Henle what it is doing. Now all of you take 2 minutes. Okay, exactly. Don't underestimate the power of a common woman. Okay, yes, I'll just get some water. Please make a note of what is selective actively absorbed very fast. Yes. Ready? Ready. Yeah, wow. What is chocolate rain class and all? What are you people telling? There's no class like that. Okay, did you do this? All of you did? All of you did? Did? Okay. Thank you. Awesome. Super love. Okay, students, look here. Some reabsorptions are happening. Look here, PCT, maximum electrolytes will be reabsorbed. So, everything, HCO3, NaCl, water, nutrients, potassium, ammonia, hydrogen. Almost all the electrolytes will be reabsorbed here. Okay. Thank you. Okay, and then look here, students. Descending loop of Henle does not reabsorb much. Only thing that they reabsorb in the first one. Look here, AE I told you. So remember like this, AE. That means ascending loop of Henle is more permeable to electrolyte and descending loop of Henle is more permeable to water. Okay, so here you can see descending loop of Henle is absorbing water. Can you see descending loop of Henle is what absorbing water. And as it comes, ascending loop is absorbing what? Electrolyte. So, NaCl will be absorbed by the electrolyte. But always remember, these people are helping us for medullary interstitial fluid osmolarity. Okay. For concentrating the urine. And as we go up, you can see again your DCT also will do conditional reabsorption of NaCl, water, HCO3, potassium and H+. Selective reabsorption will happen. Okay, selective reabsorption will happen. Haha, ma'am, you're cute like Gopika ma'am. Then who am I? You're giving me identity crisis. Okay. Okay, got it? Chalo. Okay, now students, counter current mechanism. I was supposed to draw this, but I forgot. Ready? We'll do it faster. After that, surprise is coming, surprise. Oh, what happened? 1 second, students. What happened? Ready? Okay. Chalo, let's start. Counter current mechanism. Okay, 2 tubes I'll draw. One pink one is vasa recta. Okay, pink one is vasa recta. Then we have loop of Henle. Basically, like students, 2 buckets, one above the other, like that. If you draw, counter current mechanism done. See, 2 tubes I've drawn. Now, counter current mechanism, what? That means 2 tubules which are in close proximity. Okay, 2 tubules which are in close proximity are sending 2 things ulta. Like ulta pulta means, see, now I am there, Diksha ma'am is there. I am going this way, Diksha ma'am is going this way. Okay, I am going this way, Diksha ma'am is going backwards. That means what? We both are in close proximity, but we are passing fluids in a opposite direction. That's all is counter current mechanism. Okay, and it is happening between whom? It is happening between loop of Henle and vasa recta. Okay, counter current mechanism happens with loop of Henle and vasa recta. Okay, now let's try to understand. Okay, ready? Yes. Look here, students. Now blood. Okay, let's start with filtrate. I think filtrate will be easy for you. Now filtrate is moving downwards. Okay, filtrate is moving downwards. And it's going like this, going like this. Okay, I forgot to label. Let me label. Students, this is ascending loop of Henle. This is descending loop of Henle. Okay. This is ascending vasa recta. This is descending vasa recta. Am I right? Am I right? All of you check. Correct? No? Vasa recta? Okay. No, 1 second. This is descending loop. No? This will be ascending. L-O-H A-O-A-L-O-H. Okay? Fine. Okay, look here, students. Now filtrate is going. Now blood will go. So blood will go like this. From here, descending vasa recta, it will go like this, opposite direction. First, I'll draw the arrow marks, then I'll explain. 1 second, give me time. Okay, now, simple thing. First counter current mechanism is between descending loop of Henle and ascending vasa recta. How it's happening, you see? Blood is going upward, filtrate is going downwards. That means 2 tubes which are in close proximity are sending 2 different liquids in opposite direction. Got it? Okay, yes or no? So 2 things, 2 tubes which are in close proximity, one filtrate is going downwards, this is going upwards. This is basically counter current mechanism. So first counter current mechanism happens between these 2, next counter current mechanism happens between these 2, then counter current mechanism happens with descending loop, ascending vasa recta, descending vasa recta. So I am writing it here. First thing, first counter current mechanism happens between DLOH, that is descending loop of Henle and ascending vasa recta. Second counter current mechanism happens between ascending loop of Henle and descending vasa recta. Third counter current mechanism happens between DLOH, ALOH, okay, and AVR and DVR. Simple? Easy? Tell me in the charts, is it understandable? Now, DLOH, descending loop of Henle. Students, easy or not? descending loop of Henle. Okay, ALOH ascending. AVR ascending vasa recta. Okay. Yes. Yes, got it? This much countercurrent mechanism. Okay. Now students, now we have to understand how this loop of Henle is actually helping in medullary interstitial fluid. So where is medullary interstitial fluid? This is medullary interstitial fluid. So what will happen, you know? I'll tell you, very simple thing. First thing, we have to increase the concentration of medullary interstitial fluid. How is that going to happen? NaCl from the loop of Henle, okay, from the ascending loop of Henle will be put here, NaCl. That will be absorbed by your vasa recta and it will bring it all the way till here and drop it into the interstitial medullary fluid. Okay, NaCl. So, simple thing students, NaCl and urea has to be brought into the medullary interstitial fluid and increase the concentration of the medullary interstitial fluid so that water molecules can be more reabsorbed and the urine can be concentrated. Say, simple thing, okay? Now, this NaCl which came out of this loop of Henle was taken up by the vasa recta and it was dropped into the medullary interstitial fluid. Now we need urea. For that we are going to take the help of collecting duct. We are going to take the help of collecting duct. Collecting duct is going to give us the urea and that urea will be brought into the medullary interstitial fluid and here what happened? Concentration of NaCl and urea has happened. Okay. So, concentration of NaCl and urea has happened because of which water will be given out from the tubules. Water will be reabsorbed. Got it? Water will be given out. Is this clear? Because water is completely absorbed. What will happen? The urine will be concentrated. Urine will be concentrated. Clear or not, students? Any doubts? Please ask me now. All of you just check this. Check this. Any doubts? Ask me right now. Yes? Doubts? Any doubts? They're all talking to themselves. I don't know what they're talking. Students, tell me, any doubts? Did you all like the session? I cannot see any likes. All of you who joined now, like quickly. Let me see how many liked. Now I'm checking, okay? If likes are not there, you see people. Make it 400, make it 400, fast. You people can do it. All of you make it 400, 400 is the target. If I don't give you challenge, no, you people don't like it. Okay, yes. Now students, this much clear? Good to go? So, medullary interstitial fluid, we increase the NaCl and the urea content and we reabsorb the water and made the urine more concentrated. Now, a person who eats non-veg have to drink more water because the meat, that means meat has a lot of protein. Right, because of that what will happen, this medullary interstitial fluid will be very concentrated and they will absorb all the water and the urine will get very concentrated. Because of it, that person will have abdominal pain. So when you are eating non-veg, after eating non-veg, please make sure that you drink ample amount of water. Okay, next one. Students, next thing that are... Okay, next thing is what? RAS mechanism, hormonal regulation. First is RAS mechanism. I told you that when there is a khichdi or when there is a problem with the filtrate, who is going to be released? Renin is going to be released. But renin cannot directly help in fixing this GFR. Okay, so what is renin going to do? See, look here, renin got released. That renin will get converted, or in other words, renin is going to help angiotensinogen, which was inactive in the plasma of the blood, to get activated. Okay, angiotensinogen which was in the plasma was inactive. This renin will help it to get active. I'll tell you how. This angiotensinogen will get converted to angiotensin 1. See, I am a teacher. I can motivate 10 students in this class. Another teacher will motivate 10 more students in the class. Another teacher, like that 40 students we have motivated. Maybe I cannot motivate all the 90 students in this class. It's not possible. I cannot expect all the 90 students to appreciate me or like me or comment. Not possible, right? Because everyone has their own choices and selections. Same way, this renin also did not have the complete capacity to convert angiotensinogen to angiotensin or to make it into the complete active form. Okay, so see, look here, renin took angiotensinogen and got it converted to angiotensin 1, but still it was not capable of fixing the GFR. So what will happen? The lungs will come in help and it will release angiotensin converting enzyme, or ACE. ACE your NEET exam, right? Angiotensin converting enzyme, and angiotensin 1 will get converted to angiotensin 2. This angiotensin 2 has the ability to fix all the issues. What were the problems? BP was low, GFR was low, blood volume was low, water volume was low. All these problems were there. Got it? So, look here, angiotensin 2 first will start with one problem. Okay, it will do conditional reabsorption of sodium. Why? To fix the BP. Conditional reabsorption of sodium. Okay, then after that it has to increase the water or the blood volume. For that, it will stimulate adrenal cortex to release aldosterone. This aldosterone will do what? Aldosterone will help in the increasing the reabsorption of water. That is also done. Problem sorted. Aldosterone will fix the conditional reabsorption of sodium and water. 2 problems sorted. Now, after that, angiotensin 2 will do vasoconstriction, because of which more GFR can come in. Vasoconstriction of the efferent arterioles, so the GFR does not go out faster. Right? Blood flow, all of you remember? Afferent arterioles, your peritubular, no, afferent arterioles, glomerulus, then your efferent arterioles. So they will vasoconstrict the efferent arterioles, so more blood can come and less blood can go. Okay, that problem also sorted. After that, angiotensin 2 will do reabsorption of water, that I already told you here. This is your RAS mechanism. Any doubt? Full form of RAS mechanism is renin angiotensin aldosterone system. That means whenever there is a problem with the GFR, this entire constitution people will help, right? So renin will activate angiotensinogen to angiotensin 1. ACE released by the lungs will activate angiotensin 1 to angiotensin 2. Angiotensin will stimulate adrenal cortex to release aldosterone, which will do conditional reabsorption of water and sodium and fix this. Got it? Got it, all of you? Any doubts? Any doubts? Shouldn't have doubts. Yes, no doubts, I believe. Next, second mechanism. Okay, second hormonal regulation is ADH, or antidiuretic hormone. You would have studied with me in chemical coordination. Antidiuretic hormone, which is in the hypothalamus, will be released to the posterior pituitary. All of you remember, your pituitary gland has 3 lobes: anterior, intermediate and posterior, or your pars distalis, pars intermedia, pars nervosa. In that, this will be released to the posterior pituitary, where the neurosecretory cells have to directly come and secrete it. Okay, directly come and secrete it. Now, this posterior pituitary, what it's doing, students? Actually, antidiuretic means there is no water. Urine is too concentrated. The problem is, see, blood osmolarity is below 300. That means we have to increase the osmolarity, so reabsorption of water happens. Okay, first thing is thirst center. It will activate the thirst center to drink some water. Okay, it will tell thirst center exogenously drink some water. Okay, second thing, it will tell DCT and collecting duct to do reabsorption. That's all. Very simple. Antidiuretic is simpler than RAS. Okay, and make the urine more concentrated. That's all. Next one, ANF, which is released by the heart, atrial natriuretic factor. This one is opposite to RAS and ADH mechanism, especially to RAS mechanism. It will basically do diuresis and natriuresis. You will be like, what? Why? Simple thing. Why, students? Because problems are like that. High BP is there, high water level is there, high blood volume is there, high GFR is there, high sodium is there. That means everything is more. When everything is more, they have to do ulta kelsa only, no? Ulta job they have to do, no? So, diuresis they will do, natriuresis they will do. That means loss of H2O, removal of Na+. Simple. So these problems will be sorted. ANF is the least one. Okay, nothing is there to study. Good. Can we continue? Okay. Now, micturition, that means voiding of urine or expulsion of urine. Okay, urine will be in the collecting duct. That will be the pathway we are talking about. From the collecting duct, it will go to the duct of Bellini. From duct of Bellini to minor calyx. All of you remember this. This is your pyramid, medullary pyramid. This is how your thing will be, collecting duct. From collecting duct, it will go to the duct of Bellini. From there, minor calyx, major calyx, renal pelvis, ureter, urinary bladder, urethra, expelled out. You can think of the system, no? All of you can think of it, yes or no? Yes or no in the chats? Think of it. So look here, collecting duct, duct of Bellini, minor calyx, major calyx, renal pelvis to ureter. So this is the renal pelvis, right? This portion was the renal pelvis. Renal pelvis open into the ureter. From ureter to urinary bladder, urethra, expelled out. Okay. Now, urochrome is the pigment present in the urine that gives the yellow color to the urine. pH is around 6 point. It's not neutral but slightly acidic, and urea content is around 25 to 30 grams. Okay, urea is around 25 to 30 grams. Chalo. Accessory organs, I will just tell you the main things. So look here. Liver. First we will start with lungs. Lungs will remove large amounts of carbon. Two people are writing. Large amounts of carbon dioxide, approximately 200 ml per minute. So we are talking about other organs which are able to do excretion. Kidney we understood, kidney we learned, all the mechanism we learned. But what is other people doing? Lungs is doing, liver is doing, sweat is doing, sebum is doing. Something is happening. That is what you are going to learn. Lungs will remove a large amount of carbon dioxide, approximately 200 ml per minute. Okay, and a significant quantity of water every single day. Okay, and liver, the largest organ of the body, secretes bile containing substance. Students, should I do it with different colors so it will be easy for you? Okay, look here, quantities of water. Then I'll do this one with this color, liver. See, liver will give out bile containing substance like bilirubin, biliverdin, cholesterol, degrade the steroid hormones, okay, and vitamins and drugs. Almost so many things it is. Bilirubin, biliverdin, drugs, steroids, all this will be removed by your liver. Okay, it is basically breaking down, students, when you take tablets, all that who is doing? Liver is doing, no? Now, most of these substances ultimately pass out along with the digestive waste. That means with our fecal matter. Okay, yeah. Then the sweat and the sebaceous gland. Look here, sweat and the sebaceous glands in the skin can eliminate certain substances through their secretions. Okay, sweat produced by the sweat glands is a watery fluid, all of you know, contains NaCl, small amounts of urea, lactic acid, etc. So sweat is giving out what and all? Urea, lactic acid, NaCl. Though the primary function of sweat is to facilitate a cooling effect of the body surface, it's also helping in some amount of excretion. Now, sebaceous gland eliminates certain substances like sterols, hydrocarbons, waxes through sebum. Okay, I'm underlining with different colors so it will be easy. Okay, then this secretion provides a protective, that's all. Students understood? Fine. Then last topic is disorders. Students, see, 2 hours we finished excretion also. You are all crying excretion. Is it easy now? Okay, before that, answer to me. Do you find the excretion easy or difficult now? I'll sit by then. All of you answer quickly. My leg is aching. Is excretion and locomotion easy? Are you finding anything problematic? Students, you have to go back and read, okay? You have to go back and read. Don't be like, yes, I attended the class, everything is in my head. It won't. You have to revise. Even before this class, I revised. Before that also, I read. We have to revise, students. Our brain is like that. No one is an expert. Everyone makes mistakes. Everyone has to revise. Every single teacher on whichever platform it may be, whichever class it may be, they all study before teaching. Because it's not easy to remember. So many things will go wrong. So you should also revise like that, okay? Because see, PYQs also we get confused sometimes because we don't read the question or our mind will be sometime absent. So sometimes we will not be able to answer properly. So you should be in a position to read, okay? Yes. Now look here, kidney, students, whenever there is an accumulation of urea, it is called as uremia, okay? Which is very, very harmful. Then a person who has whose both the kidneys have failed, they have only one option called as hemodialysis. What is the one option? Hemodialysis. That means with the help of a dialyzer or a dialyzing machine, we will remove out the urea manually, or by technology we will remove out the urea from the blood, okay? What is that? Blood is drained from the convenient artery and it is pumped into the dialyzing unit. So we are taking blood from a person and we are putting it into a dialyzing machine. In that there will be something called as a dialyzing fluid. What is it? Dialyzing fluid. This dialyzing fluid will not have even 1% of urea, okay? No urea at all. No urea is why? Because urea will move from a region of higher concentration to a region of lower concentration. This person's blood has lot of urea. That urea will be moving from a region of higher concentration to the lower concentration to the dialyzing fluid, and like that the blood will get purified. So when we take this blood, we will add anti-heparin so that the blood coagulation does not happen. Then when we are giving this blood back into the person's body, we will add anti-heparin, okay? It is given here. See, look here, blood is drained from the convenient artery and it is pumped into the dialyzing unit after adding an anticoagulant like heparin. Because blood will clog, no? So that we are doing. The unit contains a coiled cellophane tape. So students here, like this they are talking, see? Like this one cellophane tape will be there, okay? And here dialyzing fluids will be there, and urea will move from a region of higher concentration to lower concentration. It's surrounded by a fluid, dialyzing fluid, having the same composition as that of the plasma except the nitrogenous waste. That means except the urea, okay? Fine. The porous cellophane membrane of the tube allows the passage of molecules based on the concentration gradient. As the nitrogenous waste are absent in the dialyzing fluid, this substance will move out. Same thing what I told you. Is this clear? And when we are pumping back this blood, we will give anti-heparin to the person, okay? Because we don't want any more change, whatever coagulation has happened, over. Now, kidney transplantation is the ultimate method in correction of a renal failure. That means both the kidneys have failed, students. Dialysis is not a ultimate solution because dialysis is very expensive, okay? It is a very financially draining process. The family will have to suffer to do dialysis every month or within 3 months once or whatever, depending on how bad the condition is. So it's not possible. So the only option is kidney transplant. Now, kidney transplant also is not very inexpensive. It's very expensive. A person has to be ready to give the kidney. Graft rejection does not have, it should not happen. Compatibility we have to see. All this is there. But it is a lifelong solution. Like if you're investing some money, it's a lifelong solution. Got it? Now, how most of you have invested 1,000 rupees for the crash course. It's an investment for your future. Same way, even though that time you might be under a lot of financial strain, like ma'am, I cannot invest 1,000 rupees, but even if you paid, it's an investment for the future, right? So I hope all of you bought the crash course 999. That's all, okay? Join quickly and do your revision properly. There are also chapters they're doing like this itself, okay? Now, a functioning kidney is used in transplantation from a donor, preferably a close relative, to minimize the chances of rejection. In case rejection is going to happen, we will give an immunosuppressant, that is your cyclosporin A, okay? Suppressant, that is your cyclosporin A, will be given so graft rejection does not happen. Got it? Now, renal calculi, that is basically students stone. That could be because of accumulation or something, or you are continuously consuming something, and in that you're getting some granules and it's all getting accumulated. Kidney stone. That person will always, sometimes they will have bleeding while urinating, they will have blood while urinating, and they will require a lot of water. They have to continuously drink water and remove this. So some people, see, if the kidney stone is very small, because of continuous water absorption, it would have gone out. But for some people it would have become very big, then that person will also see urine stains in the what am I telling? Blood stains in the urine. Okay, stone or insoluble mass of crystallized salt oxalate formed within the kidney. Glomerulonephritis is inflammation of glomeruli of the kidney. Done? That is inflammation of glomerulus. Ready, students? Questions? Let's do questions. First question, which of the following statement is incorrect? Ureter, blood vessels and nerves enter the kidney through the hilum. Ayyo, I didn't tell you hilum, students. Ayyo. 1 second, students. I forgot to tell hilum, so sorry. Oh, stop. Where did I reach? 1 second. This got hanging. It's hanging, students. Work. Okay. Best idea. No. Students, here. Forgot hilum. Here, students, hilum. Through the hilum, what will happen? Renal artery, renal vein, renal artery, some nerves, all of this will be extended. Okay. Okay. Yes. Students, we are not done. We have one more chapter. Yeah. So here, hilum. Now read this. I will sit, you will read. Fast read and tell me the answer. I think some of you told the answer already. Ayyappan and all told the answer. Ayyappan, who is that? Prasad. Which is the answer? Very easy question. Very, very easy. Easy peasy. Yes, very good. B is the answer. See, kidney is situated between the levels of the last thoracic. Yes, this is correct. But fourth lumbar, no, third lumbar. Okay, all the points are correct. Fine. Look here. The path taken, easy question. The path taken by the glomerular filtrate during its conversion to the urine comprises of, which is the answer? Like, glomerular filtrate will go through which pathway? It will go through which pathway? Tell fast. C. Glomerulus, Bowman's capsule, PCT, DCT. DCT here. Hello. How will DCT come first, students? Did we become 400 likes? No. What is this? 1 hour time I've given you. Still now we haven't reached 400 likes. Shame on you people. Make it 400 likes faster. Who is that 3 students who have not liked the session? One challenge I give you people. That also people won't do. See, so many 3-4 people were there. See, I caught them. This is why I have to check in the middle. Yes, what's the answer? B. Glomerulus, Bowman's capsule, PCT, Henle's loop, DCT collecting duct. Perfect. Next question. Match column 1 with column 2. What are their jobs? Okay, what are their jobs? See, many were bunking. I know. See, now how it became 409? How? Because you bunk. Very hurt I am. Heart is breaking. That this is how you people are behaving. Students, answer this quickly. Am I covering? Sorry. Students, I don't know where to go. Can you see? Yes. Visible? Done? Which is answer? Why can't I see answers? Come on. Which one? See, let's see which is done. PCT does reabsorption of maximum electrolyte. Okay. Then DCT does conditional reabsorption. We have collecting duct also. Okay. Loop of Henle. This one. DCT reabsorption. No. Minimum. Wait, students. 1 second. This one. Conditional. This collecting duct. This one. So which is the answer? AQ, okay, correct. B, S, correct. C, R, correct. This one. Chalo, next question. Which one of the following is correct regarding excretion? Read the question, all of you. Which one of the following? After this, I'll give you a dinner break. Okay, after this, I'll give you a dinner break. Even I'll go eat something lightly and we will start body fluids, because that's a long chapter. Now, I'll try to make it kuti, but then still, sometimes, you know. Thank you, Aditya. Students, tell this answer. Are you all reading the question? 3, 2. Students, what went wrong? Correct statement. See, look here. Which is correct regarding the excretion? See, large amount of water from the renal filtrate is reabsorbed in DCT and less amount is reabsorbed in PCT. Wrong. Ulta. Malpighian corpuscles is found in the medulla region of the kidney. Hello. Malpighian tubules means what? Your Bowman's capsule and glomerulus. Where is it found? In the cortex. Remember? Cortex. This is cortex, no? This is also wrong. Then the color of the urine is pale yellow and slightly alkaline. No, it's slightly acidic in nature. So which is the correct statement? Only this is the correct statement. Okay. 2 is the correct statement. That means the descending loop of Henle is almost impermeable to salts, because DW, it is more permeable to water. What went wrong, students? It's 2. Next question. Given below are 2 statements. One is labeled A and the other is labeled R. Ascending limb of loop of Henle is permeable to water and allows transport of electrolytes actively or passively. Dilution of filtrate takes place due to efflux of electrolytes in the medullary fluid. Okay, you have to tell me which is the correct option. Faster, faster. And all those who join new, quickly subscribe to the channel. What are you waiting for? Students, all the updates, all the classes, all academic shots, everything you will get. One-stop solution. Try to answer this. 4. Okay. A and okay, very good. Very good, very good. 4 is the answer. 4 is the answer because see, ascending loop of Henle is impermeable to water and allows transport, correct. Dilution of filtrate takes place due to the efflux of electrolytes in the medullary fluid, correct. Students, did I get stuck? Oh God, what happened? Huh. Students, am I stuck? I'm not on the screen. 1 second. 1 second, students. 1 second. I'm fixing it. What happened?
He has to go to session, he has to put auto stop off. He has to do it.
No, not auto stop. I think it's just that wire got something happened. I stamped on this wire.
Which wire?
See?
Is OBS working?
OBS is the problem. Camera is working.
Okay.
Something happened to the OBS. I don't know if I can move the video capture.
Because if they switch off the auto stop, right, we can close OBS and restart again.
Right?
Yeah.
They call Ashwin.
Yes, we are audible, right? We are audible, right, students?
Audible.
We're audible.
Not visible.
Let me try fixing it, students. Let me try fixing it. No. We'll get the prompt cleared. I think there's a problem with the software here. There's a problem with the software. Let's get the software fixed. Right? Ongale madi, it seems. No, we have to just restart the software. But if I restart the software, the stream will get stopped. So many technicalities. Yes, I know. I know. Yes, I was in another live. I came from that live to this live here. Yes. Yes, if I switch off the screen and switch it back on, the software will stop. If the software stops running, right, the stream will end. So for that, we need to do something. 1 second, students. Let us do something. We'll get it sorted. Let's get it started.
Students, am I audible now? Audible? No. This I did.
Did?
Camera.
The camera did this. Did you change?
Huh. That only. Huh. Yeah, it was.
Can you hear, ma'am?
I don't know. What is wrong?
Can you hear? Can you hear? Check, 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 check. Yes, you can hear, ma'am. You can hear.
No. I don't know. Sir, Mithun is talking. Huh, I'm audible now.
Yes, you're audible.
Oh my gosh. How did you check?
Someone told in live there, you could help Gopika ma'am.
Oh, is it? Oh my god. Now it's clear. Okay. Thank you, students. I made everyone, something and all happened. Sorry. Nazar went off from the class. Okay. Wait, let me hear for myself. Oh, is it? Oh my god. Who is the student who went to Sir's class and put message, yaar? Not bad, you people are. Okay. Chalo. Okay, students, we did the question. No, where is the pen? Okay. Next topic is, okay, blood. Before blood, let's take a, actually it was supposed to be a break. I could have just given a break, but then what happened? Miserable things happened. So yes, students, we'll take a break. After that, we'll start body fluids and circulation. We'll take a dinner break. Okay, we'll take a dinner break. So we will resume back at, what is the time now? 8:12. Okay, let's resume back at 8:40. Works? 8:40 works? Yes or no? 8:40? Okay, or maybe 8:50. Okay, fine. Dinner break. Okay, this is your dinner break. After this, no more break. Okay, dinner break. Chalo. Okay, students, 1 hour. Students, 1 hour and all break is not possible. Please, you people can sit and eat there. I cannot stand and eat. No, so 1 hour break is a lot. So this much is enough. Half an hour, 35 minutes break is more than enough. Okay. Yes, even I'll go have something very lightly and come. Dinner I'll go home and have. So yes, so that little energy is there because body fluids, heart will break teaching the chapter. Okay, bye students. Come back sharp at 8:50. Okay.
Yes.
Hello students, I am so sorry. The break became very long because there was an NTA update which was very important for all of you because there's so much rumors about it, and I think it is very necessary, very necessary for us to address that finally NTA had to address it. Just imagine how fast the rumors have spread that NTA had to address it. So all of you quickly join. Yes, let's do body fluids and circulation, students. We will only do the major part of it. We will not waste a lot of time in basics. Okay, we will just try to understand what are the main concepts of this chapter. Okay, because I'm sure all of you are tired, even I am very exhausted. So let's just do it faster. Okay, yes. So in this chapter, we are basically studying about the special connective tissue or the fluid connective tissue, that is the blood and the lymph. Okay, that is this chapter about. I'm not going into the general thing. Student, it was not a prank. Okay, it is the truth. Okay, because so much noise about it was there that NTA will postpone the exam because of Lok Sabha election, and students who have elected will not be allowed inside the exam. So I feel a lot of students have got affected with this. So it's our important need to tell the truth. Chalo, see, blood has basically the plasma which contributes around 55% of the blood. Okay, which contributes around 55% of the blood. In that also 90 to 92% is water. Okay, 90 to 92% is water. Okay, I'm audible, right? Okay, audible? Yes, all of you who joined the session right now, quickly smash the like button and subscribe to the channel if you're new to the channel. Do not hesitate because we are giving you genuine content. You might feel it, I don't know, but it is genuine for at least some students. If 10 students are influenced by it, we have to change that influence, right? Okay, now plasma without clotting protein is called as serum. That means when fibrinogen is not present in plasma, it is called as serum. Okay, now students, I told you plasma has 55%. That means in the blood, plasma is 55%. In that, 90 to 92% is water. The rest is formed elements, minerals and proteins. Proteins also, you have albumin, fibrinogen, globulin. That is what we are going to learn. Okay, all of you quickly smash the like button quickly. Now, blood corpuscles are the rest of the 45%. What is blood corpuscles? Simple thing. RBC, WBC, platelets, erythrocyte, leukocyte, thrombocyte. Okay, this is what is your thing. Now look here. Plasma proteins. I told you proteins are there in the plasma. Very simple. Albumins, globulins, fibrinogen. Okay, these are the three proteins which are present in the plasma and each of them have a job. Let's see what is the job. First one, albumin. Now we just studied about it. What did we study? BCOP. Remember? What did we study? BCOP, blood colloidal pressure. Right? Blood colloidal osmotic pressure. Caused by whom? Albumin. That means it will stop the water. Right? So look here. Most abundant plasma protein maintains osmotic balance of the blood. Okay? Maintains osmotic balance of the blood. Now, next is globulin. Okay, I'll show you that. Yes, look here students. Yes, so I told you this is your plasma content. 1 second, I'll show you this PPT also. one minute. So look here what I've made here. See, this is your entire circle of plasma. What is that? In that we have 6 to 8% of protein, 1% dissolved components and 90 to 92% water. In that, which are the proteins? Albumin, globulins and fibrinogen. Now look at the functions what they have. Very simple. Albumins, it is BCOP, like I told you, basically to maintain the osmotic pressure. Okay. Now fibrinogen, blood clotting factor. All of you in the chats tell me plasma without fibrinogen is called what? All of you tell me plasma without fibrinogen is called what? Akshaya, please check the video that we made before. That is Shreyas sir and myself we have done. Check that video, you will get all the ideas about how to enroll for the offline test series and online test series. Only go to a link, type your phone number, you will get an OTP and you would have enrolled. Okay. Chalo, look here, very good Subhashini, serum, right? Plasma without fibrinogen is called serum. Now, globulin, we have alpha, beta and gamma globulin. Alpha, beta and gamma globulin, all of them does simple thing like defense mechanism. Okay, defense mechanism. That means your IgA, like immunoglobulin, right? That is done by your globulin. Okay. Now, look here. Blood corpuscle, first thing is RBC. The most abundant blood cell, right? So your red blood cell is the most abundant and it is around 5 to 5.5 million per mmHg of blood. Okay, how much is the content? 5 to 5.5. Okay, now formed in the bone marrow called as erythropoiesis. What is the process called as? Erythropoiesis. Okay. Okay, process is called erythropoiesis, and the protein which is doing it, it is called as erythropoietin. Okay, protein that is released by the JG cells. You would have studied this where when you studied chemical coordination, they tell you JG cells release erythropoietin, which actually helps in erythropoiesis. Okay. Yes. Now look here. They are devoid of nucleus and it is called as enucleate. Who is devoid of nucleus? RBC is devoid of nucleus, and it can be biconcave or circular in shape. Circular in shape in cases of camels and other, some few of them. Okay, camel is one thing you can remember. Okay, volume is fine, no? Just increase the volume and see in yours. Okay, now look here. Deficiency of RBC is called as erythrocytopenia. Okay, whenever there is a deficiency in RBC, now when you go to doctor, they check like this, no? That means if it is white color, that means they tell RBC is less. That is erythrocytopenia, and increase is called polycythemia. Okay, decrease. It's not loud. One second, let me check. Others tell me, is it loud or not? Color, that means they tell RBC. Students, it's loud. Please increase the volume. I think it's something to do with yours. The volume is okay for me. Okay, look here. So hemoglobin is a respiratory pigment. Okay, hemoglobin is a respiratory pigment, and 12 to 16 grams is present in a healthy person. So 12 to 16 grams of hemoglobin will be present in a, yes, sound is okay. Yeah. Students, I cannot shout. I'm almost breathless. Okay. I've been standing here for past 7 to 8 hours. I'm breathless. So please do understand, increase the volume or please wear earphones. Okay. I cannot shout. Yes. So 12 to 16 grams is present in a healthy person, and RBC lifespan is around 120 days. And what is the graveyard of RBC? All of you tell me in the chat box. Graveyard of RBC. It is given here, but I will not tell you. Tell all of you. Graveyard of RBC. Now see, this is your RBC. It has hemoglobin, which is a respiratory pigment. Okay. What is respiratory pigment, students? We studied this in breathing and exchange. That means they help in exchange of gases. Okay, they help in exchange of gases. Now WBC, leukocyte. Okay, WBC, pancreas. Yay, spleen. Spleen is the graveyard. Okay, WBC is called as leukocytes, which is around 6,000 to 8,000 per mm of blood. Okay, it is colorless, absence of hemoglobin is there, and they are nucleated. There it was not nucleated, enucleated. Okay, WBC deficiency is called leukopenia. So whenever deficiency is coming, penia word is coming. Okay, and increase is called leukocytosis. Now look here, WBC are of two types: agranulocyte and granulocyte. That means presence of granules and absence of granules. Okay, presence of granules and absence of granules. Granulocyte, that means where they have granules. Agranulocyte means they do not have granules. Now look here, granulocyte, I have drawn the diagram. Can you see dots here? Those are granulocytes. Example is neutrophils, basophils, eosinophils. That means the ones that come under granulocytes are neutrophils, basophils, eosinophils, or you can remember Ben. How will you remember? Ben. Benton, you remember in school days and all, we had Benton, Benton watch, Benton scale and all. Same thing. Benton, Ben, you remember. Basophil, eosinophils, neutrophil. Okay. Then agranulocyte is monocyte and lymphocyte. Okay. Monocyte and lymphocyte. Chalo. Look here. Neutrophils. What is neutrophils? First thing, they are multi-lobed. Look at them. It looks like a headphone. No, this looks like a headphone. This also looks like a headphone, but people usually tell it is not headphones type. It has a broader structure and then two loops to the end. Okay. Now also is there a Benton? I didn't know. Now also it's there. Ajijo. Oh, I don't know, students. I don't watch cartoon channels. Okay, so neutrophils is multi-lobe, 6 to 65%. That means neutrophils is highest in number. Okay, it can be stained with both acid and base. That is the reason why the name came neutrophils. That means neutral. Okay, phagocytotic. That means as soon as something comes, the first person to fight is who? Neutrophils. Okay, now basophils, they are S-shaped lobe. It is only very less is present, 0.5 to 1% is present. Basic dyes, see basophils, that means it can be stained with basic dyes. Okay, causes inflammation and secretes heparin, histamine, serotonin. Okay, what does it secrete? Heparin, again anticoagulant, histamine, which is in the mast cells for your allergy, and we have serotonin. Got it? Okay. Old episodes. Okay. Fine. Now look here. Esophils or acidophils. From the name only we understand it will be stained by acid dyes. Okay. So headphone shaped lobe, acid stain, 2 to 3%. This is the one who will be helping in allergies. Okay. To suppress the allergies. I had dust allergy. Now my eosinophils is working. Okay. Now look here, students. You can see all the things that are present in our blood. Okay, all the things that are present in our blood. Monocyte and lymphocyte we have to study. In lymphocyte, two types are there, T cell and B cell, right? In lymphocyte, so I told you monocyte and we have lymphocyte. In lymphocyte we have two of them, B cell and T cell. Chalo, platelets. Let's try to understand platelets. Is very easy. So many of you ran away from class. Okay. Okay, chalo, no problem. Platelets. Students, platelets is also called as thrombocyte. Okay, thrombocyte. And this is not actually a true cell. Not a true cell. Why am I telling it's not a true cell? Because it is not made up of, actual cell. It is actually made of a megakaryo. Okay, megakaryotype. That means it's not megakaryocyte. Okay, one second, students. Megakaryocyte. This is a large cell. So this cell's fragments. Okay, this cell's fragments are the formation of platelets. So platelets are not true cells because they are formed by fragmentation of a megakaryocyte. Is this clear? Yes, bunking is injurious to health. Very, very injurious to exam. Yes. Very good. Megakaryocyte. Okay. Are you telling Nayantara? Dora movie. Nayantara. Who told? Syed Gamer. Okay, this megakaryocytes are what, students? They are special cells which are present in the bone marrow. Okay, special cells which are present in the bone marrow. Chalo, next one. Okay, now look, coagulation of platelets. That means we understood about platelets. Platelets are not true cells. They are fragments of megakaryocytes. Megakaryocytes are special cells which are present in the bone marrow. Now we are going to understand what? We are going to understand coagulation of platelets. Ready? Very simple. Coagulation of platelets. Can we do? Yes, all of you tell me in the charts. What is this? So, first thing, an injury will happen. Thromboplastin will be released. All of you tell me in the charts one thing, one step. After thromboplastin, what will come? Thrombokinase will come. Thrombokinase. Oh, Hollywood. Dora the Explorer. Okay, thrombokinase will come. After thrombokinase, prothrombin will come. Prothrombin with the help of what, students? All of you tell me in the charts. With the help, prothrombin will become thrombin with the help of what? All of you charts may quickly. Yes, quickly. Which ion is used here? Which ion? Is it calcium? Is it magnesium? Is it iron? What is used? What is used here? Quickly tell me. Injury, thromboplastin, thrombokinase, prothrombin, calcium. Calcium. With the help of calcium, it will become thrombin. Right? Got it now? Thrombin. Again. Yes, very good. Prothrombin, again with the help of calcium, will become what? In inactive form, fibrinogen. Again, fibrinogen will get converted to fibrin. That is how your clotting of blood will happen. Fibrinogen to fibrin. Okay? Again with the help of calcium. This is inactive, this is active. This is active. Okay, student, this is a cascade of reaction. Cascade of reaction means what? That means one reaction followed by another reaction. Okay, cascade of reaction like this. Like how your waterfall is. No, one step after one step after one step. So, one after one after one after one after other it will happen. Okay, please by heart it right now, Lee. Yes. Yes, all of you? Done? Okay, next one. Ready? Okay. Look here, students, blood group. Very simple thing. Antigens are substances that can trigger an immune response. Antigens are generally proteins, although some other organic molecules can function as antigen. Okay, ABO system and RH factor system are the most important clinically. RH factor was taken from a rhesus monkey, so that's why it's called RH factor. And when RH factor is absent, it becomes positive. Right, the blood group becomes positive. Okay, ABO blood grouping, we'll see, don't worry. Their antigen generates a very strong agglutination response. Okay, hemoagglutination response. Antigens of other systems are neither very weak or function at a low temperature only. Not very important for us, but just general information. Look here, students, blood grouping. Blood grouping. Okay. Hello, I understand Telugu. What nonsense? Nonsense are you people telling? Okay, look here. Blood group A. Okay, antigen present is A. Antibody is anti-B and the donors can be A and O. Okay, here blood group B, again antigen B. So you can see blood group and antigen will be the same. Okay, now blood group B, antigen B, anti-A, and B and O can give. A and B is there and it is nil. That means they do not have any antigen, do not have any antibody, and it can give to AB, A and O. Okay, that means universal recipient, it can take from anyone. Okay, then O, nil, anti, A, B and O. Okay, universal donor is there, universal recipient is there. Now, yes, I already told this, but anyways, students, look here. Factor 1 to 13. Okay, there are 13 factors which are actually contributing in blood clotting. Okay, okay, got it? Yes. Wow. Full poem and all that writing. Students, I don't have the energy to read your comments. Okay, factor 1 to 13, platelets 13 and 3 and 13 is released by the platelets. That means platelets will release the 3rd and the 13th factor, and rest of them are formed by the liver. Okay, rest of them are formed by the liver. Okay, no, I was telling nonsense for something else. Don't worry, not for the compliment. I did not even see that. Now I am seeing it. Ma'am, will you? Oh, ma'am, will you understand Telugu? I heard, ma'am, you do not understand Telugu. So that's why I told, what nonsense. Okay. So yes, fine. No worries. Sodium oxalate is sodium oxalate. Students, you know that blood will coagulate, right? Agglutination will happen. For that to avoid, what do this blood bank people do? They add sodium oxalate in the blood bank so that it will remove the calcium level, and because when calcium is removed, this cascade of reactions cannot happen. Simple. Okay, this cascade of reaction will not happen. Okay. Got it? Now, injury, thromboplastin, thrombokinase, prothrombin, thrombin, fibrinogen, fibrin, all of this step you can see calcium is required. So, the sodium oxalate will remove the calcium in the blood bank. So, platelets, that coagulation will not happen. Fine. Look here, this is the one. Tissue factor and fibrin stabilizing factor. This two will be released by the platelets. The rest will be released by the liver. Got it? Now, erythroblastosis fetalis is a very simple thing. What has happened? Imagine the mother is negative. Okay, the mother is negative. Mother is negative. And the baby that is in her, you know, she's conceived and the baby is positive. Okay, the fetus is positive. So, in the first delivery, okay, the first child, no problem will happen. Okay. Okay, listen. First delivery, nothing will happen to the child, because even if some blood vessel have entered with the help of placenta into the mother, that means some positive blood has entered, okay, into the placenta with the help of placenta. During the rupturing of placenta, if some blood has entered the mother, immediately the mother will start forming what? It will start forming antibodies against this antigen. Okay, the body of the mother will not know that it is baby's blood. The body will be like, okay, something negative has come, something foreign particle has come, so I have to make antibodies against it. This is what the mother's body or immunity will be like. So the first child will not have any problem. The first child will be happy and it will be out. In case second child also is positive, what will happen? Already the mother has a memory of this. So the mother's body will start making so many antibodies against this baby, and it will kill the baby, second baby. So to avoid this, there's something called as Rogam vaccine. Okay, I'll show you. So first, students, what happened? First baby, no problem. Okay, first baby, no problem, the baby is safe. But in the second baby, what is going to happen? The mother's body will start making many antibodies to kill this. Okay. So to avoid this, we are going to use Rogam vaccine, which I'll show you here. Can you see here? Some of the positive blood has entered the mother, and the mother has a memory of it. Okay, the mother have a memory of it. Yeah, that's what we have to give Rogam vaccine. We have to give Rogam vaccine. Okay. So here, students, can you see? The mother will have a memory of this, and because the mother has a memory of this, the second baby will be in problem. So to avoid this, we give a vaccine called as Rogam vaccine. What do we give? Rogam vaccine, which will remove the positive, which will remove these positive ones, no, which has entered the mother. They will remove that. Okay, Rogam vaccine will remove that, so the second baby will not have any problem, and this is called as erythroblastosis fetalis. Okay, clear? Okay, next is lymph. What is lymph? Very simple thing, students. Our body, okay, from the capillaries, interstitial fluid or some water, some dissolved substance, some proteins will squeeze out. Okay, from the capillaries, some water, dissolved substance, proteins will squeeze out, and this will be taken up by our lymph. This is the lymph. Okay, it will be taken up by the lymph. Can you see? Some water, some protein, some dissolved substance, see? Some WBC, some water, all of this will squeeze out from the capillaries, and that will all be accepted by the lymph, and that is called as your lymph fluid. Okay, so the interstitial fluid which is accepted by the lymph is called as the lymph fluid. So it is a colorless liquid, because obviously WBC is there, not RBC, so it will be colorless, and it contains ions, nutrients, hormones, proteins, WBC, and it is present in lymphatic system. Got it? Got it? Clear, all of you? Now, circulatory system. Two types of circulatory system is there, open and closed circulatory system. Is this clear, students? Can you all tell me in the chats? Is it clear? Yes, okay. See, open circulatory system means they have sinuses or spaces, and the entire body, all the cells will be bathing in the blood. Okay, bathing in blood. This is seen example in arthropoda. Cockroaches, all of you have seen. Okay, arthropoda. Clear or not? Clear or not? Yes. Okay. Yes. Organs are bathing in the blood. Very good. Example is arthropoda. Closed system means what, students? We have capillaries. Here capillaries are not there. Here we have proper network called as capillaries. Okay. So the organs properly through the artery, veins and capillaries, the blood will reach the point. Okay. Okay. Yes. Fine. Now look here, students. Heart of amphibians. So not every organ, every animal has 4-chambered heart, right? Amphibians have 3-chambered heart. So basically what is happening, there is a right auricle, left auricle, and in the ventricle the blood is getting mixed. That means deoxygenated and oxygenated blood is getting mixed completely. Okay, so because of this, this is the reason why they are poikilotherms. That means they can, cold-blooded animals, they can regulate their temperature depending on the outside temperature. Now fish circulation is very important because it's a single circulation. What is it? It's a single circulation. So look here, students, fish has only 2 chambers, right and left. Other than that, they have 2 accessory chambers called as sinus venosus and coronus arterios. What do they have? Sinus venosus and coronus arterios. So blood will enter. See, look here, from the body parts, deoxygenated blood has entered. Through the sinus venosus, it will go to the auricle, to the ventricle, and it will come out to the gills and again get purified and go to the body parts. So basically only one circulation is happening. Yes or no? From the body parts, deoxygenated blood got in, and in the gills it got purified and it went to the body part. That means deoxygenated blood is going around in a single circulation. So that is why fish shows single circulation, right? Fish shows single circulation. Okay, if I drink water also, it's not going to be fine. My breath has completely reduced. Okay, that's all. Water will not fix it because I'm continuously talking, no? So that's the reason my breath has reduced. That's all. Okay, now reptiles, almost all the reptiles have 3-chambered heart except crocodile. Crocodile has 4-chambered heart. Okay, 4-chambered heart. Yes. Now walls of the heart. Heart has 3 walls, students. Pericardium, myocardium and endocardium. So let's just learn a very simple thing about your pericardium, endocardium. Okay. Yes, listen here, the outermost layer is called as epicardium. Okay, epicardium, students, pericardium is given here, otherwise you can write epicardium. Okay, you can write epicardium and you can divide it into serous pericardium and fibrous pericardium. Okay, serous pericardium and fibrous pericardium. Then we have myocardium, which is the thickest layer. Okay, thick layer, thick cardiac muscle. And then we have endocardium. So students, try to understand, pericardium or epicardium is the outermost layer, which is made up of serous pericardium and fibrous pericardium. Okay, yes. Okay, fine. Then we have middle, myocardium, which is a thick cardiac muscle, and the last we have endocardium, which is made up of simple squamous epithelium. Okay, it is made up of simple squamous epithelium. Got it? And there is pericardial fluid also. Okay, there is pericardial fluid also. Is this clear? Yes or no? Please tell me in the chats. Simple epithelium. Yes, clear? Very good, awesome. Okay, so students, it's made up of simple squamous epithelium, serous pericardium. Now, there is a visceral and a parietal layer also. So, if I show the layers, it will be like this. Endocardium, okay, myocardium, thickest layer, and then we draw pericardium, fibrous layer, I'll show you the labeling, don't worry. Yes? Can you see it? I think it's too small. Huh? Is it too small? Or is it fine? Can you see it? Okay. Wait, I'll show a little more gap. I'll show. Wait. Students, this is myocardium, big layer. Okay, myocardium. After that, we have a visceral, this one, visceral layer. And then we have a parietal layer. And in between this, we have pericardial fluid. Okay. So, I'll label this visceral, parietal. Okay. Between whom do we have? This one, pericardial fluid. To absorb shock, right? Pericardial fluid. Then we have, which color? Serous pericardium. Then we have fibrous pericardium. Got it? This is the layers. Okay. Yes. Now the heart. Okay. Look here, all of you. Now look here, all of you. This is your internal structure of the heart. So many things are there. Don't worry. Okay, don't worry. What? Okay, look here. This is the heart. So here in the heart you can see there is a superior vena cava, there is an inferior vena cava. Superior vena cava will collect the blood from the upper part of the body. Inferior vena cava will collect the blood from the lower part of the body, and both of it will deposit in the right auricle, right? In the right auricle, from the right auricle it will go into the right ventricle. This is normal things I'm telling you, okay? And then you have left auricle, left ventricle. Now students, look here. What and all I have drawn? Superior vena cava, inferior vena cava, clear. Superior vena cava is positioned in such a way that they do not need any valves or any closing. But inferior vena cava is kept in such a position that it needs a valve called a valve of Eustachia. Can you see here? Valve of Eustachia. Okay, valve of Eustachia, which will cover the inferior vena cava so the blood does not come reverse. Because it's kept like this, blood is here, it can easily go reverse, so it has a wall of Eustachia. Fine. Then inferior vena cava also you saw, it's also called as post caval, and here it's called pre-caval. Okay. Now students, here we have an opening where all the blood from the heart, whichever used blood is there in the heart, no, all that will come. Okay, all that will come to the coronary sinus, right? Coronary sinus will take all the blood from the heart and it will to the coronary, that means to the right atrium it has to deposit, because even heart is an organ, heart also would have used blood, right? All that blood will be brought by the coronary sinus to the right auricle. Okay. Now coronary sinus also have a valve called the valve of Tebatius. Okay, Tebatius valve, that means the valve that closes the coronary sinus because it is present in the right auricle. Okay, so the blood can backflow. Okay, blood can backflow. Yes. Okay. Now students, other than that, you can see few things. Now, we'll go one by one. We'll go this side. Okay. Now, students, the partition that you are seeing is what? Interauricular septum, right? The partition to separate your auricles, interauricular septum. Then, here you can see a small bending like this. A bending like this. That is actually your fossa ovalis. See, look here. Fossa ovalis is actually a scar. It's actually a scar of the formation. See, that is from the foramen ovalis. Okay, it's a scar of foramen ovalis. That means when we were infants, our blood used to mix up. Okay, when we were babies, right? When we were babies, our blood used to mix up. But as we grew, that closed. That is why sometimes you would have heard people telling the baby passed away because there was a hole in the heart. What is hole in the heart? That means fossa ovalis or your foramen ovalis was still open. That led to the mixing up of blood. That has to close as we grow. Clear, students? Clear? Fine. Look here. Then, students, can you see here foldings? Many foldings I have drawn. Those have small ridges and large ridges. Can you see here? Here small ridges are there, large ridges are there. The larger one is called as the papillary muscles. Okay, so if I am drawing a ridge like this larger part is called as the papillary muscle. Okay, and the smaller one, this groove, smaller groove is called as your columna Shannon. Okay, that is your smaller ridge. Now look here, you have an intraventricular septum. That means separating the ventricles, you have a septum called as intraventricular septum. Is this clear? Now then, students, most important valves. The valves that separate the auricle and the ventricle is called as, all of you tell me in the chat box, is it tricuspid or mitral valve? Tricuspid or mitral valve? all of you tell me in the chats quickly. Tricuspid or mitral valve? See here, the valve between the right auricle and the right ventricle will be which valve, students? Here, this valve, which is this valve? Tricuspid valve, right? 3 cusps are there, tricuspid. See, 3 cusps are there, and that is your tricuspid valve. Now, look here. Here you have bicuspid valve. That means that one separating left auricle and left ventricle is called as your bicuspid valve or mitral valve. That means they have 2 cusps, only 2. Okay? Yes? Clear? Fine? Yes, very good. Tricuspid. I think the chat is slow. Okay? Now, students, can you see from this between portion there is connection to the papillary muscles. That is called as cornae tendinae. What is it called as? Cornae tendinae, to prevent any kind of backflow of blood. Okay? We have cornae tendinae. Yes. Look here. This is your heart diagram. Okay? We understood. Students, aorta, the main artery. Then we have pulmonary artery. Don't worry, arteries will do. Just understand now vena cava, sinoatrial node also will understand. Right atrium, atrioventricular node, cornae tendinae, right ventricle, left ventricle, bundle of His also we will learn. Left atrium, intraventricular septum. Okay, that's all. We have learned it all. Okay, only the veins I will tell you, vein and artery I will talk about. Now look here. This is the best way to study your double circulation. Very simple, students. From the lungs. Okay, from the lungs, the blood is going to the heart. Which blood is going to the heart? Oxygenated blood is going to the heart. Yes? And with the help of which vein? Pulmonary vein. Okay? All of you in the chats, quickly tell me if you understood. Yeah, look here. Lungs to the heart. Oxygenated blood is going with the help of pulmonary vein. From the heart to the lungs, deoxygenated blood is going with the help of pulmonary artery. The only artery that carries deoxygenated blood, the only vein that carries oxygenated blood. Yes or no? Yes or no? Fine. Now, this is called as pulmonary circulation. Okay. Now, that means lungs to heart, heart to lungs. Pulmonary circulation. Then, tissue to heart. Tissue to heart. Deoxygenated blood is going, that is from the vena cavas. Right? It is collecting from our body tissue, vena cavas. Okay. Inferior and superior vena cava. From the heart to the tissue, oxygenated blood is going with the help of aorta. Is this clear? Can there be a better diagram for this, which is called as systemic circulation? Okay? Clear? Yes or no? Can there be a better diagram for this to understand the circulation? Okay? Simple. Lungs, heart, lungs. Tissue, heart, tissues. Okay? Lungs to heart, oxygenated pulmonary vein. Heart to lungs, deoxygenated pulmonary artery. Tissue to heart, deoxygenated from the vena cava, inferior and superior vena cava. Heart to tissues, oxygenated blood with the help of aorta. Okay? Fine. And that's called as systemic circulation. Same thing is given here, students. See, you can see pulmonary circulation. I felt this was a little more complicated, so I wrote it with my own hands. That is better for me. Okay, I like learning with notes. So yes, right, see, you can see right ventricle to lungs, lungs to left atrium to left ventricle to, with the help of aorta to tissue, tissues to vena cava. Again, continue the cycle. Okay, this will be systemic circulation. Okay, systemic circulation. Yes. Now, cardiac cycle. What is cardiac cycle? Duration of one cardiac cycle is 0.8 seconds. Okay, it is 0.8 seconds. Now, a heart beats 72 times in a minute. All of you know this. A heart beats 72 times in a minute. Just know 0.8 seconds because we'll understand how that 0.8 second got scattered. Very simple, students. 72 times in 1 minute. That 0.8 second cardiac cycle is divided into 3 parts, or 3 events are happening in the cardiac cycle. What are they? Arterial systole, ventricular systole, joint diastole. That means articular systole, then joint diastole, relaxation. So contraction of arteries, contraction of ventricles, joint diastole, full relaxation is happening. Okay. So look here, both the atriums are contracting. A systole means what? Contracting. AV valve opens. What happens? AV valve opens. Clear or not? What is happening here in the chats? Yes. What are they talking? I am taking so much breath and I am teaching, and you people are sitting and talking. You don't want my class. Shall I end the class? Tell me in the chat, shall I end the class? Okay. Now, root of great veins. Students, great vein are your vena cavas. Okay. Now, understand here, lub sound is coming. Okay. Lub sound is coming. Can you all stop getting distracted? Okay. So, students, closing of the great vein here. One more point to add. Closing of the great vein. Great veins are which and all veins? Both the vena cavas and your pulmonary vein. Okay, closing is happening, lub sound is happening. Then this is 0.1 second, only 0.1 second arterial systole will happen. Then blood will go. So both the ventricles will contract. Arteries contracted, blood will go where? To the ventricles. Now the ventricles will contract. Okay, ventricles will contract and semilunar valve will open. Here AV valve open, here semilunar valve will open, and dub sound will happen. Okay, this dub and lub I'll tell you. So this ventricular systole is for 0.3 seconds. Ventricular systole is for 0.3 second. Got it? Yes or no? Semilunar valves opened? Yes. Both ventricles contracted. After that, look here. After that, here dub sound has come. That means the valves has to close. Here AV valve opened, then closing happened, lub sound came. Here semilunar valve opened, here closing happened, dub sound came. Whenever the valve closed, sound will come. Whenever the valves open, no sound will come. Okay. Now, from here, joint diastole is happening, which is for a longer time, 0.4 second. So 0.4 plus 0.37, 0.18. 0.4 seconds. So here what is happening? Relaxation of both the atria and ventricles is happening. Okay, and it is closure of semilunar valves. Okay, that's what I told you here, dub sound. So semilunar valves are getting closed and 70% will be filled in the JD. That means what? The blood will be filled. Main filling will happen in the ventricular filling will happen 70% in the joint diastole and 30% in the atrial systole. Okay, this you have to revise. You will not understand if you listen one time. Okay. Now, here students, I actually asked a question. Dub to lub, how many seconds it will happen? So, most of the students told 3 seconds. But that's not how you do it. Dub to lub means you have to go in a cycle. So, dub to lub. That means 0.4 plus 0.1. 5 seconds. This question can come 0.5 seconds. Okay. Now, look here. During each cardiac cycle, 2 sounds are produced, lub and dub. Let's see which is that. The closing of the atrioventricular valve, first sound, lub sound. Did I say you now? AV valve opened in the arterial systole. After that it closed, causing lub sound. Okay. Then semilunar valve opened. Right. Look here. Closing of the semilunar valve created the dub sound. Semilunar valve opened during the ventricular systole and it closed, dub sound happened. Okay, got it? Yes. Now look, difference between artery and vein. Carry blood away from the heart, carry blood towards the heart. Pinkish or bright red in color, deep red in color. It's not green or blue. It's actually deep red in color, right? So that is it. Then look here students. Blood pumped by heart in 1 minute. We have to do a calculation. Very simple. Heart rate into stroke volume. Stroke volume. 72 into 70. Stroke volume you have studied in your breathing and exchange also. Right? Stroke volume. Yes or no? Lub and dub. Thank you, Madhu. I have a lot of patience. Yes. Okay. So students, here stroke volume is basically the volume of blood ejected during ventricular systole. The blood is ejected during ventricular systole. So 72 into 70 is 5040. So approximately 5 liters per minute. 5 liters of blood per minute. Clear? Just know the number. You will not be asked for calculation. Now look here students, next one is how does the heart is, see now when we learned about muscles, we learned that muscles are there, sarcomeres are there, myosin is there, actin is there, all these people are doing all of this. But here who is the one that is controlling the heart? Who is the one who is actually doing all of the job? Simple thing, 3 people are doing the job. In that one is called the pacemaker of the heart. Many people would have heard in India also pacemaker. Okay, pacemaker. I got my pacemaker replaced with an artificial one. That means what? The person who is controlling the entire heartbeat, right? So it's SA node, AV node, bundle of his and Purkinje fibers. So look here, SA node is called as the sinoatrial node, also known as the pacemaker of the heart. Pacemaker means what, student? Who decides the pace of the class? I decide the pace of the class. That means I know how fast and how slow I have to go. Pacemaker. Same way, this sinoatrial node also will know how much beat, how to control the heart, right? Yes, look here, sinoatrial node. From the sinoatrial node, if you see, AV node is there. AV node is present where you see, where your, obviously where your atrioventricular, this is there, septum is there, right? So valve is there, sorry, valve is there. So AV node is atrioventricular node. From there you can see extension is happening to bundle of his and then to Purkinje fibers. Purkinje fibers are spread all over the ventricles. Can you see here? Purkinje fibers are spread all through the ventricles. All through the ventricles. Okay. So simple students, SA node, the head, the principal. SA node will tell AV node, you do the rest. So AV node will control and send signals to the bundle of his, bundle of this to Purkinje fibers. So you have to remember SA node, pacemaker of the heart, AV node, bundle of his and Purkinje fibers. Now, next is electrocardiogram. Ready? Electrocardiogram. So students, pacemaker what does what? Basically they regulate, right? Regulate. Yes, ready? Okay, fine. Students, look here. P, Q, R, S, T, P. So this is basically a wave. This is an electrocardiogram. So if this is a person, any 3 points, okay, maybe tip of both the hands, and on this leg, they can do a triangle like this and they will keep moderators to do the ECG, electrocardiogram, okay. It was found by Enthoven, was the person who found electrocardiogram. Okay. Now, electrocardiograph is the graph that you get. Electrocardiogram is the machine that we use. Now, electrocardiogram or electrocardiograph help us to understand if there is any problem with the heart. If there is heart murmuring, we say heart murmuring, that means difference in the lub and dub sound. So, all that we will be able to understand, but its frequency or that wavelength has to be that high to also understand. Okay, let's try to understand only with this. So students, what did I tell? Let's label this. This is P, Q, R, S. Okay, now just know this P, Q, R, S, T. What is the first one? Can anyone tell me? It will be arterial systole. All of you know this? I taught you last time. Arterial systole. This P is formed, no? This will be arterial systole. This will be ventricular systole. Ventricular systole. Or in other words, we can also say ventricular depolarization. Depolarization. Here also we can tell atrial depolarization. So this is very complex topic, depolarization. So that's why we'll not go into depth. You just have to know the terms. That's all. Okay. And here this will be ventricular repolarization. So the biggest curve, the wave will be what? QRS, right? QRS. Very good. Ventricular repolarization and depolarization. Very good. Very good. Okay. So which is the most high amplitude? R is the most high amplitude and S is the least amplitude. Okay. R is the highest amplitude. S is the least amplitude. You can ask the question, ma'am, why is JD not recorded or why is joint diastole not recorded? It's because joint diastole does not make that much of an amplitude to get recorded here. You have to make that kind of an amplitude to get recorded, right? That amplitude is not made by the joint diastole. Clear? Yes. Now disorders. So coronary artery disorders means what? Also known as arteriosclerosis. Okay. Caused by buildup of plaque. Okay, that means calcium, fat, fibrous tissue. A person who eats a lot of meat, that too red meat, right? That person will have chances of getting CAD. That is because plaque accumulation or fat accumulation on the walls of the artery, right? The lumen of the artery is already narrow. If it becomes more narrower, then it will be difficult for the blood to flow, right? So makes the lumen of the artery narrower, affects supply of the blood to the heart muscle. So a person who eats a lot of red meat also have to do that kind of an exercise. Okay. Yes, it's almost done, students. I know your mobile battery is, my life battery also is getting over. Your mobile battery also is getting over. Now, angina pectoris, also called as angina pectoris. That means heart attack, also known as angina pectoris, not enough oxygen reaching the heart muscles. Now that is the condition for me. Oxygen is not reaching the heart muscles. Okay. Now symptoms is acute chest pain, can occur in men and women. Okay. Acute chest pain you will feel. Then myocardial infarction, also called as, okay, plaque ruptures and causes blockage. So what happens, students? We saw plaque in the CAD like this. Now that plaque will rupture and it will block like this in the middle. This will cause to sudden death also. Okay, this can cause to sudden death of cardiac muscle tissues. Okay, this myocardial infarction can lead to sudden death. I'll show you an image. Look here. Can you see the image? See, coronary, here what has happened? Here, like this accumulation has happened. Here what has happened? Both the sides, angina pectoris, both the sides fat has got accumulated. Still there is a flow in the middle. Here you see what has happened. This one blocked and cracked. Okay, and the entire death of cardiac tissues have happened. This can lead to a sudden death of a person, myocardial infarction. Is this clear? Any doubts? Any doubts? Tell me quickly, any doubts? We are done with the chapter. Last topic. Done? Any doubts? Please tell me now and now and now and now. No, right? Clear? Yes. So students, again, your last opportunity to join to the crash course, and you can see here, view the course plan. It's only for 1,000 rupees. Okay, the course has started. This is only for 1,000 rupees. Here, can you see here? So live class by master teachers, quizzes will be there, leaderboards will be there, previous year questions will be there, everything will be there. You'll also get some book, see, digital study materials, you will get assignments, you also will get Tattva PDF in this batch, which is 1,000 rupees. So quickly go enroll. The link is in the description box. Quickly go enroll. So yes, students, that's the end of the session, and okay, so that's the end of the session. And if you want the test series also, it's completely free. You already would have watched that video. Go enroll right now and get to know your rank and which college you can aim for, what is your mock test marks. Okay, so students, that's the end of the session. If you have any doubts, please rewatch the session anywhere. And I've also done all these chapters individually, taking 5 to 6 hours, so you can go check that also. More details will be there. Okay, so thank you so much. I'm hoping to see all of your comments and like on the session, because definitely it is almost 7 hours I'm standing here and teaching, and I think the only reward that I expect is your likes and comments, because it motivates me to do better and better and better. So yes, thank you so much for joining. Love you all. Take care. Keep hydrated and prepare for your exam. Human Physiology 3 chapters are done. Chemical coordination I did on Wave platform. Now we are only left with neural control and coordination, breathing and extent. Again, I'll take it on the Wave platform, not on YouTube, because YouTube I have done one shot video. And biotechnology we'll be doing in block 2 strategy. Block 2 that will be coming very soon, mostly by Saturday or Sunday. Block 2 will be having, and we both will be doing biotechnology one shot. Okay, principles and application in the same class. Okay, thank you so much, students. Take care. Good night. Thank you so much for joining, and it was nice, very interactive class it was. I really enjoyed the class. I didn't feel it was so tiring. Okay, so yes, bye bye, take care.